show. Watch me as I go. Should've looked both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on. Hey, hey, I'm moving on. Hey, got nothing left to say. Let's be on my way. Best of luck. I'm moving on. Oh, I'm moving on. I'm moving on.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. Formnext spearheads into day 2, and here is a small recap and outlook. Yesterday at the AM4U stage, the top female leaders of 3D printing came together in an interactive panel and discussed intensively about industry applications. Several ladies from the community offered their insights on career opportunities for women in additive manufacturing. Another highlight was an exciting unveiling ceremony. Uila's world premiere attracted a huge crowd of spectators from all over the fair premises. Uila is a prototype combining an e-bike and electric vehicle, featuring a chainless electrical drivetrain designed by Berlin-based innovation studio and Frontier. Presented in cooperation with 3D printing partner Stratasys. Bottles of sparkling wine popped at the Permundus Challenge 10-year Jubilee celebration, where winners from the past decade reconvened to celebrate the uphill evolution of additive manufacturing. Thomas Luc, Head of Innovation and Sales at Curb, explains the thought behind it.
The Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Oh, definitely.
Yeah.
Definitely they have. And that's what this retrospective view of the different winners of the last 10 years really show. That there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well at the applications as how to combine material and process, as how to make a really good design. And because at the end it's a design contest.
At after-work talks presented by Frank Jablonski, Petra Harburger, president of Messago, emphasized upon the importance of spreading the network of additive manufacturing. The talk round discussed the development of the AM market internationally, in particularly about the United States. Doug Woods, president of Association for Manufacturing Technology, said,
"We have a really big market already, so it's easier for many of our new companies to get started and have sufficient market just in the United States. But the reason they come to things like Formnext, it's in as much they want to be able to prove that they can sell their products in Germany and Europe, because that's pretty difficult sometimes for smaller, medium-sized American companies. It's as much this event. This event is the premier event. If you want to show off that you're great in anything from materials all the way through to service bureaus and everything in the middle, for additive manufacturing technology, you want to show it off here."
How was the mood at the fairground? Spread across 4 halls, exhibitors from all over the globe have set up colorful stalls displaying the creme de la creme of 3D printing technology, which drew in thousands of 3D printing enthusiasts. Our camera team picked out some trends and product reviews for you. Munich-based Fraunhofer Institute for Technological Trend Analysis have put up their powder nozzle tech up for display. Engineer Moritz Greifsue lists out the nozzle's top features.
So that is a nozzle for additive manufacturing. The special thing actually is this little box here, which is screening the powder cone. So it's characterizing the quality of the nozzle. So we could detect, for example, if there's any abrasion or something like that, we would have to change the nozzle, because its lifetime is over, or there was some clogging or whatever.
Next, we have the Heron, an industrial robot AM cell produced by Caracol. For its production processes, the Italian 3D printer manufacturer uses extrusion 3D printing technology, designed with an approach based on applications in mind. The technology already combines over 29,000 hours of printing and has found intensive application in industries such as aerospace, automotive, energy, marine, and more. It can process a wide range of polymers and composite materials in pellet form.
To the aerospace industry, we are working today mostly with molds, trimming molds, lamination molds for composites, for example, but we are also looking at functional application in the future. So we are engineering new materials to move from tooling to functional parts. That's the big bet of our company.
RevoPoint Pop 3D scanner is designed with binocular structured light and uses reverse engineering. The scanner ensures that the 3D point cloud data is on point. The highest single frame accuracy can reach up to 0.3 millimeters. This device supports both high precision and texture scanning modes, used to generate vivid 3D models for color 3D printing. The Evotech stand houses a ginormous drone, built keeping lightweight technology in focus. Lucas Meinhardt shares with us its central hallmarks.
Yeah, we got here a very interesting drone because most of the parts are 3D printed and are designed just for the 3D printing process. So you can see here, we got here a very lightweight design and it's printed with carbon fiber film filament. So it's very strong and yeah, it weighs about nothing, so it can carry a huge load.
Now on to some pointers for tomorrow's upcoming events. Make sure you do not miss these. Keep your eyes peeled for exciting presentations by partner country France in the afternoon at the AM4U stage in hall number 11. Here also, visitors can attend the Discover3D Printing Seminar, sharing knowledge about basic technology aspects of additive manufacturing. Last but not least, we have the BEAM Symposium at 10:30 a.m. at the Portal House at the Frankfurt Fair Room, Frequenz 2. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Hi guys, this is Marion from Formnext TV. We are here at the booth of Nexa 3D. They say they make polymer 3D printing ultra fast. So let's check it out.
Nexa 3D is all about ultra-fast, high-throughput 3D printing for prototype and production applications. So the Zip, because it has those industrial capabilities, is actually a very versatile printer. It's a great entry point into 3D printing in terms of a desktop 3D printer for prototyping and design, but also you can build a zip farm, and that's actually what we're displaying today, where you have several zips, and you can use that for high-mix, low-volume manufacturing applications as well. The NXE400 Pro is our industrial or commercial grade 3D printer. Both it and the Zip are powered by LSPC technology. That stands for lubricant sublayer photo curing technology. This technology uses a UV LED light source that then goes to an imaging mask. We use an LCD screen. It's monochromatic and it's 4K resolution. Think of it, everywhere where it's black is going to block the UV light, everywhere it's white is going to let that light shine through to evenly and uniformly cure the entire layer at a time down to the pixel level. So that's going to mean high quality, high detail, and excellent resolution down to the pixel level for each print. What really sets this technology apart though, the unsung hero, is our membrane, the Everlast 2 membrane. That membrane is self-lubricating, and that's a key component of our technology. And that allows you to overcome some of the typical physics associated with the 3D printing process, reducing and eliminating peel forces so that you can leverage the full speed of the technology. We're able to print up to 6 times faster than most of our competitors. This printer is all about high throughput, so it's really geared towards high volume prototyping, maybe for like a service bureau or contract manufacturing environment, or typically production applications. So all of our 3D printing technologies, from the desktop zip all the way up to the NFC and QLS for industrial applications, are all about ultra-fast, high-throughput 3D printing. That's important because that's going to allow you, whether you're doing high-volume prototyping or even moving into production, achieve a low total cost of ownership and a lower cost per part, which enables you to move into production applications that you may not have been able to do otherwise. The second is large build volumes, so you can fit more parts or larger parts than a lot of other technologies, particularly for the resin-based printers. And lastly is going to be materials. So we have over 30 validated materials, and then it's also open source systems. So this enables you to use your own materials as well. This, along with the high throughput, mean that this is an investment that you can make, and it's going to continue to pay dividends for years to come.
Fraunhofer, and this is Moritz. Moritz, tell us, what do we have in front of us?
Okay, so that is a nozzle for additive manufacturing. The special thing actually is this little box here, which is screening the powder cone. So it's characterizing the quality of the nozzle. So we could detect, for example, if there's any abrasion or something like that, we would have to change the nozzle. Because its lifetime is over, or there was some clogging or whatever.
Why is this product going to be better for the market in terms of, sure, it saves time, but how is it in terms of quality?
Yeah, you know, from my point of view, AM is maturing, meaning a lot of people are trusting these processes more, and that's the point where we have to step in to ensure quality. That's what I believe.
Welcome to the second day of Formnext 2022. I'm happy to have you here in our live stream and here at our stage in AM4U stage in Hall 11. Yeah, yesterday was the first day full packed of information and new products and new insights here on stage and all around the fair. Today you can expect an interesting program again. And now we want to start into the exhibition day with our morning talks, and I'm very happy to have 2 Insight guests here. Next to me, Markus Hering. He's VDMA Managing Director, Trade Association and Working Group Additive Manufacturing.
Right, good morning.
Good morning, good to have you here, Markus. Rainer Lotz, he's President EMEA of Renishaw, exhibitor and member of Formnext Advisory Board.
Good morning.
Good morning. Good to have you here. Rainer, short review. How was the trade fair yesterday for you? And did you have some highlights you want to share with us?
Well, yeah, it was very good. We had a very fast start, and we could see that the visitors were extremely excited to come to the show. So we were placed in the front of Hall 11, and honestly, in the beginning, we couldn't cope with the number of visitors we saw coming of us. It was interesting to see the excitement of the people to know about details of the technology and what it can do for them. And it was also very good to see that you see very senior people coming here. So you see people, you see designers.
Decision makers.
Decision makers, exactly. And we had yesterday decision makers on the booth from aerospace, from very big plane manufacturers. I don't want to name anybody, you'll understand. But also, obviously, for the traditional machine tool, from medical sectors, from the powder sectors. So it was a very vast variety of visitors. Really decision makers on the booth and great excitement. So fantastic first day. We're looking forward what's coming next, and I'm sure we're on a good track.
And did you have the chance to go around to visit the other halls, or was it so much at your own booth that you had no chance to walk around?
I have to be honest, I didn't have the chance yet to walk around.
That's the same every exhibition.
I want to take the advantage because you can see we're over 800 exhibitors. It's the show becomes back, to old strength after COVID. But I didn't have the chance yet. But I certainly will do that probably today or tomorrow.
Markus, you have a booth here as well as VDMA. What was your impression? What was a highlight for you yesterday?
I can confirm what Rainer said before. It was a really good day, and I had the chance to walk a little bit around because I would like to visit my members. They are placed in the halls, and I would like to receive the answer about their impression. How is the fair for them? And everybody said what Rainer said. It's really good, high quality decision makers, and really for the first day it was also awesome that so many people have been here, and we expect today and tomorrow also will be real good days. And Friday is the last day. It's usually the day where the exhibitors meet each other. So we will see. Yeah, really good first day.
Okay, and the highlights you occurred from maybe the one or the other product that was exhibited, or a lot of exhibitors, they have short shows or clips and highlights at their booth. Was there something you could say to our spectators they should have an eye on?
As an association, I have to be neutral, and I am neutral to all members. But what I can say is
you can just speak as your.
As a private guy.
Yeah.
Now, but what I have seen this time is we see in more and more industrial products, what are really used for industrial application. And this is a trend. If you compare that with the last shows, you see this is becoming more and more important. You see also the dimension are getting bigger. And I guess this is a trend what you can see, especially this year, that the applications, the technical products are increasing. And that is important for our industry, because we need more technical applications, we need more success stories. And that is what also we try to show at our booth in the user case area, examples from the industry where you can see where additive manufacturing is used.
So these are crystallizations point where the ideas come, okay, that could be something for my business as well, right?
Yeah.
Rainer, you wanted to say?
I would like to underline that, because if you go a couple of years back and you looked at the parts you could see everywhere, it was like a gimmick. Sometimes, you build a little Eiffel Tower, you do this and that, so it was fun to see, but it was a bit of a gimmick. When you look today at it, and I would tell the visitors, watch out the quality of the parts, watch out everywhere. It's a very serious quality we have in the parts, and most of the exhibitors, they have serious industrial applications with true customer parts where you see the added value of additive manufacturing. And that's probably the thing to underline. Of course, there are new products, but for me, the highlight is the quality of the parts, and it's real industrial parts with added value. That's really great to see.
As a member of the Formnext Advisory Board, give us an insight how important it is to have the whole process chain here at the exhibition. What do you see here? Is there an improvement, or is it a stagnation?
No, we see improvement, but we have to be a bit modest on the speed we're traveling in this direction, I have to say. Of course, we also know efficiency is the entire process chain at the end of the day. It's not enough to have a high quality printer and a good quality part. It's also how much post-processing is needed after, and can you handle it automized, can you handle it semi-automized, do you have a full total quality, so no scrap at all? How can you guarantee, how can you document the quality of the part and how can you verify it. So we see improvements, but obviously like 5-6 years back there was a hype where we thought this is an easy win. It's not. We have to work on it step by step, but you do see in the handling and in the verification of quality, you see improvements.
Is there a missing link you're seeing where we can make a big leap forward, or do you you have the stage here? You can say, okay, we need some body or something.
I wouldn't call it missing link. I think the links are all there, but they're not all mature yet. The links. So if we look, let's compare for a second with the subtractive technologies, milling and so on. And there we obviously already look in closed loops, where you have a part coming off the machine, you have verification either during the process or after the process, and the results are going directly in the loop and are helping the controller of the machine to correct immediately, to stay always within tolerance. So no scrap at all, and you save energy, you save raw materials, you save machine hours. So this is where we are with the subtractive technologies. Additive, we're not there yet. So we also, the knowledge and data we get in the verification, we need to better feed them back into the printer, that we can eventually fully automized correct all parameters, that we always print good parts. That must be the target.
So we are full in the topic of digitalization and of connectivity. We yesterday had that topic here on stage as well, and I had some American guys here, and they said with a smile on their face, okay, we are a bit different in US. We are a bit more fast forward. We are a bit more, we try and fail and try again, and. They didn't say it, but you could hear it between the lines. You Germans are a bit behind what the mood and the thinking is, and you hear it from the machinery industry. Sometimes we have to serve our customers, and don't bother me with digitalization. Now they have everybody has a digital product like an app checking their machine, but it's not really digitalized to the ground. Not every sensor sends his information to the cloud, and there is an AI working on it and sending it back to the printer or whatever, to the machine, which makes the process better. Where are your companies standing there? Would you agree the American guys, or would you take an opposite?
Not the real opposite. I guess there is a truth in behind. So the Americans like to try something, and if it's not running, they try another thing. But on the other side, we as Germans or Europeans, we have to say we have a working system, we have a running system. And this is very successful, what we have done with machines and technology. So we have to be very careful if we implement new technologies. Especially for IM, we are competing with traditional production methods. And it's important to be successful, to be honest to the customers. We have to tell them what is possible, what is not possible. We have a big pressure on costs on the products at the end of the day. And if we implement, that is also what I would like to add to the missing link. So I like to see that we go step by step forward, and we do what is possible. And if we're looking back
in the German way,
but if we're looking back within the last, I would say 5 to 10 years in additive manufacturing, what we reach now, and Rainer mentioned before, you have seen those gimmicks products here, and now you have real technological products what are used for applications, for technical applications, day by day. And this is the right way to do. And then you're receiving also trust from the customers, and they see, okay, additive is working, and then we have to do it. And digitalization is a part of this story. Without digitalization, additive wouldn't work. So it's really important and necessary to do, but we have to put the companies together, we have to find common solutions, we have to find standardized solutions for digitalization, and that is what especially we as an association are working on. And it takes time to do this.
So you have not the fear of missing a train here? Your statement is we have to go step by step, and then we will succeed.
It's my way as an engineer. I would like to see what is coming out at the end and not try and error. And I guess we have been very successful with this method for the last 100 years, and I'm sure that it's the right way to do.
Rainer, do you agree?
I agree. I adore the American way of try and error. I think it's very exciting. But, fast thinking is one thing. to be fast in finally doing it right is another thing. And I think in additive, try and error is a bit dangerous because you might have some good results, but you don't understand why you have the good results. And we talk in production, like Marcus mentioned, we talk about consistency, we talk about quality, we talk about stable processes. And they're only stable if you exactly know what we're doing. And that's the difference today. When I go around, I speak obviously also to the other exhibitors as a member of the board here. And the good thing is, most of them really know what they're doing in the meantime, and they know exactly where the challenges are, and this helps to stabilize the whole thing. So repeatability, verified quality, all this you need, and you don't get this by try and error. And therefore, I agree with Marcus. We have to sweat the details step by step. It's sometimes a bit boring, but for us engineers, it's very vital because it's stable and it will be sustainable and successful.
Okay.
And let me add one thing more. If I'm looking to our customers, the final users, they have to trust the procedure. And if you fail once, they are not convinced and they stop it. Maybe the Americans are different, but the Europeans are in this way. And we have seen that in some cases at the beginning of additive, that some people tried, it was not successful because they have not foreseen what it means to use additive, and then they stopped it, and they said for a while, it's not working.
But couldn't be digitalization and the sort of connectivity we need to connect the different, experts and expert products together to just be the case to make these obsolete, these problems?
It helps to do that.
So you are an expert in measuring, in control, in looking in quality control, and so wouldn't it be good to to have an in-process control that you make sure that the failures just do not happen because you control the process itself?
Absolutely. If we look at it, how we work today, we look at the full picture. And the full picture does include in-process control. So we do have additive machines with in-process control, but we also have post-process control, and it has to come together. And this is when I look at our AM experts today, they're not focused on one discipline printing that part. In our solution center, you always have the full process chain, and you have specialists, they fully understand the process chain. So we have AM specialists, they also understand milling, they understand measuring, they understand to correct the lasers inside the process. So you need these people, they understand the full picture, because exactly like you said, you have to bring everything together for the final success.
Do we see enough of these companies who bring in hybrid products? I'm talking about machines here on a Formnext, or would you say that it would be good to have some of these? Every machine vendor, not every for sure, but a lot of machine vendors, they have hybrid machines, additive and subtractive combining. Do you want them to have them here, or do you say it's a different approach? We don't need them necessarily.
I think everybody who is not only doing additive, who embeds additive in factories should be here. So it could be somebody else, not
there
printing.
Are enough halls in Frankfurt.
Exactly, because it's plenty of space here. They should be all here because we talk about a versatile, modern factory where obviously all the kind of technologies have a place, but also digitization, as you said, have a place. Digitization is happening, and obviously we have to make sure also, like Marcus said, the trust of the end user, the customer, is very important. And also we have to present the digitization. In the old days when we talk about Industry 4.0, and so a medium or small-sized company looked at it and said, oh, I cannot apply this because I have no IT specialists on my shop floor to work on this. And this is then our job to make it approachable, to make it attractive and easy to use for them, that they immediately get the benefit without having a shop floor full of IT specialists. So it's our task to present it to them in a way that they can add value to their factories. And I think there we need all of them. So everybody who works on the modern factory and who has either an interface to additive or combines in hybrid machines, that they should be all here. And obviously, if you want to have a hybrid machine or you have two machines aside, liaising in a perfect way, it's a bit of a philosophy, and I think it's probably too short now to dig into that topic.
But do we have enough of these high-skilled people or people who are focused on software and solutions?
Of course not. We never have enough of them. That's the problem.
I think that's a real problem.
We have not enough of them. We have not. That's the short answer.
And it should be a political, we should talk about that political, how can we get into Germany or to Europe? People, they are willing to work with us on that topic. You know, we should talk to the American guys, how can we get the experts, the software experts here to Europe, isn't it?
Our resource here, I mean, we all know that, is brain. That's our resource. And everything built in this country is built on brains, on engineering, and therefore, we're not having enough. I think we agree, and that's also of the VDMA and the associations, obviously their goal to help us in the industry to excite more people about that, to come into technology, into engineering, and to be excited about the new moves into digitization and not dreaming of working for TikTok or something. So that's our job, and we see little progress, but we want to do more because we need more brain, we need excitement. And I tell you, it is pretty exciting what you see happening here in manufacturing.
Let me add, I guess we have some different challenges in this sector. So, of course, we need more IT specialists for digitalization, but we also have to qualify the existing stuff because we have a lot of engineers who are now 40 years, 45 years old, and they don't have the experience in digitalization, but it's needed, and they have to work for 20 or 25 years in the future. So this is the other challenge what we have. I guess we have too less young people. The next generation is too small. That's what we all know. We can bring them from other regions to Europe, of course, and this is a political issue, is still on the table. But the other issue, what we have as an industry, is to educate, learning the whole life, the people what we have in production technologies, in digitalization, and this is a big issue what we are working on, and we try to inform what is still possible. And also the next generation, when they starting the education procedure, just bring them on the level what we need as industry at the end of their education process.
And the exhibition is, or the fair company, Mesago, is doing its own part. We have a 3D, Discover3D printing seminar here on stage every day. So there you can get young people into the topic of additive manufacturing, and it's a learning seminar. So you get really a lot of insights here, and maybe the one or the other of our spectators zoom in here in the fair or on the live stream. We will show that.
I would suggest to Formnext even a step further. When I look at us, we invite kindergarten kids. Whole kindergartens into our factories to show them the printing, to show them the milling, and also at our headquarters we have girls' days because it's always underestimated to excite technology, to excite girls about technology. And so we have girls' days where very young girls get in and we show them the excitement around it.
We had yesterday here a very interesting round of women in 3D printing. So,
but we should get, you can get honestly 6-year-old, 10-year-old here and excite them already for technology, to excite them and give them an idea how they can change the world being a part of this.
Let us switch the topic, because I want to take the time we have left for an interesting survey you made with VDMA. I just want to show a slide if you give me the time. And you brought the member survey, hot off the press, what I learned, and the one topic that caught my eye particularly was where is your company likely to use the largest proportion of additively manufactured components in the next 12 months? And I will show you the slide here. No, that is a different one, but that's interesting as well. I have two. I'll show you the other a minute later. Here's the topics relevant for AM sectors, and you see cost. It's all about cost.
Absolutely.
We mentioned that earlier. We have to cut the cost. You said it. And the second, technology development. I'm very impressed of these two, because cost is a problem since we talked about first about additive manufacturing. We are too slow in getting results here.
I wouldn't say we are too slow, but it's the expectation from the users is still that it's too expensive if you compare cost per part with traditional methods. And this is, of course, it's a challenge. On the other side, we see the benefits of additive, and we have to compare the cost with benefits.
The second part is technology development, and that is linked to it. So
it's linked to each other, yeah.
You have a problem with technology development, so that's not a really good saying here from your members.
No, I wouldn't say it's a problem, because that is what they see, what they have to do. So it's a mirror of the market, what they receive from the customers. So they see we have to be more cost effective, we have to be quicker. It's also process speed is directly linked to costs. If you're quicker, then costs going down.
And stability is a problem too, so that is again cost related.
It shows us that they know what the market needs. And they see they have to improve development in technology to solve these issues. So for me, it's crystal clear what they do and what they need. It's not the problem, it's looking forward for the solution.
So how can we deliver?
I think it's also important with the cost, perhaps to add this. We have areas where cost per part is absolutely competitive. You know, when we look in the medical areas where it's and also the customers learn to look at the total cost of ownership. So if you have other principle where you think the cost per part is cheaper, but then you realize, oh, I have to make at least 500 of it with this procedure, and in additive I can make single parts and can do verify these single parts, so the total cost is different and lower, and they learn now to look at this. So obviously you have to be very selective where additive adds value. You have to be selective. It's not the holy grail of manufacturing, but the end users learn this more and more. But cost is an absolute driver, there is no doubt.
And it's directly linked that it's used more and more for industrial applications. Therefore, it's also the pressure coming that you have to look on costs.
We are a bit running out of time. So I skipped the second page I wanted to show to you, but we take the time. Where can somebody who is interested in the whole survey can have access to it? Is it on the pages of VDMA, or is it openly for users?
It's on our homepage, and also you can contact us, and then you can get the results.
Okay, perfect. Thank you very much. Yeah, dear visitors, and dear attendees at home, that was fast forward here. Time's running fast. Sorry for skipping the missing page, but you will find it on, as we said, on the website. And now we have to start into a very interesting topics here on stage. The next we will have here is in cooperation with Beam of TU Darmstadt, a lecture, construction and architecture. And I wish you a very successful start in the second day, and we see you later.
Welcome to this exhibitor focus on Formnext TV. We are here at Discover3D to learn more about their metal printing solution.
Discover3D is a metal additive manufacturing technology company that is focused on allowing our customers to print the parts they really want to print, and to do so as they scale into production.
Can you tell me what exactly makes the Sapphire family fully integrated?
So the Sapphire family is really part of a system where the system includes not only the hardware, which is the Sapphire family of printers, but also the software. Both the print preparation software that you use to prepare a file for printing, and Assure, which is the quality assurance and control software that's used to give insights into the machine, into its operation, and into the quality of parts. So with that entire system, you have this integrated end-to-end metal AM solution.
In the industry, process reliability is a very important issue. How does Discover3D reach this goal?
Yeah, process reliability is critical. And one of the main things that we do differently than other systems is to provide this fully integrated metal AM solution. So that really starts with calibration of the system. You have to make sure that the machine is properly calibrated every time you start a print, in order to know that the output of the print is going to be good. And then we also have the software on both the print preparation and the quality side. So you have a continuous digital thread from basically the CAD file to the final printed part. So that helps as well whenever you're looking at the process reliability and being able to validate that a part is good at the end of the day.
What else makes the Sapphire printers different to conventional printers?
So a lot of our customers are able to use our systems to print parts that they would find very, very challenging on other people's systems. That's mainly around the geometric complexity that you can print, some of the low angles that we're very, very good at printing. And then also on the metrology side, I think we have the most complete set of metrologies built into the machine that allow the customer to have insights into all of these things that we talked about previously, the calibration, how the build was executed, and the final print quality.
Your printer family includes 4 different printers. I'm just wondering, what applications do they cover?
They cover a wide range of applications. We have customers that are printing parts from a variety of different industries, whether that's aerospace, defense, automotive, tooling, power generation, oil and gas. They really are useful across a wide range of different applications. And it really depends on kind of the size of the component that you're trying to print. And that's kind of what drives the decision between the different Sapphire printers.
We're here at 3D Step at Formnext. Welcome, Pekka. Tell us about the services that you're providing and the product that we see in front of us.
All right, we are 3D Step, a metal and plastic 3D service provider from Finland. And what we do is contract manufacturing, serial manufacturing for industries.
And what is it that we see in front of us? Tell us about the products that we see in front of us here.
This is an example of serial production. Our customer is Mirka in Finland, and this is a component for robotic grinder. This has 120 components that are printed in one go, and here's the one specific component that this has. And this is an example of what we do as a daily business.
Hello and good morning, ladies and gentlemen, also from my side to the second day of Formnext 2022 here on the AM4U stage and at the screens at home in our live stream. We are kicking off a day full of interesting panel discussions and experts insight, as well as highlights and sounds from the exhibition halls. Together with Frank, whom you have just seen in the morning talk, we are going to be there for you in order to answer your questions you might have. So please make heavy use of the comment function in our live stream, and I will get your question here on stage to ask it to my audience. Let's start the day with a really interesting panel. I recently heard an interview of Terry Wohlers, who made a very fascinating statement regarding 3D printing. He said, the size of the product to be created is not important for the time being. The basic principles of additive manufacturing apply regardless of the size. So this brings us to a topic that has developed rapidly in recent years, the use of additive manufacturing in the design, planning, and construction of buildings. The focus here is on important aspects such as sustainability and circularity, whereby it's not only about recyclability, but also about the possibility of deconstruction and reuse at another location. So in order to be able to approach such a topic, I need, of course, experts of the area, and we have a lineup here on the panel that can definitely be considered as experts. So please welcome with me on stage, to my left, Dr. Olga Ioanu, not so easy, Assistant Professor, Architectural Engineering, Technology Department, Architectural Engineering, it's doubled, at the TU Delft. Great to have you here, Olga. Then we have Professor Dr. Paul Nicholas, Associate Professor at CETA, the Center of Information Technology and Architecture at the Royal Danish Academy. Great to have you here, Paul.
Thank you.
And then Dr. Oliver Tessmann, Professor of Digital Design in the Department of Architecture at Darmstadt University of Technology. And then last but not least, just arrived on time, Dr. Nadia, your name is quite heavy to pronounce. Let me...
Godilier-Jamy.
Okay, I try to. I stay with Nadia if you don't mind. So you are a postdoctoral researcher at the Technical University of Darmstadt as well. Hello, everybody. Great to have you here. Olga, starting with you, because your main topic is circularity, right? So the construction industry, as I read, is responsible for a large share of waste. I was quite surprised, to be honest, because it's the first time I really considered the topic of waste. I've read like 20 to 30% of the whole waste of the European Union is produced by construction. So it's then even more important that we reuse things and we can recycle materials. So what does that play a role in your work, in designing, and in your work at the university?
Well, we are trying to establish new design protocols for reuse. That's not inherent in the architectural profession. Layers are still very interdependent, building layers, I mean. And therefore, we are required now to come up with different ways of designing building products, but also buildings, to be eligible for reuse. That means that requires a major shift from buildings as monolithic structures to buildings like assemblages, so assemblages, in the sense that buildings are temporary, let's say, formations of products that have otherwise a very high value, a higher value than the building itself, because they can be reused endlessly in endless life cycles.
Is it kind of a modular approach then, in terms of the elements, or?
Yes, but that doesn't mean that it limits design.
Yeah.
It kind of challenges design to overcome modularity per se.
Very good, very good. I'll come back to that topic because that's really interesting for me. Paul, when we talk about optimizing and reducing waste, because this is important, we quickly come to the topic of material use and reuse. To what extent are you involved here with your research and what you are currently working on?
Yeah, so I suppose that we we looked at large-scale AM as an enabler for new materials for architectural building. And we are working particularly with biodegradable materials, bio-based materials, materials which come almost entirely from local waste streams, agriculture, the timber industry, the meat industry, the clothing industry. And we're very interested in working with and developing materials using those products, which are locally producible and, most importantly, very cheap. We're then working with robotics and gantry scale printing to print large-scale architectural elements. From those, we can print elements at the moment that are about 2.5 by 1 meter, which can weigh up to 60 kilos or so. And we're also interested in part of that question of scaling up of those materials, not just being about the size of the printer, but also the ability to produce those materials in quantity. So ideally being produced cheaply, easily, in situ, on a site and with little energy. And then lastly, we're interested in the performance of architectural elements that are made from those materials. And I think here what we are understanding is that it would be maybe a mistake to consider them as one-to-one replacements for many of the materials that we have around us. But what we need to do is to identify the particular opportunities associated with those materials. And that's particularly also around the way that they can modulate the internal climate of buildings, also the acoustics, many qualities that other 3D printable materials can't do.
So it's not rather about stability or material specs that are similar to the ones we have today, it's more about the specific use in the future where you can put them in the building, right?
Stability is important.
I mean,
of course.
that would be my question if we're talking about these materials.
Yeah. But I think it is very much, yes, looking at what other value, what extra value comes with these materials beyond those that are sort of currently in our printing palette.
Yeah, very good. Thank you so much. Nadia, you are not only doing research. I was quite interested in to see that you have founded X3. That's a company that prints large formats. And you have already existing project, right, as far as I read. The question always in additive manufacturing, whatever panel discussion we're doing, what are applications? Can you name one or two and give us the current status for the use of 3D printing in your field?
Yeah, of course. I can give 3 examples from X3. So they're all in concrete, but the first one is furniture. So we've explored a super large range of furniture. The second one is housing. So we just finished a series of 5 houses in the north of France. Which are quite interesting because they mix concrete printing with a range of other building techniques. And so this is where applications for the construction get interesting, right? Because you're able to really see how it connects to the whole rest of the industry itself and the techniques they use. And the third one is slightly further away, but also extremely interesting, is artificial reefs for fishes. So with the geometries you can print with 3D are especially complex compared to other concrete structures, and so you're able to provide housing not just for humans but actually for animals too, including fishes.
Okay.
So yeah, here is a maybe broad range, but that's also the thing with 3D printing. You can do a lot of stuff with it, so quite a few applications there.
So what is then the focus? That would be an interesting question, because we kicked off with sustainability and circularity, and I think you all are in architecture, so there's always also a design approach. Is the focus rather to create the perfect solution regarding sustainability or design, or is it a mix of all?
That's a big question. I would say it just started being mentioning, and we have quite a few people here working on that. It's that idea of assembling 3D printing with other pieces and also disassembling. But yeah, Oliver, maybe you can say a few words about DDU's work on that.
Yeah, well, we have an interest in what we heard from Olga already, to work with modular systems, but revisit those from a digital perspective. If you use computation for modularity, we hope that it looks different from the disappointing post-war Plattenbau stuff that we find all over Europe. Yeah. So using computation for combinatorics, recombinatorics, is something that allows to really design with modular principles. And that also addresses the question of the scale. Do we always need a printer that has the scale of a house or is slightly bigger to print the entire house? Or can we prefab stuff that is assembled and can be disassembled, but also can be reused in different contexts and buildings?
Yeah, that would be interesting for me, because then aren't we then back again in like delivering parts of a ready house and assembling them on the spot? Wouldn't that be contradictory to the sustainability approach of at least try to prevent transportation, for example, in this case?
What's important to have in mind is that the construction industry is very different from a lot of industries we see here at Formnext. It's extremely fragmented. You have small companies doing stuff. You have a few global players, but a lot of them are small scale. So that means every construction site is slightly different. There is stuff that is prefab and is brought on site. But there's also the case that machines travel on site to then print the entire building. And I think we have to look at all the different possibilities. And then if we look at life cycle assessment, sometimes it's also about the length of a transport that makes things sustainable or not. So in that sense, keep the possibilities open still. I think for us as researchers, it's important.
Oliver, you helped to establish Beam. I mean, you are one of the founding partners. So you have a good insight and overview of all the architectural activities through your international network. What has to be done, as you mentioned, the fragmented industry in the construction area, what has to be done to bring 3D printing in the real production world so that we get it at a scale and not only like experiments or single projects?
Yeah. Yeah. As you mentioned, we are running the BEAM Symposium, which stands for Built Environment Additive Manufacturing, and that starts at 11 o'clock in the tour house, so you're all invited to join. We do that since 2015, and it's very impressive how things evolve from kind of concrete poo in 2014 to, well, houses, multifamily houses being built in 2021 and being presented today. What we see is, on one hand, that there are companies that develop 3D printing of concrete into a robust technology. You can use it. And there's an approach of gaining efficiency of existing things that have been built. Do them a little bit more quickly, let's say. But what I think we also need is a kind of disruptive change, which is in German the Bauwende. We have to rethink the way we build and how we consume materials and how we reuse. So we have to look at materials that we are printing with. Can we print with local materials, where you bring the technology to a place and you use the local materials? Can we use biomaterials for printing? This is something that research now has the opportunity to focus more on after the technology is working. Yeah, the printers are there. We can now look at materials. We can also, and we still need to do that, at design to production workflows. We have other possibilities of forms, geometries that can be printed. Well, we also need to design them, right? So from an academic point of view, it's also a question of educating a new generation of designers, architects, engineers to have a deep understanding of the link between designing and materializing printing elements and buildings, of course.
Very good. Paul, Oliver just mentioned the materials, and you were talking about the biodegradable material. When we have, like, as far as I read, like, we have concrete, we have sand, we have different materials. What are the most common ones used in 3D printing, and what are the different challenges regarding the materials?
Within biomaterials?
No, within 3D printing. Yeah,
3D printing in general.
So what is the most, let's say, the most trendy one for the moment?
Well, certainly in Denmark it is concrete, I think, at the moment. Cobod is a Danish company, a leader in the industry for large-scale gantry printing, and it's also a partner in a number of our projects. It's very interesting for us to test our biomaterials against an existing infrastructure, which is their 3D CP gantry printers, and to understand how that those processes work. I think also, I mean, there is, probably concrete, maybe metal, and maybe polymers, so PETG, these kinds of things. But I think from our research focus, the interest is really in trying to diversify, actually, materials, and to think about how can we use more different materials, so that if we do not need to print with concrete or metal or plastic, then we can print with another material as well. I think, Ollie, you mentioned scale or localization before as well. I think this is also, for construction, is very important. And I think there, particularly because you can see hybrids construction approaches emerging, so containerized robotics, for example, the ability to print, so in a way do prefabrication, but on the building site, and then to move that up. It's very powerful if that can be connected to local material production. So again, it's something that is very similar to what is happening maybe with concrete printing, for example, that the materials can be made very simply on site. There is some advanced chemistry that is happening back in the lab, but what's actually going on in terms of the material production on site is cheap and fast and able to be produced in quantity. And I think this is a key hurdle or challenge for materials going into the construction industry, is that sort of scalability around quantity and cheapness, price.
Yeah, price is definitely deciding. I mean, you as a researcher, you are always quite a few years ahead. I would put it that way, because I mean, you are researching things that might be applicable in the future. Or you're focusing on the topic of circularity in design. Although you are years up front, let me put it that way, do you see already an interest on the end consumer side? Is that something you look at as a researcher in terms of, is the society ready for thinking about circularity in building? Is that something you consider?
Well, first of all, let me say that we are 2 steps ahead because of our students.
Yeah.
They are the ones who are two steps ahead from us. So we have this co-learning, thing going on. Yes, of course, because circularity, we tend to say, requires systemic change. That means it's not a matter of developing a technology, it's not a matter of finding the right material, it's actually everything. So it's both, but also how to raise awareness in regard to the use of new materials, to develop a new let's say, vocabulary of aesthetics, because these materials need to be also accepted by architects and their clients. So it's also about making policies to advance and promote different construction methods and different materials in construction, and to also enable certifications. There is a huge amount of stakeholders involved in the buildings, anyhow. Circularity challenges these predetermined, predescribed, let's say, interdependencies, and reshuffles the box. And in that sense, you cannot just focus on the allure of digital technology like additive manufacturing, for example. You have to question every time, what is the added value of that technology to what you want to achieve, to your ultimate objective? So what is that?
And for each and every stakeholder.
And for each and every stakeholder, and for the person coordinating the design process or the building process, every choice needs to be contextualized. So what is actually changing is that we're not trying to develop one-size-fits-all solutions, because this is never going to happen, but we are trying to advance our understanding and knowledge across the different topics, just to be able to make the right decision each time. So it's a different thing. It's not like, oh, take this, it's going to work. No. Every time, every situation is different. We need that kind of knowledge from materials and construction to be able to make the right decision.
Sounds like it takes another few years until we see that.
I think there is a phrase I always identify with. We have work to do until the end of time.
I mean, Oliver, the 7 years with Beam now, how do you see the progress, and what kind of outlook creates that for you? I mean, you have observed now 7 years of development in this field. How is the future?
Yeah.
How fast?
As I mentioned earlier, the 7 years were amazing in a sense of how fast things developed. Regarding to your last question, where are we in research? Yes, we might be a little bit ahead. We have the luxury to work on stuff that does not need to be economically performing. Yeah? However, that needs to be transferred. So one thing that a lot of universities look at is how can we help startups to get our research into industry. That is something that also then feeds back into the research, of course, yeah? Because you're faced with problems that you wouldn't envision in your lab. That's an interesting way to collaborate and exchange. And then there's a political dimension, which is important. If you look at EU taxonomy, if you look at the German Koalitionsvertrag, what our government agrees on doing in coming years, it will change the requirements for an industry. So you better gear up for that as an industry to see what's coming in a sense of using resources, of using materials. Yeah? We are at a point where tax models will change and CO2 emissions of materials will play a major role. And this is a moment where additive manufacturing could be suddenly economically valid because if you design it in a smart way, you then use only the material you really need for a building, for load bearing, and for all the different requirements that a building has.
might be the only way, like we heard yesterday from Deutsche Bahn, that say whatever train they buy in the future, they need the spare parts for a lifetime. So this is the only way to realize that is implementing additive manufacturing in this case. So probably this is really a way which then would lead also to biodegradable materials, because this might be a way to prevent another CO2 increase. Nadia, this leads to, let me tell you a quick story. Last weekend, before I went here, I met a friend and we talked, and he told me in the past he worked in the wood economy, okay? So, and wood and construction. And he said for decades now, they are discussing about building houses, especially in Germany, where we can do it like circular because sustainable, because we have the volume of wood we would need for building. And it was never achieved due to the fragmentation of the industry. It was never, they still build the old traditional way. What, beside the legal aspects, must happen that we see more and more projects in reality?
Well, I think actually the legal aspect and what researchers can do for it is pretty important. Oliver was describing how can you collaborate with the industry or industry partners to get that through. And in 3D printing, there is a huge issue about regulations, right? We have new materials, potentially new ways of shaping materials. How do they perform? And I think research is also there to provide the data so that we're kind of further and further able to guarantee we know what's actually going to happen. So there's currently a lot about how does a 3D printed material for construction performs alongside like 10 years, 20 years, and how can we do a model of how printed materials react when we can structurally in comparison to when they're shaped in another way. And with these models, can we sort of work with certification institutions so that we get through. And I think for the sustainability aspect, it is also very close to that. It's about can you assess the performance of a material so that when you take it away from a construction, because it's a modular one and you're able to retake them away, if I put it somewhere else, then how does that work? And can I sort of, as a researcher, provide information that guarantees we're able to do it? And as for the structure of in the industry, it's a big question because it's one of the advantages probably also in terms of sustainability. We were talking about these many little companies, and if you envision things as a network because you want to work locally, then it's actually a pretty big advantage to be able to have that kind of tiny distributed structure. So there's a big question whether you would like to push towards larger companies that would be able also to afford moving forward new technology, which is always expensive, or if we kind of take advantage of that distributed structure to move to a more sustainable model.
Very good. Or they are forced then, as Oliver said, by legal restrictions. Oliver, at Beam, do you discuss then standardization where you make like proposals to the regulations, or is that something like where you try?
One thing that we discussed in the last years was the challenges of recreating always the same quality. If you print, you have to make sure that if that becomes a product, it always comes with the same properties and the same performance. This is something we look at. The political and the legal dimensions is maybe a good suggestion for Beam 2023 to get into.
I mean, we need to speed up. Nadia, you mentioned like the modular way and how does the material behave at another place, for example. Paul, is that something that, how can we research on that? That's just a question for interest. Like, let's say you build in your biodegradable material, then Nadia says, oh, let's try it in the south of France, for example. Other climate condition, is that something that is in undergoing testing? And I try to imagine it's nothing you can do in a lab. You need like corporations. Are you internationally then cooperating in testing those materials, or?
Yeah, that's a very good question. And I would say that we are aware, very aware of those issues. And it becomes even more complex the more you think about it, because of course there are regional differences. A material can behave very differently in two different climatic regions, but also the constituent ingredients of that material can possess very different properties. The strength of fibers, of biofibers, can differ drastically when those fibers are grown in different locations.
Absolutely, yeah.
And then temporarily, I mean, just like wine, you can have good seasons, you can have bad seasons. Yeah, we have, and I think the further you dig, really this. I mean, it does also suggest either developing either sort of expanding the ways that we consider how we characterize and standardize these materials to allow them to come into the construction industry. This is something that certainly needs to be addressed and put in focus, both on a regulatory but also in the research perspective. But I think it is still, I mean, it exists for timber, for example, and more standard biomaterials. We have broad classification systems that allow that to happen, and there's, I think, a similar sort of set of procedures that need to be created to enable the diversification of those materials. But I mean, at the moment, from a research perspective, it's actually quite productive and interesting, because even though someone may have done a particular experiment, made a particular material, created something on one side of the world, that does not mean that it would work on the other side of the world. And that kind of replication is very healthy for the research community.
Yeah, is there an international exchange on that? Like, you call Paul, let's test whatever?
We are trying to establish one. Yeah. And where I come from, TU Delft, we have a very, we are very determined into bringing these different discourses together. So we have the Circular Built Environment Hub, Professor Tilman Klein is leading. And there we're trying to establish collaborations that are for now interdepartmental, but also cross-faculty. And through the CB Hub, which is like a critical mass of researchers, we're trying to reach out the rest of the world. So cross-level education, but also other institutions. We recently had a symposium on circularity, inviting researchers and professors from all affiliated institutions, let's say, to discuss how they go about in their education. But we do the same thing for research-wise. Interestingly, and it also relates to the question you asked me before, I don't think it's possible to transition to a circular built environment unless we actually learn how to work together. Yep. So far, industry engineers have learned how to be competitive to one another. That needs to change, and it needs to change radically, and yesterday. So the thing is that we cannot afford to try out separate things and doubling the effort, whereas we kind of need to align forces to get there sooner.
But that's an interesting topic, because when I talked at AMTC with metal 3D printing researchers, they had the problem that international cooperation is always a little bit limited due to funding. For example, as you mentioned, would be great to have an experiment with your material either in Denmark and then, I don't know, in France, for example, or in Thailand or in South Africa, wherever. So who is then paying for the research then on the other side of the world if there's not exactly the same program funded? So how is that an issue with funding in your research?
We have very close ties with the industry at TU Delft, and interestingly we had this prophet, and there was the president of the VMRH branch, that's the Facades branch organization, association, and it was she who said that first we need to start work in a way that's not competitive to one another. And we're talking about the whole facade branch association, so yeah, that's it.
So this would lead then to quite of a important responsibility as role models, as you are researchers. You have the new students in place, which will make the next generation of architects, construction expert, material experts, whatever. How do they, is that something that you implemented in your teaching to tell them, listen guys, in the future it's not longer I want to be the best architect in the world, it's more about...
Definitely.
Yeah, how do you do that?
Yeah, it's mostly because we're dealing with issues that are very complex, and there is no single answer. We don't even, sometimes it's not only that we don't know these things, but we cannot even describe them in full. So how do you go on teaching something that's so uncertain and so complex? And how do you make students get inspired by this and not discouraged? So that is a hard task. I think it's good to frame education as a hopeful stance, as the practice of hope. I think where we stand at the moment, we kind of need this younger generation of professionals to take a hopeful stance to what is going on in the world and to coil around ideals and principles before technologies, if you ask me. So.
And to remain positive, I think this is another important topic.
Yeah.
Nadia, I mean, you have X-Tree still exists, or is a company that you're still driving. So you could then be a role model and tell the future architects, look, we are doing this and that. Is that something, the role you have to play very often, that you give speeches on your activities there? And
a bit. So what we've had a lot of students visiting our facilities to kind of see how that works, which is always pretty interesting. It's what we were saying, they're a new generation and they're a lot more strict than maybe we were at that age on sustainability issues and on saying if it's not sustainable, then we're just not doing it. So it's also about sort of questioning, figuring out. At X-Tree, we've been looking at new materials, so geopolymers or clay or things that may be potentially more sustainable than concrete to print, and how exactly you can put that in place, how you can either reach the same performance in terms of scale and structural performance with other materials, or maybe also, as was hinted a little bit, can we just rethink how we construct? If like clay doesn't reach the performance of concrete, then maybe it's not that bad because maybe we can make it work in terms of scale. Maybe we could just do with smaller pieces and then go on. And yeah, it's quite interesting to see how visits have intervention. It's not only about showing them what we do, it's also about listening at the way they kind of hint towards and the things they believe should be done. And yeah, balancing how we progress also based on their intake.
Let me ask Olga, another question, because this is really interesting.
Yeah.
As I experience researchers, once I talk to them, there is also a way of competition, because of course you want to be, depending on the research you're doing, you want to be the first to publish, or you are on an innovation, whatever there is. So sometimes, I mean, we are not, let's call it, we are not the generation that learned too much to cooperate. I mean, we are rather forced actually to do so. So the new generation coming up, would you consider, as Nadia said, that sustainability is a must for them? Is that something you feel? I mean, you are close to them, or are they saying, most of them, it's not that bad as always described in media?
Well, I can't say it's a must, but it's, let's say, related to the other fascinations. It's embedded in other fascinations. And we're not trying also to promote it as a must, in the sense that it's not a mandatory. It maybe is, but we as educators cannot force sustainability or circularity on anyone. What we are trying to do, though, is to enable them to, let's say, intertwine their own fascinations within the greater context the world is in today. And then comes circularity, there comes sustainability, and then there comes the choice, which is a very political choice, like Oliver said, to decide who you want to be in this world. So pursue the fascination, but in a way that makes sense to others as well. And in that regard, I think we're doing very well.
Sounds good to me. Paul, you mentioned it several times, the economics of materials, or the whole thing here. As due to a study that I just read from Exactitude Consulting, I don't know them, was on 3D Native, the market should rise from 503 million in 2020 to 6.5 billion in 2029. So there might be some economic interest on the side. How do you see that in terms of economic scale? So is additive manufacturing increasing with these impressive numbers, in your opinion? What needs to be done to get there?
It's a difficult question, because really we also want to reduce our material use. I think as well, yeah. So I
think it's more about the construction market and the use of additive manufacturing.
Yeah. Okay. Yeah. So in that case, I mean, I think that the construction is characterized by the need for for a lot of material. Yeah. And I think this is so. And of course, we are. There is a great need for development. And I think where additive manufacture can play a role is in reducing maybe that overall quantity of material, and perhaps also diversifying the material resources that we are able to use
to a better result. Oliver, I mean, it's if we talk about additive, it's always, if we want to speed up, what is the what are the advantages in real use compared to traditional methods, right? So if I read through the advantages of additive manufacturing in construction or building or in architecture, it's a really long list. But it doesn't mean that it really gets realized, because most of the companies out there, and they are fragmented in your segment, they are comparing it, and if it's not really the same price or even cheaper, then they say, okay, I don't see the main advantage. Is there in the near future an economic advantage in using additive manufacturing if we look at the different materials, if we look at different designs, Nadia, that we can use? I mean, probably we can build into mountain parts where we couldn't build before because we can use additive manufacturing. Do you see that in the near future, that the building industry, at least for specific situations, says there we can use additive much cheaper or more economic than the traditional approach?
Yeah, the question is what is part of that calculation, right? Currently, we don't pay for the costs that we create when we use concrete. And if we would calculate the amount of CO2 emitted by producing cement, then concrete would be much more expensive. If that becomes a reality, I think the way we build will change. And there's probably a difference between this aim, you mentioned that, for being faster, being slightly more efficient in what we do all the time, or if we want to have other effects, if we are effective with 3D printing. Yeah. And I'm convinced that that means that we have to rethink the way we design and we materialize. And again, if there's the political and societal context around it, that will have an impact on construction costs. So my hope would be that, maybe the way we build today becomes more expensive because costs that we create for future generations are part of that calculation.
Yeah, very good.
Which then gives the chance to build differently through additive manufacturing.
Nadia, we discussed briefly in our briefing about the life cycle assessment of buildings, especially if it comes to sustainability. I mean, the problem is we are talking about things that last, I don't know, 50, 60 years. What is the current status on that? Probably whoever wants to answer, but I would ask you first, Nadia. We talked about models that are tried to be used, but this is a question I got from this friend from the wooden industry. The first one is, what is then, where is additive manufacturing more sustainable? Because you can always say we use less material, but probably use more energy. This is always a main calculation. So how do you see the status on that?
So I think the main question now for additive manufacturing in the built environment is that usually if you do a life cycle analysis for a building, you almost only consider the material the building is made of, because every construction process has been extremely optimized. The tools can be reused so many times that their impact is very small compared to the actual material the building is made of. But through 3D printing, we digitalize a lot of the process. So the question becomes, is my process, my tools, are they still so negligible compared to the building material itself that I cannot just not calculate them and look just at the materials? And one of the big questions now is to basically make enough LCAs of different situations, of including the tools, to be able to figure out in which cases we can keep that assumption and in which cases we actually have to consider the impact of the printer itself, basically. And then comes the question, how are we capable of integrating those tools enough in construction processes that we're able to say, well, yeah, certainly my printer has quite the impact, but maybe I'm using it enough times that it becomes worth it. So we need a lot of data because LCA is usually a very specific, very powerful, but very specific tool. So the status now is to kind of be able to figure out if that trade-off between process and building material is different in additive manufacturing for construction, or if it's similar to what we already know.
Would lead then to my question, who is doing that? Is that part of your research? If you are looking at the material, is that something you include, or is a clear part of your, let's say, of your target, considering, let's say, at least models or calculations on sustainable in the...
Yeah. So not for us. I think more what is part of our target is to because I think there's a calculative dimension and then there's a social dimension. And that is certainly within our target, which also is about changing expectations around buildings, changing expectations around the lifetimes of building elements and building products, and understanding also relations, I think, actually, between occupancy and the buildings we inhabit. So in our research, at least, we do not do so much LCA, because we are not producing those objects, and our research projects do not last the length of time that it would take to really test them. But we are able to explore the social dimensions, and this, I think, is the other very important aspect.
Very good. We are coming to the end of the session, which is a pity because I just grooved in. So thank you very much. Excellent panel here. Thank you so much for the insights. I highly recommend to the audience and to all that have the time to go to the BEAM Symposium. Seems to be something that has to be visited and to explored. Thank you so much for giving me some insights, for answering the question. Although I'm not an expert, I hope you apologize that. It was great to have you here. Thank you so much, and good luck for the symposium and your future work. Thank you so much. Big applause for the panel. Yeah, ladies and gentlemen, we are doing a short highlight break, and then my colleague Frank will say hello again with some expert insights. Enjoy and keep on watching. Bye-bye.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. Formnext spearheads into day 2, and here is a small recap and outlook. Yesterday at the AM4U stage, the top female leaders of 3D printing came together in an interactive panel and discussed intensively about industry applications. Several ladies from the community offered their insights on career opportunities for women in additive manufacturing. Another highlight was an exciting unveiling ceremony. Uila's world premiere attracted a huge crowd of spectators from all over the fair premises. Uila is a prototype combining an e-bike and electric vehicle, featuring a chainless electrical drivetrain designed by Berlin-based innovation studio and Frontier. Presented in cooperation with 3D printing partner Stratasys. Bottles of sparkling wine popped at the Permundus Challenge 10-year Jubilee celebration, where winners from the past decade reconvened to celebrate the uphill evolution of additive manufacturing. Thomas Luc, Head of Innovation and Sales at Curb, explains the thought behind it.
The Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Definitely.
Yeah.
Definitely they have, and that's what this retrospective view of the different winners of the last 10 years really show, that there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well at the applications as how to combine material and process, as how to make a really good design, and because at the end it's a design contest.
At after-work talks presented by Frank Jablonski, Petra Harburger, president of Messago, emphasized upon the importance of spreading the network of additive manufacturing. The talk round discussed the development of the AM market internationally, in particularly about the United States. Doug Woods, president of Association for Manufacturing Technology, said,
"We have a really big market already, so it's easier for many of our new companies to get started and have sufficient market just in the United States. But the reason they come to things like Formnext, it's in as much they want to be able to prove that they can sell their products in Germany and Europe, because that's pretty difficult sometimes for smaller, medium-sized American companies. It's as much this event. This event is the premier event. If you want to show off that you're great in anything from materials all the way through to service bureaus and everything in the middle, for additive manufacturing technology, you want to show it off here.
How was the mood at the fairground? Spread across 4 halls, exhibitors from all over the globe have set up colorful stalls displaying the creme de la creme of 3D printing technology, which drew in thousands of 3D printing enthusiasts. Our camera team picked out some trends and product reviews for you. Munich-based Fraunhofer Institute for Technological Trend Analysis have put up their powder nozzle tech-up for display. Engineer Moritz Greifsue lists out the nozzle's top features.
So that is a nozzle for additive manufacturing. The special thing actually is this little box here, which is screening the powder cone. So it's characterizing the quality of the nozzle. So we could detect, for example, if there's any abrasion or something like that, we would have to change the nozzle, because its lifetime is over, or there was some clogging or whatever.
Next, we have the Heron, an industrial robot AM cell produced by Caracol. For its production processes, the Italian 3D printer manufacturer uses extrusion 3D printing technology, designed with an approach based on applications in mind. The technology already combines over 29,000 hours of printing and has found intensive application in industries such as aerospace, automotive, energy, marine, and more. It can process a wide range of polymers and composite materials in pellet form.
The aerospace industry, we are working today mostly with molds, trimming molds, lamination molds for composites, for example, but we are also looking at functional application in the future. So we are engineering new materials to move from tooling to functional parts. That's the big bet of our company.
RevoPoint Pop 3D scanner is designed with binocular structured light and uses reverse engineering. The scanner ensures that the 3D point cloud data is on point. The highest single frame accuracy can reach up to 0.3 millimeters. This device supports both high precision and texture scanning modes, used to generate vivid 3D models for color 3D printing. The Evotech stand houses a ginormous drone, built keeping lightweight technology in focus. Lucas Meinhardt shares with us its central hallmarks.
Yeah, we got here a very interesting drone because most of the parts are 3D printed and are designed just for the 3D printing process. So you can see here, we got here a very lightweight design and it's printed with carbon fiber filament. So it's very strong and yeah, it weighs about nothing, so it can carry a huge load.
Now on to some pointers for tomorrow's upcoming events. Make sure you do not miss these. Keep your eyes peeled for exciting presentations by partner country France in the afternoon at the AM4U stage in hall number 11. Here also, visitors can attend the Discover3D Printing Seminar, sharing knowledge about basic technology aspects of additive manufacturing. Last but not least, we have the BEAM Symposium at 10:30 a.m. at the Portal House at the Frankfurt Fair Room, Frequenz 2. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Top quality in metal printing. This is what Renishaw shows here at Formnext 2022. Let's ask how they achieve this.
Well, metrology is really important for 3D printing. The unique shapes that we can now print using our additive manufacturing technologies need to make sure they're not just unique in what we can do, but also that they are precise. And our background here in metrology has been really important for us in helping us design our additive manufacturing equipment. But it's also really important in us delivering end-to-end solutions to the customer. Most parts have finished machining, so actually the metrology, traditional metrology equipment, making sure that link between additive manufacturing and subtractive manufacturing is absolutely key.
The RenAM 500Q is a really highly productive system. It has 4 500-watt lasers that cover the entire bed of the machine, which is the only 250mm system to do so. Having these 4 lasers firing simultaneously means that we really minimize build times. The system also has really close alignment between the optical system and the machine bed. This, when you combine that with the intelligent gas flow, means that we can achieve greater than 99.9% density of parts. This integrated powder handling system, intelligent gas flow, high productivity, with a relatively small footprint makes the RenAM 500Q a really compact, cost-effective system. So Renishaw works really closely with partners and customers. This ranges across a wide range of different applications, so from aerospace, medical, dental, oil and gas, and consumer electronics. We have a global applications and a service network, so we're always ready to help our customers.
In our AM solution centers, we have a wide range of experts. And also in the facility, you find the technology around additive manufacturing, all the post-process, part inspection, and also analytical possibilities. So therefore, we work with our customers on feasibility studies, how attractive additive manufacturing is for their factory. And so with this consultancy, we can choose the best solution for our customers for their needs.
At Fraunhofer, and this is Moritz. Moritz, tell us, what do we have in front of us?
Okay, so that is a nozzle for additive manufacturing. The special thing actually is this little box here, which is screening the powder cone. So it's characterizing the quality of the nozzle. So we could detect, for example, if there's any abrasion or something like that, we would have to change the nozzle. Because its lifetime is over, or there was some clogging or whatever.
Why is this product going to be better for the market in terms of, sure, it saves time, but how is it in terms of quality?
Yeah, you know, from my point of view, AM is maturing, meaning a lot of people are trusting these processes more, and that's the point where we have to step in to ensure quality. That's what I believe.
Welcome to our Expert Insight short presentation here in cooperation with VDMA Working Group Additive Manufacturing. Today we have the topic new application and new markets, and that is what we want for our product, new markets. And I have 3 interesting guys here on stage. They will show us about their applications and maybe their new markets. And we have here Thomas Batinier, he's CEO of Linkstar. Thomas, nice to have you here. Alexandre Schäfer, he's Business Development Manager of James GmbH. Good to have you here, Alexandre. Und Udo Burggraf, Sales Director EMEA of Additive Industries.
Thank you.
So, they will give you the presentations, and I think we have not so much time. We have about 38 minutes here for the colleagues. And so let's start with the first presentation with Alexandre. Oh, no, with Thomas, sorry.
Thank you. All right. So
killer application is basically the thing to find in additive manufacturing. We've all heard about different kind of prototyping solution and some applications that do work at a scale, but at Linkster, we spent the last 6 years developing a lot of different technologies, and one of them is actually a game changer today in the industry. We're talking about silicon additive manufacturing. And by silicon additive manufacturing, I mean actual silicon. We're talking about 2 parts, medical grade and industrial grade silicones that are printed with a material extrusion technology dedicated for this kind of materials. Interesting fact is we end up with isotropic properties, and also we end up with the final properties of injection molding with an additive manufacturing process, which is pretty interesting. So we dived into different applications with customers in order to find this killer application. And we found that silicon additive manufacturing can be game-changing in industry and in the medical field. The first one, in the medical industry, we're looking at epithesis, basically external prostheses for people to recover from an injury or from a cancer, printing direct silicone that is colored in the mass to print ears, noses, even part of the bodies, for people who don't want to go through internal surgeries and internal implants. So thanks to the qualification of this silicon that is not put into question, going through this process, we can find a better way to solve custom issues at patients. Another one is for industrial applications. We've realized that there is so much time spent on taping parts, just basically to mask them and to go through a surface treatment process. It sounds trivial, but at the end of the day, we're talking about hours and hours of a repetitive process, which is very, very labor-intensive and is not scalable. By printing custom devices like that that are capable of masking some areas, some strategical areas in high-value parts, they can go through chemical treatment, they can go through heat treatment, painting, plasma, all of this kind of post-treatment, basically. Using actual silicones or polyurethanes for this matter allow us to withstand a lot of different cycles and reuse these devices in order to, well, basically have a win-win situation with the customer. That was basically what we used to do last year, and then at Formnext we've released a new machine that's capable of printing supports. By doing that, we are now capable of printing basically any kind of geometries, even big overhangs, and we have the freedom of design that we could have in FDM, classic thermoplastic printing. So it is a mini revolution in our field, and we feel like all of our customers in the medical area, in the industrial area, will take the most out of this innovation to tackle new challenges.
So, well, that's very interesting. You know, silicon, to produce silicon additively was always was long time a problem. Just give me, maybe I did not get it correctly. What was the main obstacle, the main hurdle you had to take?
We're talking about thermostats, and when we talk about technical silicon, there is a technical issue. Is that, well, silicon is liquids, and we want to peel up layers first. Second, we have to play with a lot of different parameters in order to not clog the mixer, which is mixing part A and part B. So all of that happened thanks to a lot of different partnerships with experts in the field. And now we're capable of making small parts, big parts, at a scale for a fraction of the cost.
And here is it?
So that's a very simple mask in this case, and basically it's been through a sandblasting process, which is like very, very aggressive in terms of abrasion, and then it's been through a, it's powder paint, meaning that it goes into an oven at 200 degrees for a long cycle. And basically everything they've tried was either polluting the paint, deactivating it, or was just not withstanding the condition, this harsh condition. It's like, fine, this part's been through the 200-degree process, and it's fine, it's reusable.
So why was it so important that you choose to handle silicone instead of choosing another different material?
Silicones are very technical material. They remain very soft, flexible. We're talking about pure silicones. They can withstand this temperature, which are pretty extreme when we're talking about thermoplastics or TPUs.
So did you make a research on different materials? Did you try to enhance maybe, or to put fillers, or to use some solvents or something like that?
Yeah, so our partners went through multiple PhDs to develop the right formulas, and we did the same to develop the machines. That's been a very, very long journey to find out what's the actual right formula and what are the actual right printing conditions, right? And now, a fun fact is that by allowing support structures, we are now capable of processing silicon that should not be 3D printed because they are not supposed to be extruded this way. But now we can have them in a kind of a dynamic molding process, and that's I think a game changer.
Okay, where can I put an eye on that here on Formnext?
So we're located at hall 11.1, just above. Basically, just at the left of the entrance.
Yeah. Okay, and I can get a new ear at your booth.
Yes.
Okay, perfect.
Tonight we shoot a body.
A nicer one, actually, than mine. Okay, thank you very much, Thomas.
Thank you.
We are talking later, but now the stage is Alexander's. He is, as I said, Business Development Manager of James, and we're very curious what you brought us.
Yes, so as you already know, the additive manufacturing is very well developed and experienced for years. And we have a lot of different materials, a lot of different printing processes, and cool applications. So when you have a look around, you see a lot of things there. But what is about electronics? So we have PCBs for decades. And from our point of view, it's time to change that. So what does it mean to come from an AM to an AME, so add the electronics into the additive manufacturing? What our goal is, we want to have real AME. What does it mean? I will explain it in a few seconds. So let's have a look on the AM itself. You can design your application regarding mechanical requirements, like with focus on weight or heat resistance. Then you can use the material, you can use the printing process, and then you can print your application, and that's fine. When you get some electrical requirements, then you have to do the step in between. So you get a small E on your AM. That means for antenna designs or thermal radiation solutions, for example. That means you take the 3D surface and print some conductive material on it, some wiring or whatever. We call it MID, Molded Interconnect Devices. In our world, from electronics perspective, we call it 2.5D, 2.5D. So because it's a step in between on the way to a real 3D structures. And what does it mean to have real 3D structures from our point of view? That means we have embedded components, we have 3D wiring, we have the same creativity, the same freedom like you will have in the AM itself. So currently, it's not possible. There are some challenges to do, or a lot, to come to this way. And we want to push this technology to the next level together. And that is why James exists. We created world's first online 3D community for AME, for printed electronics. And on this platform, we bring the whole ecosystem together because we have seen that the printer manufacturers are doing something, academia is doing a lot of research, we have enthusiasts, they work for years in that, and also the industry, they don't know about this technology or they don't know how they can use it or what is possible. And we bring all these stakeholders together. On this platform also what we are doing is we share our knowledge. We want to educate the people. We want to show how does it work, what is possible. We have a lot of applications and examples there to copy it, to have an easy access to this technology and to have some synergies between all of us to push this to the next level and to come to real AME. This is what we want to have. And if you want to see some applications about it, please visit us, come to our booth, and we can have a small chat. I can show you something, what is possible today, and how does it work. So I'm looking forward to seeing you there. Thank you.
Yeah, Alexander, thank you very much. So we know now where to go, but I want to dive a little bit deeper into what we see there and how it actually works and what were the obstacles you have to solve on the way. I learned some years ago that it was a really problem just to print copper. So
yes,
to have the copper printing process was really a problem in the first beginning. And you're trying to print hybrid materials.
Yeah.
So what were really the steps? Please explain to solve these problems.
Yes. So when you have a look on the whole process, so to come from an idea over a digital design to a real print, the first thing is we have to change the mindset of the people. So this is one of our biggest challenges, let me say.
When you're talking about people, you mean
the engineers, the designers,
the end users, or
not the end users, the designers. They design or develop the applications.
In the first step, the designers.
Yes, because they are in the PCB world and they think in layers and vias and in 2D structures. And to bring them to think out of the box into real 3D structures, this is the first.
You're talking about the people engineering the circuits, the circuit designer.
Yeah.
Okay.
Yeah. And then when you have when you are lucky and you convinced someone to think from PCB into real 3D structures, the next question is, which tool can I use? And that is the next
designing. Which designing?
For designing, yes. And this is currently the next problem we have to solve, because there are some ECAD tools for electrical design, some MCAD tools for the mechanical and 3D design, and we have to merge it manually currently. So, and this, is not the best process. And we also cooperate with software companies. They design such tools to tell them, hey, we need something. The best thing will be a 3D auto router, let me say so. This will be the best way to come from design into real 3D structures.
Okay, and once we have the good designed product, the additively producible design product, what is the next step? I'm curious about the machining. How do you do that?
Yeah, we have some processes available also in this world. From my point of view, the most developed process is the inkjet process, where you have a DI, a dielectrical material, and a CI. In this case, it's silver. And then you can print layer by layer or dot by dot, and you can design a conductive or non-conductive layout. Then you can use pick and place to add some components on it.
Okay.
And what we also want to have is another process is called micro dispensing, and then we want to replace the wire bonding for the components, so that we connect the components via micro dispensing into the whole system, and then print again to put it to encapsulate into the whole system and in the whole design. So currently we have this process. We begin to print, then take it out, pick and place, micro dispensing, back again to the inkjet process, and then print again. So.
And if you're ready with that product, is there another post-processing steps, like in other processes where you have the supporting structures or something? Then but when you are finished, then you have the product you can put into a computer or.
Yes, there's no. Currently, we are talking about such sizes like that in this electronics area, and so we don't have to do any other step behind. Yeah.
But all what you said, I believe everything you said, but it sounds very cost intensive. We had a discussion this morning with Mr. Hering from VDMA, and he brought with us some results from a survey.
Okay.
And the main issue there was cost.
Yes, so to be honest, this technology is currently on a technical readiness level between 4 and 6, let me say, around that. So prototyping a bit behind, and it's it's a long way to mass or serious production. That's the reason why we also want to have all the people on one table to discuss this. And yeah, that's true. Currently, the prices, it's expensive to do this, and for
it's
that. Yeah,
still a challenge.
Yeah.
And look into the future. Then the goal would be someday to have one machine process which combines all the steps you said in a one hybrid machine.
Yes, that would be very good. So merge of materials also to get some materials from the AM. We need it also into electronics. And to merge the different processes into one solution. That would be the dream, let me say so.
So everybody who can fulfill this dream here at exhibition or at home in our stream, here's the right person to talk to and to make dreams come true. Thank you very much, Alexander.
Thank you.
We can talk after our third presentation a bit more and dive maybe a bit more if we have the time. I don't know. It's exhibition is always a very time-consuming business. But now we have Udo Burggraf, Sales Director EMEA of Additive Industries. Udo, come here with me and show us what you brought with us.
Yeah, thank you very much. So I brought with me today a use case I would like to share about a established technology, laser bed or powder bed fusion, an established application which is an impeller for a pump, but a technology and a setting right now that opens up new opportunities in new regional markets, like, for example, EMEA, Eastern Europe and Africa, especially in oil exporting countries. So we're talking about a use case we did with our partners. It was a joint effort with Equinor, which is an international energy company, Eureka Pump as an OEM for pumps, K3D, which is a service bureau in Netherlands, and Additive Industries as the OEM for these machines. On the right side, you can see an oil rig that is Statfjord A, which was once one of the largest platforms in the Northern Sea. So we're talking about ballast pumps. A ballast pump is crucial for the trim of vessels and platforms, and it actually pumps water, seawater, into a ballast tank and out of a ballast tank. And the specification here in this special case was that this ballast pump is in operation for quite some time. It had a duty point at about 1,000 cubic meters an hour. And now, at the tail end production of this oil rig, the operator induced actually and started a re-rating of the pump so it can be operated at a duty point of about 50 cubic meters an hour, a significant change. So if you are in that situation, you have three possibilities and three options how to proceed. First one is actually use this pump and add a choke valve to reduce the flow and the output power of the pump. You can buy a new pump, which is a large investment, but brings to the lowest operating costs. And you can modify the pump by replacing the old impeller by a newly designed one. On the right side, you can see what happens. The red curve is the working curve of the old pump. If I would reduce the flow, I would end up with a pump creating excess pressure and excess energy, and it would on top actually operate a pump outside of the design point. So the efficiency, the rate between input power and output power would decrease significantly, and I would have to invest a lot of energy actually to operate the pump in this off-design point. So we used here actually the full process chain. We started, or Eureka started, with a 2D drawing. We made it a 3D model. We did simulation with CFD, validated if the new design works as expected, printed the part, did the machining, the certification, and the installation. So there are standards out there in the meantime, like the DNV GL STVs 203, that gives us actually recommendation how to do the full process chain and how to certify those kind of parts. And you can see that we have a work split here between an OEM who does the design and the certification and the service bureau right now that does the manufacturing, the printing part. And this is actually significant if you want to go to new markets like oil exporting countries in Africa, where the IP still sits with the OEM, who's located somewhere here in this case in Norway, and then a service bureau that is closer, let me say, to the place, the location where we are producing oil and energy and gas. The printing process was done on a metal fab, to see at K3D in the Netherlands. You can see the part, how it comes out of the machine, and the finished part nearby. If you want to learn more about additive industries and our machinery equipment, come by the booth D11 here in this hall. You can see also now the old impeller and the new one, the installation and putting the pump back in operation. And what quite interesting fact actually here is that we had cost savings on 2 levels. First of all, the operator had to buy less carbon dioxide certificates, which gave him a cost saving of about 174,000 euros a year. And on top, of course, a lower energy bill, which added another saving of 236,000 euros. In the end, he ended up with cost savings of 450,000 euros, round about, per anno per pump. So we can see additive has reached a state right now where you can have significant cost savings using additive manufacturing. This impeller could have not been manufactured otherwise, and it could have not been manufactured in that lead time. This whole process took Eureka and K3D about 8 weeks from the design to the installation at Stratford A. Thank you very much for your attention.
Yeah, thank you very much, Udo. Very impressive. You picked out a very nice example, because that is an industry sector where they have a really time pressure, and every minute the pump is not working, they are losing a lot of money in the oil and gas sector. That's very, very impressive. Maybe just, I'm not sure if I understood it right. So maybe I'm the only one here, but please explain to me again. You said he needed a lot less certifications while using the 3D printed part. I did not get that point quite clearly.
It's not less certification. We see that we now have established standards in the industry how to certify an AM part.
Okay.
In this special case, the solution was made that this part was treated actually as a spare part and not a new design, which simplified certification significantly.
So if he would have bought a new pump in the total, so he would have a lot more of certification work, because he had... okay, I understand.
Precisely. Now it's treated as a spare part with less effort.
And that is the case for just the oil and gas industry, or can you please compare to, I don't know, medicine, where you have a lot of certification issues as well, or flight industry?
No, standards are different in different industry. So this applies here with this standard in this industry, these kind of applications. So I want to point out again.
I'm here at the stool, sorry.
Okay, sure, sorry for that. So I just want to point out again, we have now a setting where we have an OEM who has the IP and does the certification. But we are producing the part in a totally different place. And we can do it now also in new markets. So we're setting up a service provider, for example, in Nigeria, who can support the oil and gas energy industry locally. So we can overcome the situation that we have to export parts. The companies have challenges actually to get parts into this country because of local regulations at the borders. Now we're transferring only data, and the parts can be produced locally. And this example actually sets the pace here and demonstrates it is possible now. We dreamt about that that was quite a while ago. And now you can see here we are a step further. The machines are mature enough, the processes, the standards are there, and we can take now the next steps to go into new regional markets and where there's less expertise in AM right now, because we have reached that maturity in the application and in the process.
Well, let me talk about the material you're using, because the pump is again a very good example, because you cannot use any metal as a pump impeller. So you need the expertise for each of these products. You produce a spare part.
Yeah.
How do you manage that? I think that's a very huge problem to keep that on track.
It actually isn't such a problem. So here in this case we use stainless steel, which is a well-known material. But with this setting, all this know-how and this IP stays with the OEM of that part, here in this case with Eureka. They know their materials, they know their certification processes, but they can, let me say, subcontract now the realization and printing of a part to another company that doesn't have the expertise. So they have only to share, let me say, a subset of their IP with a service bureau to get that part printed locally, and all the IP remains with the OEM on materials, certification, and design.
And is it common that they transfer a sort of something like a running guarantee or stand-up time guarantee with their choose materials for that part?
Yeah, absolutely. So these are materials, they are familiar with the materials, they have their established tests, which are the same actually for, or similar for AM with other...
So the end user can feel safe,
absolutely.
So they get a guarantee about that.
Absolutely, that's right.
When you're talking about, or give us some insights, please, about the different steps you said. So you have the certification we talked about, but the service is always a topic, and the producing of the part, and the discussions with the customer, which part is really needed. What are the most time-consuming steps for you, and where can be an improvement in your opinion?
Now we have an established process here right now. All that, talking about service,
so
about
everything is fine
the
for
customer.
You. So you are
no,
really
it's
happy?
not fine. But it stays with the OEM, who does it anyway, independently of the manufacturing method. So this is the same, the service and all the kind of discussion. But right now we can split, let me say, the production in AM, the production from all the service activities, which still remain with the experienced OEM, which is a core part of his activities. There is nothing new here on this side, on the service side, and on the material side. Yeah, but we can do it right now with AM, and we can decentralize these activities.
Okay, my hope was that you say something like, we need a digitalized process, that somebody at the oil and gas station, he just types in which part he needs, and on the other side of the world, something pops out of a 3D printer, something like that, I hope.
I think you invite me, let me say, in 5 or 10 years again, and then we can talk about that. That's very much in the future. I think it's all what we dream about. But we have to do baby steps right now. We dreamt about this idea a couple of years ago. It was not possible, actually, because the expertise was not there, the technology was not mature enough. We are at that point, so we are making right now the next step is a decentralized manufacturing. And then, of course, if you are about data, next step would be how can I secure my IP? Because I give away, of course, the design and the build file to another company outside, let me say, of my region. That's the next step, where we have already software solution in the making. And if this one
there are some signatures which are built into the part, so that you can identify it.
And also, of course, on the job file itself, to make sure that it's only used for this specific production of that specific spare part. So that's going to be the next step. And if you have that done, we will more and more digitalize the whole process. Keep in mind, when we started, there was a 2D drawing of that pump, so it has to be digitalized for the very first step. But doing that over and over again, our OEMs actually have a more and more digital inventory that allows us actually then in the next step to look at this direction.
Okay.
Baby steps, one of the other.
Yeah. One question concerning the signatures. There are some thoughts about choosing a blockchain technology to identify it. Are you familiar with these kind of talkings as well?
At the moment, I think we're missing a standardization. There are many technologies here and many offerings. Basically, it's a decision of the OEM. Just imagine that you have in a platform many systems, many different OEMs, and at the moment it's not a given standard that we use exactly this technology for all systems and all volumes.
It's similar, like the topic in connectivity. We're talking there about OPC UA or something to get a common language, and we should need that on that side as well.
Yeah, we need these standards.
Okay. Who would be the best to work on these standards? Is it VDMA, like a group of manufacturers, or is it a broader?
Let me say, the companies who offer the solutions, of course, they will always propagate their own solutions.
So they have...
Basically, I think
there is a competition on the one side, but we need a standardization.
Yeah, and I think it's the OEMs, basically, that have to drive and set the standards so that the industry and the supply chain actually then follows their lead.
Okay, thank you very much, Udo. I have some questions for you guys as well. I don't leave you so early here from my stage. I want to have a question for all three of you, but I'm more interested in you both because your answer is, I think, quite clear, or it was quite clear. I want to know how would be a next step to to transfer what you have learned in your process to another industry sector or to another production sector? Do you have ideas, or is it just out of sight?
No, definitely. What we've realized that, I mean, no one actually want to buy a 3D printer. They want to make parts, right? It just happened to be the right technology to do that, and we have to work on the software side and to connect with what you were mentioning about digital warehouse and all of that. We're talking about job-specific software to design easily the parts. When we were talking about masking application before, when you think about it, we're talking about a workshop with very manual work to be done, and the printer is here to make the part directly, and basically you just have to give a couple of specifications and you get your part, if it's a simple part. So to spread the technology to other sectors, we have to work on turnkey solution to allow the Lambda user who just want part to be able to get these parts either through a service or by internalizing the technology. So UX has to improve a lot, and the software suite has to be developed like way more than what it is today. And I think that's a big challenge for all of us here, is to get something that everyone can actually use. And 3D printing becomes a thing in the backstage somehow. Even if I'm an OEM and I like these machines, but I think that's what we have to do for the customers.
Alexander, what would be your transfer to another industry sector from what you're doing today, and where would you say, okay, the one or the other guy here at the exhibition, they should come to our booth, and then we can talk about the future, and maybe we can transfer the one or the other what we learned, not to use it in electronics, but in another industry sector.
This is a good question, but currently we are in the area of electronics. We try to learn from the AM more and more.
But my question was the other way around.
Sure. Yes, that's true. But we have a lot of things to do currently in this process. We have a lot of challenges there, and I think what we have seen is of the current status of technology. What we can do is antenna design, high frequency applications will be a first step where what we can use to design applications and to use this technology now. This is what we see, and this high frequency applications are in different areas like defense or sensoric or whatever. So that's, from my point of view, a good point to start with this technology there.
But you know what I wanted to get when I asked this question? I wanted to get you connected, guys. I wanted that you come out of your box and go out in the halls and have not only your processes and your products in mind. Make the step out and go there and have a look at what the other exhibitors are showing, and maybe there will be a connection not for today but for tomorrow. So. We have a short time left. What will you do tomorrow? With that idea in mind, who will you visit firstly?
So have a look at on the show definitely tomorrow. No, we will exploit it further. We will work with groups like AM Energy, for example, actually to get the industrialization forward, to get the standardization forward. Because the idea of AM is basically, we want to establish it as a production method. And this will, let me say, increase the numbers, will increase the number of printers, the number of applications, will reduce the cost. We want to establish the technology.
Okay.
So this is the way we'll.
Where will you go first tomorrow, under a personality view? Just not the professional, just for you. What will you look at the exhibition?
At the exhibition tomorrow, my schedule?
Yeah.
Well, basically trying to find as many vertical players, verticalized players. So I said in the medical field or in the industrial field, the one who are in contact with the users directly, because we can be sometimes far away as an OEM, and we have to be on the field to solve applications.
Yeah. Okay. Thank you, guys. Thomas Batinier, CEO of Lynxter, Alexandra Schäfer, Business Development Management of James, and Udo Burggraf, Sales Manager EMEA of Additive Industries. Thank you very much for being with me, and have a very successful exhibition. And I hope your dreams come true. And next days will be busy for you, I think.
Yeah.
Thank you very much.
For the opportunity.
Yeah, and thank you very much out there. Yeah, an applause for you three, for sure. Thank you very much for these insights. And after a short break here, we will have some highlights from the exhibition. We will have the next highlight here at the stage with this Discover3D Printing seminar. So see you later.
This year at Formnext, Formlabs is presenting its latest 3D printing innovations with our SLS and SLA platforms. The Fuse 1 Plus has a more powerful 30-watt laser along with a faster scanning system, which allows it to print almost twice as fast as the Fuse 1. On top of that, it has an active powder management system, which allows it to print more demanding materials but with better mechanical properties. Finally, the nitrogen purge allows it to have a better refresh rate and allows effectively for wasteless printing. The Form 3 Plus, which was released earlier this year, is a new version of our SLA platform and an improvement over the previous Form 3. With software and hardware improvements, we were able to increase the speed up to 40% on certain materials, but also improve the surface finish, as well as the ease of post-processing, thanks to optimized light touch supports. Finally, we have the Form 3L, which brings the same technology seen on the Form 3 Plus, but with 5 times the build volume. With the Form 3L, large format SLA 3D printing now becomes more accessible and easier to use.
So we're here at Stratasys, and we have something quite suspenseful over there covered in this black veil. Peter, tell us about Stratasys vision. What hides under that veil?
Well, as you know, Stratasys stands for innovation at the end of the day, and innovation also means we are supporting any new technology, especially when it comes to faster go-to-market, faster innovation, amongst all the different technologies that we're offering. And therefore we are happy to join forces with Frontier as our development partner, and we are going to unveil a new, let's say, brand new system, which could be explained by Stefan much better than by me.
Stefan, let's pan to you. You're from Frontier, which is I think the heads behind the innovation. Tell us about the technology. This is the future of e-mobility, you teased it. Tell us more.
All right, so what we're seeing here is ULA, and ULA is the answer to a new green and urban mobility, because what we need to do is we need to get rid of the cars in the cities, but how we're going to do this, we need to make a new offering to car drivers, commuters, also in tourist areas. So this is why we came up with ULA. It is a four-wheel bike. It's an e-bike, so you can ride it on a bike lane. It has a hot motor, 2 hot motors in it. We have a partner for this, so it's very comfortable. It's also a digital device, so it'll have functions like follow me. We're going to have a head-up display. You're going to bring your own device features in there. So I think that is creating a great deal of comfort and a digital experience for the consumers. I think that's what needed going forward to create sustainable mobility.
Lots of new technologies that hide behind this particular thing, and I hear urbanization as the key word. And since we're here at Formnext and additive manufacturing is the key word here, tell us about the parts that have been manufactured with the help of 3D printing.
What we did, it's an aluminum frame that we welded inside, which you can't see because we cladded a lot of polymer parts on top of it, and all of them were done on Stratasys machines, so we were very grateful for this collaboration. So let me do a sneak preview just for you, because we're going to have the big unveiling.
Let's get that, before the big unveiling.
What you see here is just the front part. The rest we're going to see later.
So basically this is the Batmobile, but sustainable. And from the looks of it, it's going to be a huge unveiling. And I wish you all the best for this technology, and I hope as soon as it hits the road, we are all going to get a good taste of what the future of e-mobility looks like. Thank you both, Stefan, Peter, for talking to us. Have a great time in Formnext, and I'm sure we'll be here for the unveiling. Can't wait.
Thank you so much. Thank you very much.
Thank you.
Welcome to Expert Insight Discover3D Printing Seminar here on stage AM for you in Hall 11. I'm very happy that we have the topic with a groundbreaking additive manufacturing and with really basic information here. With me is Victoria Krömer. She is our expert on stage. She is consultant and independent expert at ACAM. What is ACAM? ACAM is the Aachen Center for Additive Manufacturing, and the starting point for the seminar begins right now, and it will continue later, and we will have it each day here at the exhibition. So if you want at home, are curious about what the second step is, then you have to come to Formnext here in Frankfurt and to have to attend. But the first step we will have together right now. One advice to the colleagues here in the hall, as this is a silent seminar, make sure you grab your headset over there so that you can follow every step of our presentation here. Yeah, Victoria, now I would say the stage is yours, and we're very interested in the basics in additive manufacturing. And well, have your time with the audience.
Thank you very much, and a warm welcome from my side. I'm very happy to be here today. Welcome everybody sitting in front of the stage and everybody following online. It's a pleasure for me to be here at Formnext. Welcome to our Discover 3D Printing Seminar. We'll dig into the basics of additive manufacturing today, so please follow along for the next 75 minutes and discover with me what additive manufacturing has to hold for you. Who's standing up here? My name is Victoria Krömer, like what was already said. I'm a research associate at the Laboratory for Machine Tools and Production Engineering of RWTH Aachen University, but I'm also a consultant at the ACAM, the Aachen Center for Additive Manufacturing. What is the ACAM? I'll just give you a short introduction, as I will be giving more information on the ACAM later on. But the ACAM offers services in consulting, engineering, and research and education, just focusing on additive manufacturing. On the right-hand side, you can see our perspective and focus. So we are the one-stop shop for additive manufacturing, and together with all the expertise from the research institutes in Aachen, we can cover the whole value chain of additive manufacturing. In the ACAM, there are more than 100 researchers involved, and we have approximately 40 industry projects in consulting, engineering, and research yearly. So what you can expect today is, first, I'll give you a short introduction on the ACAM, and then we'll dig more into additive manufacturing. We'll go into the details of additive manufacturing technologies. I'll give you an overview on different technologies. Then we'll go ahead and dig deeper into additive manufacturing application examples, go along and see how you can successfully adapt AM. And then, last but not least, we'll look into the future perspective of AM and end the seminar with a summary. So hopefully you'll learn a lot today. I'm always happy to answer any upcoming questions afterwards, so feel free to just approach me. And I hope you'll enjoy the next 75 minutes here together with me. So starting a bit with the history of the ACAM in Aachen, why do we have so much expertise in additive manufacturing? We have a quite long history of additive manufacturing. You can see, for example, the first patent for SLM was filed in Aachen in 1997, and the ACAM itself was founded in 2015. So you can say that we are one of the world's most vivid and multifaceted AM ecosystem, and that's what makes us, the whole research landscape, and Aachen especially, so unique for additive manufacturing. Just to give you a quick overview on how the RWTH Aachen campus works and how it looks like, why we are such a unique research landscape. So the RWTH Aachen University was founded in 1870. We have more than 260 institutes involved, and we are a university of excellence since 2007. And what we try to do, we try to combine research and industry, so we do applied research and push it into industry and collaboratively solve challenges of the industry together with the research expertise that we in Aachen have. So within the RWTH Aachen campus, there are more than 400 companies enrolled, working together with our research institutes on just very different topics. And part of that RWTH Aachen campus is our cluster landscape. So we have 16 different research clusters, each focusing on a unique topic. For example, we have a cluster for biomedical engineering, we have a cluster for production engineering, and an innovation factory. And like I said, the point of those clusters is to just bring together companies and bring together industry and research and solve problems that industry may have. So always try to look at challenges from both sides and involve research and industry. So here again, you can see the Aachen Center for Additive Manufacturing, and what we do is we navigate AM complexity. So we combine all this expertise that we have in Aachen together with our broad industrial consortium with many different member companies, and are able to provide leading-edge research in AM. On the right-hand side, you can see our research institutes, each focusing on different parts of the AM value chain. So we have a very broad expertise, may it be in metal AM, may it be in polymer AM, and pre-processing, post-processing. Each of our research institutes has different focuses so that we are able to provide expertise in all challenges along the AM value chain. So summing it up, you could say that the ACAM is your one-stop shop for additive manufacturing, may it be for research, for consulting, education, or engineering. So let's dig a bit deeper into additive manufacturing. Probably, I would assume that most of you at least are a bit familiar with AM since you're here at the Formnext today, but we'll start off pretty basic. I'd like to start off with a definition of additive manufacturing. So there are many different definitions on the market. I'd start with the one from ASTM, according to which additive manufacturing is defined as the process that produces components from 3D model data by joining material, usually layer by layer, as opposed to subtractive and formative manufacturing methods. According to the VDI 3405, it's a manufacturing process in which the workpiece is built up in successive layers or units. So pretty basic, the definition so far. And on the right-hand side, you can see a couple of AM principles in life. So just giving a short overview on what makes AM different from subtractive or formative manufacturing, as most of you probably know, but anyways, so if you look at subtractive manufacturing technologies, you have a geometry, you have a defined workpiece, and you generate a new workpiece by just removing part of material. For example, milling or turning work that way. And then if you look at formative manufacturing, you have a given volume that you just try and put into a different geometry, like molding or deep drawing, for example. And then we have additive manufacturing, which, like we just learned, builds a part by stacking volume elements, usually layer in layer. So let's take a look at the global interest on AM according to Google Trends. On the left-hand side, you can see what the global relative interest is according to Google Trends. And we differentiate it in additive manufacturing and in 3D printing. And the yellow graph is 3D printing, and the purple graph is additive manufacturing. And the reason why the results for 3D printing are so much bigger is that 3D printing is just the more common term. Additive manufacturing is the more research term, and 3D printing is just what everybody pretty much knows it by. But what you can tell for both 3D printing and AM, that there is an overall positive trend of relative interest in all online search engines. So we started looking from 2010, and we finished in 2021, and you can see that there is a steep increase of interest in AM. And especially since 2013, 2014, you can see that steep increase of interest. And one time, Barack Obama said that 3D printing has the potential to revolutionize almost the way we make almost everything. So the question is, what is true about that statement? So there's different opinions. Some people say AM has the potential to provide solutions for everything. Other people say that it's just a big hype. And probably the truth is somewhere in between. And I think you can also tell that when you look at the fair, that the AM market knows what its challenges are, and that they are working on providing solutions to solve those challenges collaboratively. But then again, AM definitely does have many high potential that can be seized. And that's also what I would like to show in this seminar today, that additive manufacturing has high potential and offers many chances if you're able, or if you get enabled to seize those chances. So let's take a look at the positive historic and future development of the AM market. What you can tell on that graph on the left-hand side, that the market size has been constantly growing since the past decades. The Wohlers report stated that during the last 20 years, there was an annual average growth of about 20% of the AM market. And you can tell that pretty clearly on that side. We have different reports and graphs included, but all of them state that there has been a positive growth rate, and also predict that there will continue to be a positive growth rate. And the reason that the forecasts are diverging is because the market is pretty volatile and uncertain. So some markets predict a better growth, others predict a smaller growth. But all in all of them predict that there's going to be an increasing growth of the AM market. And included revenue here for those graphs or from the primary market for AM systems, software, material, and services. So let's take a look into which industries use AM already. AM is no longer just a niche technology like it was 30 years ago or something, and it's no longer just used for prototypes. So if you look at the different industries that AM is used in, and that's a survey from the Wohlers report, and they considered revenues generated from AM service providers, system suppliers, and third-party material suppliers, you can tell that there's a very spread use of the technology in many different industries, and a high share have the automotive or the aerospace industry with about 15%, but AM is also used in academia and medical and dental, for consumer products and electronics, power and energy, for military reasons, architecture, and many other industries that aren't included because they have a lower share. But for example, in the marine industry, AM is also being used, and it continues to be used even more. So now that we kind of know which industries AM is used in, let's take a look at the general process chain. And that's something that a lot of people underestimate. Additive manufacturing is not just I print a button and I have a part that comes out of it, but it involves a pretty complex process chain that's divided in pre-processing, in the actual in-processing, in a post-processing, and in work that you have to do when you have the final component. And it always includes a physical and a digital dimension, since AM is a pretty digital technology. So if we look at the pre-processing, what needs to be done before you can actually print a part? You have to make sure that you prepare the material that you need. You have to make sure that you prepare your production facility and that you prepare your machine. And again, on the digital side, you have to make sure that you have all the data that you need in order to prepare that part, both CAD and CAM data. You have to prepare your build job. You have to make sure that you have your production planning going in order to be actually able to print that part. So after you've done all that pre-processing, you go into the in-processing, which is where the part is actually generated, so where the physical generation of geometry takes place. So just like we just learned, where the component is built, usually layer by layer. The digital side on the in-processing is rather low. It's just executing the machine code that's been generated before and monitoring of the printing process. And then comes one of the biggest pain points in additive manufacturing, the post-processing. Because the post-processing, according to the technology and use case and part requirements, can be very extensive. It includes, for example, the build job removal and the cleaning of the part, but it also includes the part finishing, which can consist of many different process steps according to the industry, the use case, and the part requirements. Some steps just include, for example, support removal, heat treatment, surface treatment, or quality assurance. And in the digital dimension, you try and gather as many data as possible for quality assurance. And then when the part is done, you have some other steps regarding the final components, such as assembly, if necessary, labeling, packaging, and shipping, and also evaluating the data you've generated for longer-term improvement. And it's very important to understand the AM process chain and also to take into consideration the entire process chain when you try and design a part. Because what happens a lot of times is that people have a great idea for a part and they start with the pre-processing, they print it, and then they're kind of lost because they didn't take into consideration that there needs to be done something to the part when it's done. So it's always important to incorporate this whole thinking of pre-, in-, and post-processing when you actually think of a part that you want to manufacture. So just as a quick summary of the last few pages, what are the key characteristics of additive manufacturing? Additive, obviously, so the material is, the geometry is built by adding material instead of removing or forming. It's a toolless process, so meaning that the part geometry is independent from any tool, so you have almost any freedom of design. You can produce very complex parts and are not limited to any expensive or time-consuming tool generation processes. Then it's digital, so it's a direct manufacturing process based on 3D models. And it's kind of complex. If you're new to AM, you'll realize that there is a lot you have to consider, and especially that you require specific expert knowledge regarding the entire process chain. So if you're a designer or engineers have been designing parts the same way for 40 years, it's going to be difficult for them to just switch to an additive mindset. So you have to take into consideration that additive manufacturing is kind of complex depending on the technologies you're using, and that you need to take measures accordingly to successfully use AM. So last but not least for that chapter, let's take a look into the benefits and barriers that AM offers. And again here, it's important to understand that additive manufacturing benefits and barriers are not generic. So they are very specific according to the technology you're using, according to your use case, and according to the process chain that comes with it. For example, if you want to produce a prototype, of course, you have different requirements compared with the series part that you print in very high volume. But what are general benefits? General benefits are you have a very high design freedom. So you're able to produce very complex features. You can produce lightweight components and monolithic features. You are very flexible regarding design iterations. So if you say you don't like the geometry, you just have to change your part data, and you can just print it over again. You don't need to produce any tool or spend a lot of time before you can have any engineering changes made. You can integrate functions. For example, if you want to have a cooling channel in a part, you can just change the design in a way so that you can integrate cooling channels, which is probably not possible if you just manufacture it conventionally. You can have small quantities and individualization for, almost for free or at least economic compared with conventional manufacturing. You have very short time and efficiency idea to product. You have a short supply chain. And you have more ways to be sustainable compared with manufacturing technologies that have been established for many centuries. But if we take a look at the barriers, we also see that additive manufacturing has not only benefits to offer, but also barriers you need to take into consideration. For example, the printing times are fairly long, depending on technology. So if you have a large metal part, it might easily take 24 or 48 hours in order to just print that part without the post-processing. The printing times can be pretty long. You have almost no economies of scale. And depending on the part, on the technology, you might have low surface quality, which you need to take into consideration for further post-processing steps. It requires an additive mindset and skills that are adapted to AM. And also, what you need to take into consideration is that AM demands you to transfer different health and security measures than other technologies. For example, if you work with metal powders, you need to take into consideration how you can protect your employees. And the last point is that the quality assurance and certification can be rather complex depending on the industry that you want to use additive manufacturing in. So summing up what we've just learned, we've learned what additive manufacturing in general is. We've learned what the general process chain looks like, and we've learned what can be different benefits and barriers of AM. And to understand those benefits and barriers, it's very, very important to successfully use AM for your own purposes. So now I'd like to go a bit deeper into additive manufacturing technologies. And to those watching online, I might not be able to finish due to the time, but I'll just start and we'll see how far we get. So if we look into the established metal AM technologies, there are many different ways to categorize AM technologies, but we've followed here the Formnext AM field guide and also the DIN and ISO terminology. So there's different ways to categorize AM technologies according to energy source, according to material deposition, or according to the raw material you're using. And according to this terminology, we have 5 big categories. We have the powder bed fusion, we have direct energy deposition, we have material extrusion, binder jetting, and material jetting. So how do those different categories differ? So on the left-hand side, we have a powder stock where energy is inserted in order to fuse powder to a component. So we have the laser powder bed fusion, where you use laser as an energy source. And we also have electron beam melting, where an electron beam is used as your energy source. And then in the middle block, we have the direct energy deposition, where we don't have a powder stock or anything, but the material is deposited with the energy source together. And then we have the material extrusion, where we have a filament that's being deposited. We have binder jetting, where we have powder that's bonded with the binding agent. And we have material jetting, where the material is cured with heat. I will go into more detail on some of those technologies in a minute. This slide was just intended to give you a general overview on metal AM technologies. And sometimes within the terminology, there are different terms for the same technology. So laser powder bed fusion, for example, sometimes is called selective laser melting. Some terminologies are trademarked from different companies, but this is the official names that are used in the norms. So if we look into the segmentation of established polymer AM technologies, we have 4 big categories. We have the powder bed fusion, we have material extrusion, we have material jetting, and we have photopolymerization of resins. And again, according to the metal part, on the left-hand side, we have the powder bed fusion, meaning that we have a powder stock that's being fused somehow. We have the multi-jet fusion, where the powder is fused with an agent and energy, and we have selective lasers entering, where the powder is just fused with the laser. And then on the middle part, we have material extrusion, where we have a filament or a granulate that's being melted and deposited and solidifies when it cools down. So we stack the building layer by layer, either through filament or pellets. And then we have material jetting, where material is cured with UV light. And on the right-hand side, we have processing of resins, either cured with laser or cured with the projector. So it's important to understand that according to each technology, we have different principles of inserting energy. We have different options to produce raw materials. So we have pellets, we have filament, we have powder, for example, resins. So we're not limited to one type of raw material. Each technology uses different kinds of raw material, and it's important to understand which technology uses which material stock. So I'll just start with going a bit deeper into the technologies, and probably the live stream will be cut off after the metal part. So like I said, we don't have enough time to go into detail of all the technologies, but I'll go a bit more into detail on the laser powder bed fusion, the laser metal deposition, the ELA process, and also binder jetting. So if we look at laser powder bed fusion on the right-hand side, you can see the process in action. So how does it work? You have, as input, you have the digital model, the digital data of the part, and you have metal powder. And then it works in the way that powder is deposited, just one layer of powder according to the thickness of one layer you want to have. It's selectively melted by terms of a laser beam, like you can see on the right-hand side. And then the build plate is lowered exactly by one layer strength, and the whole process starts again. So that subsequently you build up your part layer by layer, and then in the end comes a bunch of post-processing. For example, you need to get rid of the powder that didn't get fused. You have to might have to finish the surface of the part. So like I said earlier, there might be multiple steps involved with the post-processing until your part actually gives you the required, the requirements that you wanted for it. Laser powder bed fusion requires support structures for overhangs, for heat convection, and also to stabilize the part within the powder. So you always have to make sure that you tie those parts physically to the build plate instead of just placing them free within the build chamber. One advantage of laser powder bed fusion is that it has a general suitability for welded materials. They have a very high material choice. For example, you can use steels, you can use nickel-based alloys, you can use copper, titanium, aluminum, magnesium, doesn't really matter. You're not really limited in choice of material. Laser powder bed fusion is the technology that's mostly used in industrial applications, so it has a very high process maturity. For example, AM Power always publishes a report on the technology maturity of different AM technologies, and laser powder bed fusion is the technology with the highest technology maturity reached, so it's a very stable process. Downsides of the process are it's relatively slow compared with other technologies, and you always, like I said, need to make sure that you tie the parts to the build plate, so you can't nest parts three-dimensionally inside the build chamber, but you always can stack them only two-dimensionally. All right, let's go into laser metal deposition, which process you can see on the right-hand side. Differing from laser powder bed fusion, you don't have a powder bed that's being fused, but you also have metal powder as input material and a digital model. And the way it works is the powder is in an inert gas flow, and it just gets, it gets put onto the substrate, and then it's successively melted. So differing from the laser powder bed fusion, you don't have a powder bed, but you just apply the material with each layer that you are that you're generating. And laser metal deposition is mostly used for AM, for additive coating, or for repair. And like I said, the powder is transported by an inert gas flow. And the energy is mainly deposited in the substrate, not directly in the powder. And again, it has general suitability for weldable materials, such as steels, nickel alloys, or aluminum alloys. It's much faster than laser powder bed fusion, so you have a much higher deposition rate, which is one advantage, but you're limited in the geometry that you're able to process compared with laser powder bed fusion, for example. So let's take a look into ELA, which is extreme high-speed laser metal deposition. It's the same principle pretty much as LMD, but it works only, or at least that ELA process works only for rotationally symmetrical parts. It has higher process speed than LMD, and you can apply very homogeneous coatings on those rotationally symmetrical parts. Again, the powder is transported by an inert gas flow, and ELA is something that's starting to come up more when you look into coding applications within AM, so it's a technology with high potential that's expected to be used in industry more in the future. So now for the last part of the live stream, let's look at binder jetting. There it works, okay. So like laser powder bed fusion, you have a metal powder bed, so you have powder that's deposited layer by layer, and the digital model as input. And then the way it works is the build platform is lowered, powder is deposited, and then a binding agent is applied. So instead of putting laser or an electron beam on top, you fuse the part by applying a binding agent. Binder jetting has the advantage that you are able to process very complex geometries. You don't need any support structures for that technology. And you can nest the parts three-dimensionally within the build chamber, so you're able to place many more parts inside compared with laser powder bed fusion. Downsides of the process are that when you have the parts, they are in a green state and very fragile, so you have a very extensive post-processing that you need to perform in order for the parts to give them their original functionality. For example, the curing, depowdering and sintering to make sure the parts are no longer fragile and that you can actually use them for the use case you intended to do them. So compared with LPBF, binder jetting has lower technology maturity and less materials qualified, but it has a potential of higher productivity compared with laser powder fusion. So thank you for everybody watching online, and have a nice rest of the fair.
Yeah, it's your applause. Thank you very much, Victoria, for these insights and these learnings from you. While there will be a short break in the live stream until 2 p.m., the second part of Victoria's presentation will continue in the hall here. And for all these guys over there which came late, as this is a silent seminar, make sure that you grab your headset over there and you can follow the second part of Victoria's presentation. Yeah, the audience outside there in the YouTube stream, we will see each other again on time at 2 o'clock, and then we will get some expert insights how to reconfigure international supply chains. We will see us.
Watch me pay the curse, I don't break reports. I'm moving on. I'm moving on. Got nothing left to say. Must be on my way. Best of luck. I'm moving on. Oh, I'm moving on. I'm moving on.
So hello, dear viewers of our live stream, and hello, audience here at the AM4U stage. I hope you had a wonderful lunch break and are ready to get more highlights here from the AM4U stage at Formnext 2022. We will start the afternoon with an exciting expert insights, and I would like to introduce to you Dr. Jennifer Johns from the University of Bristol, UK, who will introduce us to the topic Reconfiguring International Supply Chains, Distributed Manufacturing, and the Role of AM. I would like to encourage you again to follow carefully and ask questions via the comment function, because then I get them live here on the screen and can ask Jennifer afterwards your question here on stage and get your answer. So please, welcome with me, Dr. Jennifer John. Jennifer, stage is yours.
Thank you.
Clicker, by the way.
Thanks, everyone, and good afternoon. It's a real pleasure to be here today at Formnext. I've been coming for many years and watched this great trade show grow. I'm here on behalf of a team of people. We have a booth over in Hall 11.1, so please come and see us. We're an interdisciplinary team of engineers and people from a business school, so I'm a management scholar. And we're using interdisciplinary approaches to try and solve some of the world's real problems and challenges for manufacturing at the moment. And we're all quite aware of trends and issues and problems in supply chains. And I wanted to make today a connection for us between those supply chains issues and how it creates challenges, but significantly opportunities for additive manufacturing. So I'm going to talk through today some of the patterns of the changes that we're seeing in supply chains and thinking about some of the ways we as academics are working with industry to come up with solutions to help further application and the development of additive manufacturing. So please do come and see us if you want to see some of the work we're doing. I'll talk more about the project at the end in brief, but I wanted to set that broader context for us today about the contemporary global economy and situate some of this amazing technological activity we see at Formnext in the bigger picture around the global economy. So I don't really need to tell the audience that we have supply chains now that appear to be more vulnerable than they have been in the past. This is through a combination of different factors: environmental challenges, COVID challenged our supply chain networks, and we're seeing issues around our logistics, and we're having some downstream supply problems. I've been using the Ever Given as my graphic for a while. I thought change was needed, so I have this cargo ship tipping over. And that symbolizes for us some of the very real everyday challenges that firms globally are facing around their supply networks. We can broadly characterize longer supply chains as being more vulnerable. It's harder to monitor and control your relationships with your suppliers if they're more geographically extensive. That's a broad assumption, but it can present challenges, and it also can be harder for you to monitor the quality of your supply when you have extensive, geographically extensive supply chains. We know from the work that we're doing with businesses that there's now a tendency for within firms to question the models that they're using to make their offshoring supply decisions. There has been a propensity in the contemporary global economy for companies to offshore based on calculations and modeling that sometimes can overlook some very significant dynamics. One of those can be supply issues. It can also be the costs of maintaining those extensive supply chains. And we know from our conversations that firms are having very intense conversations at the board level often and through their procurement departments, questioning some of the assumptions around offshoring and sourcing in low-cost economies can actually be not necessarily the right solution for firms. Some of this predated COVID, but COVID has exacerbated this. I also wanted to highlight how there's a broader context here around consumption patterns and what the consumers desire, thinking about that final end product. And we are seeing changes in consumption patterns, changes in the expectations of consumers. There's this term, the prosumer, and this is putting together production and consumption, which is in a way going back to the very start of 3D printing with the hobbyist maker spaces, about how you could design and manufacture something yourself, and essentially bypass the whole value chain of production. We're not there yet. We might be with a couple of things, but broadly speaking, we're not. But there is increased demand for customization and demand for speed of delivery. So we have to overlay these understandings of these supply chain challenges with what the end consumer is also expecting from those supply chains. I wanted to think through how we can characterize global production, and I'm going to talk about centralized, decentralized, and distributed manufacturing. And from what I've observed within manufacturing and additive manufacturing is sometimes a confusion and overlap of understanding about what those three terms mean. And I think it's really important for us to understand those spatial dynamics so we can understand where AM can be deployed in order to change and improve supply chains. Now, this is showing centralized production. So the graphic is stylized, it's simplified, but this idea is of a central hub that is supplying other places. Now, you could very easily see that central hub as China, the world's global factory, producing and sending out manufactured goods to the rest of the world. And this is part of a broader change through globalization, what we call the new division of labor, where we see manufacturing being located in low-cost countries, because a high percentage of production costs can be through labor. So we do see higher value activities sometimes remaining in advanced economies, and we can see a space for AM increasing the amount of those higher value activities that stay in advanced economies. We are seeing a lot of rhetoric about how some of those activities could be reshored, and I'll talk about that in a moment when I talk about decentralized production. Now, of course, all of this and globalization has been facilitated by communication and transportation technologies to support these very long, geographically extensive supply chains. And this is where the vulnerabilities are coming now. The technologies are there, but we have pressures on these supply networks that is in some ways encouraging us to think about this centralized model and whether it's sustainable. And I use the word sustainable as well in the meaning of sustainability and thinking about whether this is having too heavy an impact on the global economy in terms of environmental cost with these extensive supply chains. So we're seeing multiple pressure points asking us if this centralized model is the most efficient and effective way of producing. So that's the status quo, and now we're starting to have conversations about different models. And we're seeing some trends in the global economy that are sending us towards decentralized. But I wanted in this talk to emphasize the difference between decentralized and distributed. So first, if we look at decentralized, there's often in academia, which hasn't filtered into industry, been a conversation, a debate actually about how global the global economy is. And many academics argue that we've always had a regionalized global economy. And we can divide those regions broadly into the Americas, Europe and Africa, and Asia. And you can actually, if you look at a lot of trade data, see that most trade is between the triad economies of North America, Europe, and Japan and China. So is anything new happening? I think we are seeing a shift more towards decentralized production. And here you can see from the diagram, there's more nodes of production. And you're not seeing many of these the dots, the smaller dots, are sourcing from the nearest hub. And we're not seeing many firms, many countries or places connecting into more geographically distant. So you're sourcing from your nearest hub. This is kind of a hub and spoke model. This is reducing supply chain length, but it doesn't necessarily mean that your supply chains are short. They're just relatively shorter than they would have been if you were traveling the whole globe. So not all problems are solved through this model. It does distribute production more across the world into smaller hubs. Now, if we reflect on what this might mean for additive manufacturing, I don't see any substantial changes in the conversations we would have around additive, its application, or its adoption in this context. It's very much just a breaking up of the status quo into a more regionalized system. Now, thinking about the world now, this mess, this complicated mess, which is supposed to be a stylized cleaning up of the messy reality of supply chains, sees centralized status quo overlapped with decentralized. So in the confusion and the pressure and the vulnerabilities of supply chains, we're actually seeing multiple supply chains overlapping each other. So firms are now having to rely on 4 suppliers. We know that we used to use dual sourcing, and we are seeing more dual sourcing, but we're now seeing also multiple layers of sourcing, because you can't rely on just 1 or 2 suppliers. Some of those supply chains will be extensive, so you may have a supplier that is from China, where it will be cheaper, but you're conscious that that shipment might not arrive, or it might be not of the right quality. So you then have to support that with a more local firm, or firms. And those are often backup arrangements. And we know that firms are spending quite a lot of time worrying about their suppliers and ending up sometimes being dependent on one supplier, and that's causing friction and tension within manufacturing. Now here there's a clear role for additive, particularly in these local suppliers, who may be called upon at quite short notice because another supply relationship has ended. So a clear role then in terms of immediate need. And this speaks very much to the rationale of additive in terms of flexibility and speed of delivery. I wanted to also mention some of the rhetoric around reshoring. I'm from the UK, so I'm very conscious that there's a lot of political interest in reshoring, simply because the government hopes that it will solve all the problems of Brexit. And I'm not going to speak for the remaining 23 minutes about Brexit, because I might cry. But very politicized conversations around the idea of bringing back manufacturing from less developed nations back to advanced economies. And we're seeing lots of countries like Singapore, the US, Japan, investing quite a lot of money in the idea of reshoring manufacturing. Where this is being discussed in the firms that I talk to, we're seeing some interest in the idea to reduce these supply chain vulnerabilities by bringing things back. But as an academic, conceptually, I struggle with the idea of just picking up production and bringing it back, because it probably isn't coming back. It probably never was in the advanced economies. And actually, it's probably going to be manufactured in rather different ways when it comes to advanced economies. That is because if labor costs are particularly high in the advanced economies, then there's an interest in reducing those labor costs. And this is where digital technologies can be very important. So there's a clear involvement and rationale for digitizing your production, your manufacturing, and a real opportunity for additive manufacturing to produce things differently if they are returning back to advanced economies. So at the moment, we see this complexity and this mess, and it feels like an opportunity because so much effort, money, and energy is wasted on these very vulnerable and confusing supply chains. What we do tend to see is a kind of status quo, a kind of real resistance to moving away from centralized production. And what we as researchers are interested in what the barriers are, what the challenges are, and what the opportunities might be for a world that looks rather different. And this here is what the world could look like. So again, more hubs, but here many more hubs. And connected in a peer-to-peer network. And this solves many of the challenges that we're currently seeing. There's few geographically extensive connections, and it reduces dependency. The peer network is able to work more collaboratively in order to produce and supply. And geographical scale will matter here as well. We've gone from looking at the world and China as a hub, and actually you could overlay this distributed network at any geographical scale. This could be operating across North America. It could be operating across Greater London, for example. And when we're talking about sustainability, we would be hoping that this could be operating at a more local level in order to reduce the miles that products are moving. If the supplies are more local, then we can speed up supply, and it could be more efficient. Now you see I've got some question marks thrown in there, and of course in some ways we're making some assumptions because we need to start implementing this at particular scales and starting to see how it works. So I'm raising some questions really. We would hope it would be more efficient. Does it reduce environmental impact? Now, of course, if the miles traveled are being reduced, then that, of course, is going to help. The idea would be to have a producer and the consumer being proximate, being geographically proximate. Of course, if we start looking at this model, we then start to pay greater attention to the material supply chain. And then we will still be seeing probably extensive supply networks of materials that are supporting this distributed network, because the global distribution of materials is not geographically even. This challenges conventional supply chains and value chains. This really is a different view of the future, a very radical way of understanding how the global economy could be organized. And there seems to be a lot of resistance, from that centralized model, and drifting towards a decentralized model because somehow that fits our conception of how the economy works, and our minds can't quite get to thinking about this distributed model. I've raised a question as well of what happens to volume levels in each production site. There are some good reasons why particular things are produced in particular places, to do with specialization, to do with labor, to do with skills. So there's some quite significant challenges about the people and the companies that are needed to support this distributed model. So, thinking then about this possible shift from centralized production and how it occurs. Now, in the brackets, I've put for whatever reason. And sometimes that's because when we're thinking about these possible changes, we often wonder what the drivers could be of those changes. Now, I would love to be able to stand here and say that digital technologies themselves, including additive manufacturing, could be the driver for a change towards decentralized manufacturing. Unfortunately, I don't actually think that additive manufacturing or digital technologies together will be the drivers. I think that far more catastrophic, potentially, phenomenon, things like climate change, environmental disasters, are likely to actually be the drivers that are going to cause the impetus to want to have decentralized production, but that additive manufacturing could be one of the technologies that enables that once those drivers occur. In that scenario, we can think about labor costs. I've covered the idea that actually if your labor costs are going to increase, if you're reshoring activities, this opens up an opportunity for additive manufacturing to reduce those labor costs. Now, we all know, and we can look around the booths, and we can see that there have been, over the last couple of years, particularly significant advances in the automation around additive in order to fit into this idea of a factory of the future. But in order to reduce the amount of human input that is needed into additive manufacturing. And that's really crucial when we're thinking about these geographical shifts in production. When I come on to talk about our team and the work we do, one of the things that why we have people from a business school is also to remember that there are humans involved in production and to think about what that human involvement is and what it means to the broader system. Scale. And I mentioned that you could overlap this decentralized network and how we actually start to research how this could work and what the ideal scale could be for a distributed system. I think in some places the scales could be larger and in others they could be smaller. I think that's probably quite geographically specific. I think I say on the slide that there's a chance there for additive manufacturing to become more competitive as scales are smaller if these networks are very responsive and based on immediate need and demand. Of course, those of us who work in AM know about lots of talk and progress made in spare parts. It's considered one of the applications that AM could really significantly contribute to. And so work around digital inventories, spare parts, stopgap manufacturing means that there are opportunities as we are, because there's always going to be transition. We're not going to wake up one day and have decentralized or distributed production. There will always be transition, and that will take a very long time if that is where the journey ends. So additive could be really important during times of uncertainty and change. Constraints. So when we have these conversations, there are often many people who say, but, and there are many constraints. And we acknowledge that in our project. And we've written already about some of these constraints as we see them, what the barriers are to a distributed system. The diagram, which I hope you might be able to see, it did need to be a bit bigger, I think, is just something that I drew up to start thinking about how there's lots of conversations about these kind of distributed ideas at different scales. We have at the city level, things like Fab City, where you're trying to have circular economies and closed-loop systems in a distributed system within a city. Or that could be at the region or the nation. A lot of the political dialogue and conversations are about a national scale, about self-sufficiency for national economies. That certainly is the rhetoric in the UK. But then also up to a regionalised area within trading blocks, perhaps within the EU, for example. Coming back to the constraints, we see issues around governments and regulation, particularly around intellectual property rights, also around the information that you need to share being connected into a distributed network. As I've already emphasized, suddenly our emphasis thinking about materials and material supply chains, how raw materials are actually being shipped globally to support a distributed network. In no way would a distributed network be entirely self-sufficient unless it happened to overlay a geographical territory with all the materials that were needed, which is highly unlikely. So logistics become very important, particularly in pre-production. And if you're more localized to your consumer, your logistics at the end of the value chain become less significant, and they become more significant around materials. There's also issues around standardization and certification, around process development, emphasizing the importance of design for additive manufacturing. Infrastructure. Do particular countries, regions, territories have sufficient manufacturing capability and the labor force that is needed? One of the concerns in the UK around reshoring is that firms are wanting to bring back some production and they're unable to, they don't know how to find suppliers. They're not connected into local manufacturing. And there is an organisation, Reshoring UK, that's trying to match up that production. But of course, it's a sector that's been underinvested in the UK for many decades. What is local? So often around sustainability we talk about local, and this diagram speaks to actually at what scale are we talking about. But then also thinking that there's a lot of uncertainty around what this means for companies and how they manage their business models. So that's another reason why we as people from business schools feel that we have some things, important things, to say to the AM community. So our project then. I promised to leave that to the end, and I've given you the context. I'd been working on additive manufacturing, looking at its capability to change the geographies of supply chains since about 2015. And I did much of that work on my own. My background as a geographer, so I'm very much interested in the spatial dynamics of how the global economy works. Then COVID hit, and there was lots of talk around PPE, and there was funding, government funding for academics to help with the crisis. So I put in a grant around additive manufacturing and sharing best practice in the UK. It was unsuccessful, as were most applications. 0.6% were successful. I then teamed up with some colleagues, some of whom are sat over there, hi, and they're in the engineering school at the University of Bristol, and we put in for a different kind of, a similar grant, also unsuccessful, but you keep trying, and we finally got some significant EPSRC funding for this project called Brokering Additive Manufacturing. And it brings together us from a business school and the engineers to work together to look at a cloud and agent-based distributed model using 3D printing with industry partners and engagement. We very much have to ground our ideas around what this distributed model could look like in the realities of what's happening in the business environment. So our business partners, our industry partners are really, really important to us. What we're doing is developing the theory, models, and technologies to make the AM machines think. At the end, I'll put where our booth is, and we have some prushas that are all speaking to each other and printing. The printers are self-aware, and we're working with the parameters that you can give these machines, that you can set for them. Thinking about how long, the length of a print that they might want to accept. Thinking about what materials they might be using. You can link up to the cloud and pull down jobs based on that set of parameters. They are communicating to each other through the network, and they're linking to the cloud. And they're competing for jobs. So the jobs can also think, evaluating which machines to be manufactured on. So the rationale around our funding was actually talking about the UK context and thinking about how we could utilize the additive manufacturing capability that exists in the UK. And we were particularly interested in times of peak demand. So our starting point was PPE, but we acknowledge that PPE is hopefully a one-off and quite peculiar, but demonstrating this idea of industry coming together, changing supply, changing production methods in order to meet some peak demand. We're also modeling different types of peak demand and thinking about how AM can be mobilized during those times. One of the reasons for that is that some of those constraints evaporate if you're operating in times of critical need. It might be that you're a bit less price sensitive. It might be that firms can collaborate in different ways that they wouldn't in the everyday. So we have found that these firms can work together to create the ephemeral supply chains, doing what's best for the network. So the network's resilient, scalable, flexible, secure, and responsive. And the control and the governance of machines remains with the owner. Now, when we come to trade shows, we start to see that actually, although we needed this rationale for the funders about UK manufacturing capability, of course this isn't a story that's unique to the UK, far from it. But also there are some significant constraints, like many firms would not want to connect their machines to a cloud, for example. But we're starting to see ways in which actually this technology could be deployed within firms or within collaborations of firms to form distributed networks. So there's many different segments and different levels, layers at which this distributed technology could be deployed. We're empirically testing a lot of our assumptions around the opportunities and the constraints for this. We are going to be setting up machines in different places across the Southwest, across 4 different universities, all speaking to each other, but geographically apart. As I've said, we're exploring the parameters for these machines. So, our findings so far. With across additive manufacturing, we've been going around and interviewing firms in the UK, talking to them across the value chain, different firms, 3D printing machine manufacturers, material suppliers, covering the value chain of additive manufacturing. And there's a lot of interest in this idea, which resonates with some of the assumptions that I've been making about the challenges around manufacturing in general and the global economy. And there's quite a lot of excitement about the idea, but what we have got the impression is that when we're talking about this idea to firms, they think that this is something that could be happening in 10, 15 years. And what we're now trying to emphasize, and the reason we're here talking to everyone, is saying this can happen now rather than in the future. There are concerns around connecting to clouds, there's issues around security and issues around quality. So in no way do I mean to stand here today and say that we have all the answers. It's very much a starting point, and we acknowledge these constraints. But a collective understanding of them could work towards some solutions. And I think that solutions are probably different in different contexts in order to make this work. I get the sense there's a kind of lack of awareness of the different scenarios under which this model could work. As I said, there's the everyday. Could this work within a firm to help you manage your jobs, prioritizing jobs? The machines will decide for you which order to print. And it takes away some labor, some thought, and the machines are controlling that. Is this occasional? Could there be scope for a firm that does their everyday production but then collects to the cloud to do some production overnight? An extra revenue stream, a way to make sure your machines are working for you. That could lead to more machines being bought, greater adoption. Is it exceptional and is it extraordinary? And we're, as I said, modeling these kinds of scenarios around peak demand where you could actually be ramping up, utilizing AM capacity in order to meet critical need at times of crisis. And we perhaps are heading towards more times of crisis. There is a general interest in extending the adoption of AM. I mean, that's why many of us are here. But I'm, in a way, preaching to the converted. I think there's probably quite a lot more work to be done in terms of reaching out to manufacturing in general and telling them about, talking about distributed manufacturing and also emphasizing the role of additive manufacturing, because I think there's still a lot more work to be done in really convincing people around the adoption of AM to helping solve a lot of these issues and problems. And of course, we do also want to emphasize our starting point is additive manufacturing because we think the technology is incredible, but also there's no reason why these networks wouldn't exist with other types of manufacturing technologies, and perhaps theoretically they should do. And of course, we're going to see lots of different geographical supply chain configurations that are driving the increased adoption of additive manufacturing. And if we look at the global economy as a whole, still the adoption of additive manufacturing is going to be geographically uneven. And perhaps these changes in the supply networks might lessen the divide between those countries where there's very poor adoption of additive and those where there's high levels of additive manufacturing. So I'd like to ask anyone who's listening if they'd like to get involved. At the moment, our conversations with industry have been based in the UK, but as we're here in Germany, I'm always very happy to talk to other firms and get an international perspective. We as a team will be applying for further funding, so this is very much a starting point for us. We will be looking at developing our software, our solutions around this. Always keen to talk to firms who think that they could use or supplement or complement. At the moment, we're using open source software and we developed our own. We can come and see the Prushas speaking to each other. We're in Hall 12.1, A132. So please do come and see us. And we've got 6 of us on the team who can talk to you in detail about anything you might be interested in. So the big clock counting down tells me I have 3 minutes, so I think I've done okay. So I'd like to say thank you very much for listening and perhaps a bit more time for questions. Thank you very much, everyone.
Thank you so much, Jennifer. Exciting presentation. Any questions here from the audience so far? My question would be, Jennifer, if I heard about the product, it sounds a little bit like to me like a platform for me, where I can send in an order. The platform looks for the perfect printer or perfect setup to print out my parts, and then I get it back, right? Is that the right understanding? So first question would be, what is your interest as university to step into something? And I mean, it has a commercial focus. And let's say this experiment is super successful. How is this then transferred into like in an economic environment? Don't get me wrong. I mean, you can't do it university-based for ages. So is there like a step afterwards where you bring it into real life?
Yeah, the project only lasted 18 months. Significant funding, but still only over 18 months. So really for us, it was a kind of a proof of concept, really, to get the machines, to get them speaking, and then engage with industry to think about what the challenges are, where we might head. Yeah. So the emphasis now is on us as researchers to gain further funding. And we do that by connecting in and saying this is how we can solve significant issues that are challenging manufacturing. The process then to commercialize that is rather different, and that's where my engineering colleagues take over.
Okay, very good. And the next question, I mean, there are companies like 3Mind, for example, which today do exactly the same. But
if you think about 3D Printing Hub, where you said you'd get the product back, this is where the product might not come back to you, it might go somewhere else.
Yeah. Okay, so it's a different approach, you
Yeah.
think? Okay. Then the next thing is, I mean, you were talking a lot about labor costs and the reason why we moved to China, and I totally agree in the fact that it will be probably only the crisis that bring us a step further into the development of additive and reshoring. The other side, in my opinion, is always we tend to forget quite quickly as humans, and price is finally always the main argument that is driving us, because we as consumer, we don't want to pay double or 3 times the price. The industry wants to produce as cheap as possible. So how realistic do you see the whole topic of reshoring using additive manufacturing for the near future?
I think there's a very practical level, and actually a lot of academics are working on this assumption that supply chains are driven by profit maximization. And now as we think around a sustainability agenda, there are sectors where the value proposition of a firm can be more dependent on their sustainability criteria, and that means price is less important. And you can charge more for your product if your sustainability criteria are higher. So the business models can change, but I think still we're quite some way from that.
I mean, we just experienced here in Germany the example of Audi that claimed to be very sustainable focus, and they enter Formula 1 again in 26. So this is a highly discussed topic at the moment. So the topic of greenwashing is all around us. So it's really interesting to see what are the real powerful interests and drivers in the end. But I'm totally with you. We all would be glad to drive the topic of reshoring and having such concepts.
Yeah, I have a
in
PhD
place,
student who's halfway through a PhD looking at reshoring also in Brazil, because we're very conscious that the story around reshoring has been about bringing manufacturing back to advanced economies. What happens in the global south then? So my student's from Brazil, so she's going to be looking at manufacturing and textiles in Brazil and the UK, interviewing firms and following these supply chain arrangements and seeing what's happened. Her initial observations at the moment is towards this decentralized regional systems where the reshoring's happening across Latin America and Central America.
Yeah, but last question, is that something that you consider in terms of what would be the impact on the world economy afterwards? Because of course it's super logical to do reshoring and bring it back and do it professionally there, but what happens with countries like Brazil, for example, that are dependent on the productivity level and amount they have today?
I absolutely have no idea what the answer to that question is, and I wish I had a crystal ball.
Well, but it's good.
Academics tend not to make predictions about the future because it's written down, and then we're held hostage to what we said 5 years ago.
So let me sum up. As I said to you before the speech, that I was very excited about the topic, and you met all my expectations, over-exceed them. So super happy that you had you here.
Thanks for inviting
Thank you so much for being with us. Jennifer Johns, please.
Thank you, everyone.
Applause. Thank you. Thank you. So, ladies and gentlemen, we proceed with the program of today, and we are going to look into a very interesting country that we are partnering this year, and this is the country France, because it's one of the most important countries if it comes to additive manufacturing in Europe, and they are strongly represented at Formnext this year. And this is why they are our partner country, and we want to give them a stage here at the AM4U area and get to know some of their exciting companies, research organizations, university, and different sectors they are presenting to us. And we do have a highlight block yet. So stay tuned and you will see all this after our highlight block.
Welcome to this exhibitor focus on Formnext TV. We are here at Discover3D to learn more about their metal printing solution.
Discover3D is a metal additive manufacturing technology company that is focused on allowing our customers to print the parts they really want to print and to do so as they scale into production.
Can you tell me what exactly makes the Sapphire family fully integrated?
So the Sapphire family is really part of a system where the system includes not only the hardware, which is the Sapphire family of printers, but also the software. Both the print preparation software that you use to prepare a file for printing, and Assure, which is the quality assurance and control software that's used to give insights into the machine, into its operation, and into the quality of parts. So with that entire system, you have this integrated end-to-end metal AM solution.
In the industry, process reliability is a very important issue. How does Velo3D reach this goal?
Yeah, process reliability is critical. And one of the main things that we do differently than other systems is to provide this fully integrated metal AM solution. So that really starts with calibration of the system. You have to make sure that the machine is properly calibrated every time you start a print in order to know that the output of the print is going to be good. And then we also have the software on both the print preparation and the quality side. So you have a continuous digital thread from basically the CAD file to the final printed part. So that helps as well whenever you're looking at the process reliability and being able to validate that a part is good at the end of the day.
What else makes the Sapphire printers different to conventional printers?
So a lot of our customers are able to use our systems to print parts that they would find very, very challenging on other people's systems. That's mainly around the geometric complexity that you can print, some of the low angles that we're very, very good at printing. And then also on the metrology side, I think we have the most complete set of metrologies built into the machine that allow the customer to have insights into all of these things that we talked about previously, the calibration, how the build was executed, and the final print quality.
Your printer family includes 4 different printers. I'm just wondering, what applications do they cover?
They cover a wide range of applications. We have customers that are printing parts from a variety of different industries, whether that's aerospace, defense, automotive, tooling, power generation, oil and gas. They really are useful across a wide range of different applications. And it really depends on kind of the size of the component that you're trying to print. And that's kind of what drives the decision between the different Sapphire printers.
This beautiful dress in front of us. Tell us about it, the technology behind it.
All right, so what we have here is taking the polyjet technology of material jetting and applying it specifically on the fabric, directly on the textile itself. By this, basically allowing the designer to, go wide with his dreams, with his designs, doing basically whatever they want.
How would you say does it fare in terms of sustainability? Are 3D printed clothes better for slow fashion?
Yeah, so 3D printing combined with fashion, I think, in my mind, is the next step in terms of sustainability and in terms of environmental friendliness, because this way minimize the production, everything can be localized, so no need, to start shipping things all over the world. So yeah, I think that's the next step in sustainability in fashion.
Hello, ladies and gentlemen. Welcome back to the AM4U stage. This year, more than 30 French companies, associations, and research institutions will be exhibiting at Formnext and presenting their range of services to the international trade audience. Reason enough for us to have them here on stage. The French AM sector will represent a very diverse portfolio of products and services along the entire process chain, from materials, hardware and software, engineering to post-processing and various services. French exhibitors will present their products and services at the Formnext French Pavilion in Hall 12C33. This afternoon, we will get the chance to get to know various companies and their products. Our first session this afternoon will be on the topic how the network of excellence in the field of AM research serves international products. And I welcome on stage with me the following speaker. To my left, Leo Talot Irma from the Institute Carnomica. Hello to Leo, good to have you here. Then we have Bruno Lessi.
Almost.
Almost. Lacy.
Kaisi. Thank you, Sven.
Okay. Sales engineer from the Institut de Soudure. Soudure. Yeah?
Soudure. That's
Soudure. Then we have Franck Simon, scientific coordinator, cluster CMS. That's correct. Thank you. Good to have you here. And we have Benoit Vacan, AM expert of CITIM. Great to have you here. Leo, we want to kick off with you. You have 4 minutes. Please go on with your presentation.
Okay, so hello everybody. I am Leo Talot. I'm a materials engineer at IRMA, which is part of the Institute Carnot-Mika. I will present you quickly a prototype that we made, combining FDM printing and low-cost AFP layup. So, AFP layup, automated fiber placement, which is carbon fiber placed on a mold by a robot. It's a very cool technology because it offers very high-quality composites. But it also needs very high-cost softwares, molds, calibrated materials. So for new markets that want to address the automated composites technologies, they are not able to pay for all that quality. So they need smaller parts. They need very short design to manufacture times. It is market that we have near IRMA in Brittany, like offshore racing, or design, or medical applications. So for all those markets, you don't need a metallic mold with 5-axis machining and 0.1 millimeter precision robot. It's a kind of craft composites. You need to address every client differently. So at IRMA, we do FDM printing. We make our custom machines, and we love the challenge of combining different techniques, like printing materials with carbon fiber inside. And for this project, the challenge was to produce the mold and the part in less than a week of work. So to do this, we designed a mold. The design is made on the Rhino 3D software. It's a double curvature mold, around 40 centimeters wide, with a hollow structure, and we use the additive manufacturing to make some reinforcements in the structure of the mold and to add some functions like fixture and probing points to the printed mold. So the printing takes place on a Stratasys machine, Fortus 900, and it's printed with ABS-based material, around 40 hours of printing, and then after that, to reinforce the mold, we pour epoxy foam inside the structure to make it vacuum resistant. You need, of course, a bit of surface finishing after. I apply epoxy gel coat. It's not the best solution. Next time, I will apply a PTFE film. And once you have the mold, you can do the programming. And one thing with this AFP XS machine is that you do the programming in the same software as the design. So it's a plugin named Add Composite, which is used for path planning and robot simulation. And all of that is in the same document than the design part.
Leo, you have 1 minute left. I need to be the nasty timekeeper so that the others can do as well.
Okay, perfect. So after a little probing and mold placement in the virtual machine. We can do the layup. You can see that it's a very little robot, but little robot equals little problems. So it's epoxy carbon prepreg, and then it's curing in an oven at a low temperature, around 80 degrees, with a long cycle, just with vacuum, no autoclave, no pressure. So you have seen just pictures of the part, and if you want to see the real part, you can come and see us at the Hall 12 and the booth C21. Thank you.
Thank you, Leo. Thank you so much. Sorry for interrupting, but I need to keep the timing. Bruno, stage is yours. Thank you so much.
Thank you very much, Sven. So, just expecting the presentation. Should I start? Or?
Yeah, you can click.
Okay, wait. First, I'm just, wait.
You can go back, yeah.
There is, thank you. Thank you very much, Van. So I'm really happy to be here today to give this presentation. I'd like to thank the Carnot Network, in particular Carnot Mika and Carnot ICL, as well as thank the organizing team. Thank you, Andrew and Van. And of course, I'd like to thank our partner, PCM, both for the trust in the project and for allowing us to give this presentation today. So PCM is manufacturing progressive cavity pumps for almost a century now, and the pieces that we have been working on are the rotors and the stators that you can see in this video there. Those are screw-shaped pieces, and their complexity is what gives the idea of doing this by additive manufacturing, specifically wire arc additive manufacturing, so WAM. So, as I told you, we did it in WAM. Why did we do that? First of all, because, as you can see, PCM uses a wide range of different materials for their pump. And for WAM, as long as you have a wire, then it's easy to manufacture. So first advantage is this one. Second one is, those parts, as you've seen in the video, are highly complex. And so they are produced in small batches. This is WAM is so suitable to make them. So how it goes? What do we do? First, we need a digital model of the piece. Then we'll try to find some deposition parameters. Then find a deposition strategy. Fail sometimes. And then, of course, manufacture the parts before the finishing. So better than a photo, here's a video of the manufacturing in WAM of one of the pieces. If you get some quick eyes, you can see that some people are around while it's manufactured. This is because it was still a development stage. So by using the flexibility of WAM, we were able to reduce tremendously the mass of the final piece, as well as improving the geometry. This gives us an overall 30% of upgrade of the performances of the pump. So the surface condition is not exactly the one that you can find in other additive manufacturing processes like powder. Yet, we ensure and we make sure at every stage of the manufacturing that by 3D scanning that there were enough material to do the machining afterwards. As I told you, the visual appearance can be a bit scary sometimes, but stay still. We made sure and we ensure that after the machining, the pieces didn't present any unacceptable defects. For confirmation, here's the pieces that you've just seen being assembled in one of the biggest pumps that PCM produces. So we talked about the geometric aspect that were good, but what about the mechanical properties? Actually, here is a comparison between the same material of the one we use in the PCM studies, building walls. And you can see that the comparisons say that the mechanical properties on the pieces that we produce in WAM is highly better than the one you can find on the specification sheet of the A240 stainless steel material. So I think I'm on time then. Thank you very much. He is our partner, our proud partner, Mr. Eric Auger, in front of a fully assembled pump. So thank you again, PCM, for your trust, and thank you again, Carnot, for making our life easier every day. Thank you.
Thank you so much, Bruno. Excellent presentation. Let's head on with Frank. Frank, stage is yours. Enjoy. You can use, do you have the clicker? The clicker?
Oh, sorry.
Ah, here. Bruno has stolen it. So enjoy your 4 minutes.
Thank you. So after the technical presentation, I will present you the national cohesion on metal additive manufacturing. So it's a French national cohesion. It was created 1 year ago, in October last year. The aim is to coordinate the hunts to competitiveness of French players to help companies. You can see the mapping and structure of the players in the ecosystem. We are principally present on 3 regions in France. So in Île-de-France with IFH, in Nouvelle-Aquitaine and Occitanie with Adim Alliance, and in Auvergne-Rhône-Alpes region with Initiative 3D. So there are many laboratories and technical centers you can see on the screen. It represents more than 100 million euros devoted to R&D IM players for over the last 5 years. And there are more than 300 people who work on the R&D project. And the other one characteristic is there are 70 equipment on manufacturing and more than 200 equipment on characterization. Now I will do a focus on Initiative 3D. The other structure network are like Initiative 3D, but I know better this one because I manage it. It comes from the competitiveness cluster SIM, and there are six technical centers like the CETIM, IPC, or CTIF, and others with platforms like the CEA. And there are 8 laboratories issued from 6 engineering schools, like you see in the screen. So the aim is to have a network of skill and resource, and only on metallic additive manufacturing. And there are some R&D projects with a small project from 200 euros to 20 million euros. And there are many groups who work on design, materials, process like powder, bed fusion, direct energy deposition or indirect process. And there are training programs on this group, for technicians, for engineers, and for company resourcing. What the aim is, it's for assisting the emergence of new competitive players on the international scene. It's promoting synergy between these initiatives. It's for giving visibility for industrial manufacturers and on the international market. And it's for optimizing investments and consolidating results. With coordinating, interacting, and sharing, and promoting gateway and access, and focus material resources and human skills. The next step will be to have some collaborative project between all the network, and we'll do a metal additive symposium in 2024 in March. Thank you.
Great, awesome. Thank you so much, Frank. I think it's already worth listening to you. I will hand over to Benoit. Benoit, stage is yours.
Thank you.
Sure.
I would like today to give you an overview of French R&D network and its organization. So at the first level, you have the French government hub Solutions Industrie du Futur, which coordinate initiative which leads to the transformation of our industry thanks to novel technology like robotics, artificial intelligence, and of course additive manufacturing. France Additive is a French association which gather all the stakeholders on additive manufacturing, from academics to industrial user or supplier of the technology for all domains of additive manufacturing. From polymer application to concrete construction application.
So reden die alle 6 Minuten.
For metallic, CETIM is coordinated cohesion, the French national cohesion, and which gather the most relevant laboratory in this field and company, and it was just presented by Frank just before. And to complete the map of this R&D network for research and innovation transferred, you have the Carnot Institute network, which gather French public laboratories certified by our French Ministry of Research, committed to developing research collaboration in order to develop innovation and improve the business of all size of company, from SMEs to larger group. So on additive manufacturing, the Carnot network has 8 Carnot institutes who are working in synergy. It means that if you have needs, you have one contact point is able to, and you will be able to access to all this network. This network represents around 300 experts on 27 platforms. And all these people are working on all the value chain of additive manufacturing, from the creativity innovation for the development of a new product to the standardization. And if we see at our offer covers all the whole value chain of additive manufacturing, from technical economical study to the support of integration of this novel technology in your workshop. So we do such activity, of course, at the French level, but at the international level. And of course, I invite you to visit our booth on all 12 booth C21. You will discover many applications, many success stories, and you have 2 success stories shown this afternoon on many applications: polymer, metal, concrete construction, small parts, big parts. And we will be happy to present all this innovation. Thank you.
Awesome, Benoit, thank you so much. Benoit, thank you to the others. Was already a great insight on your market, and I think this was a perfect round of Benoit. Thank you so much. Great to having you. Please visit these guys at Hall 12. See you there. Thank you so much. Okay, bye-bye.
Thank you.
So this was our first session, and we will head over to the next session. But before that, you will have 4 minutes of highlights of the exhibition. See you in 4 minutes.
Germany Trade and Invest is the economic development agency of the Federal Republic of Germany, and from the investor consulting department we support international companies setting up in Germany. We provide market information about the key industries in Germany and advice on tax and legal issues. We also have a team specialized in financing and government incentive programs for businesses. And we also analyze different locations in Germany to find the best place for the investor. And of course, all our services are free of charge. Germany is the biggest manufacturing country in the European Union and offers lots of opportunities for 3D printing companies. With its famous research institutes and universities that conduct research in 3D printing, it offers optimal conditions for startups that are developing new additive manufacturing technologies. So no wonder that already 1/4 of all additive manufacturing companies are located in Germany. We are a government company and all our services are free of charge and all inquiries from the investors are treated confidentially. If you plan to expand your business in Germany, please contact Germany Trade and Invest and also check out our webpage for more information.
This year at Formnext, Formlabs is presenting its latest 3D printing innovations with our SLS and SLA platforms. The Fuse 1 Plus has a more powerful 30-watt laser along with a faster scanning system, which allows it to print almost twice as fast as the Fuse 1. On top of that, it has an active powder management system, which allows it to print more demanding materials but with better mechanical properties. Finally, the nitrogen purge allows it to have a better refresh rate and allows effectively for wasteless printing. The Form 3 Plus, which was released earlier this year, is a new version of our SLA platform and an improvement over the previous Form 3. With software and hardware improvements, we were able to increase the speed up to 40% on certain materials, but also improve the surface finish as well as the ease of post-processing thanks to optimized light touch supports. Finally, we have the Form 3L, which brings the same technology seen on the Form 3 Plus, but with 5 times the build volume. With the Form 3L, large format SLA 3D printing now becomes more accessible and easier to use.
Ladies and gentlemen, good to have you back for the presentation of our partner country here at the AM4U stage. We had already some exciting presentation. We're heading over to the next topic, and this is super interesting because at additive manufacturing, we are always looking at the industrial users of additive. We have 3 exciting speakers about the topic, return of experience of real industrial AM users, and I'm happy to welcome here on stage Arnaud Cosson. I hope I put the name correctly. It's not that easy for me.
That's it.
Thank you so much. You are digital workflow engineer at Decathlon. Then we have Melanie Chevet.
Hi.
Good to have you. Additive manufacturing project manager at one of my favorite companies, Renault. Great to have you here. And we have Florent Lebrun, antenna department, technology innovation at Thales Alenia Space. Great to have you. Arnaud, do you want to kick off?
Yes.
Thank you so
sure.
much. Stage is yours. Please come over here.
Okay. It's not the right slide?
I hope so.
Okay.
Is it not yours?
It's not mine.
It's not yours.
Okay.
Okay. See,
maybe next one?
Something.
Okay.
So we are live. So probably, Arnaud, if you don't mind, you can already start.
Okay. I have very, very good pictures to show, so that's...
and I'm pretty sure that Anja is already on her way in order to check that for you.
Okay.
And you will get, of course, an extra minute.
Okay.
Thank you.
Yeah, so just I want to show you some use case we did with Decathlon. So I'm part of the team which is called AdLab Takeoff, which is a dedicated team to additive manufacturing. And here it's just focused on real case of production. So the first one, you can see here, It's a nose clip. So this is the first fully 3D printed product that was available in store, in a Decathlon store. This nose clip is a single body design product, no assembly, and made in France. We sold around 2,000 of it, and the product is no more available in store because the user satisfaction was under 3 on 5, and because the design was not well adapted to every nose morphology, so it was removed. But thanks to the low investments, because we have no mold, no tooling, thanks to additive manufacturing, we had the opportunity to fail without, and so to learn with a low impact. The second use case, it's really worse without the picture.
I check for you quickly.
The second example is a very good example of how additive manufacturing can help to improve products after their release. On our electrical bike, when you remove your battery, the connector, the plugs, they are visible. And so if it rains, the rain can come into the connector, and so it's not good for the lifetime of the battery. So we made a small cap, and this product is available for 10 euros on the Decathlon website. We manufacture it on demand, and we made 150 of it this year.
Arnaud, just to inform you quickly, we unfortunately do not have a presentation. So for whatever reason, wasn't sent. But this shouldn't hinder us from exploring Decathlon. And probably you describe it as best as you can, because it's already exciting. And I'm very sorry for that. But unfortunately, there is no presentation.
So I will focus on other topics that have that don't need the.
Just a quick side remark from my side, not to interrupting you, but as you all know, you have probably the products on your booth and can show them. Do you have a booth here?
No, we don't have a booth, but I have pictures there. So if you want, if you're interested, come to me.
But they're still working on that, and I promise you, once we have that, we do an extra round, and you can show the pictures.
And also,
quickly.
all these examples, except the first one, which was removed from store, they are real life, so they come. They come from. You can see them in stores. Oh.
Here we are. It's coming slowly.
Coming soon, maybe.
And here we are.
Okay, great. So this was the nose clip.
Awesome.
This is the battery cover. I will skip this one because of the time. This one is a OEM component, which is part of the crankset of our mountain bikes. And with it, the integration of electrical shifter is perfect. So we have produced a third batch of 1,000 for that part. This one is really interesting. The story of this combo lock is amazing. The production of the bike was stopped because two components were not compatible with each other. So we had 3 weeks to find a solution and resume the production. Combining the works of the bike engineers and the power of AdLab Takeoff team, we have been able to produce in-house 3,000 parts in less than 2 weeks and resume the production. This part is now a new standard that leads to a better components compatibility. So we have a wider diversity of components that we can use. And we have produced 2,500 more of this year. Another production story where AM saved us from a difficult time. 6,000 bikes to be produced, 15 weeks delay for the mold, and a project team came to us for a rescue. So within 2 weeks, we develop, we adapt manufacturing recipe, and we validate this part. And the next 2 weeks, this TPU part was manufactured by our partner AirPro and to be delivered to our factory in Portugal. And of course, the cost of the part was higher than the original one that should be produced with injection, but it was offset by the cost we avoid by the immobilization of the production. So all these examples, they show in many cases, additive manufacturing is the best option for components and end products. And these use cases are some of the many stories we are writing in Decathlon with additive manufacturing. And we are confident that there is much more to come in the future. Thank you.
Anu, I know I'm not allowed to ask a question, but I'll do it anyway. Just one, because it's super interesting. If we see this product, for example, has it the same, let's say, material specs in terms of durability and quality, so that they could rely on your solution?
Yeah,
or?
yeah, exactly. Every component or every product we made with additive manufacturing, they follow the same quality acceptance rule, the same lab test than other manufacturing technologies. So yeah, that's really the quality is really the same. And just a fun fact, because I focus here on the production series, but we also work a lot on spare parts. So some of our spare parts, they are available on the Decathlon website. So the user, the customer, they can order directly from the Decathlon website. And one of these parts, the number of cycle the part is okay, is better than the original one.
Awesome.
So
awesome.
In some case, additive manufacturing leads to better results than original manufacturing technologies.
And honestly, Arno, these are exactly the examples we need to push additive manufacturing forward. I was anyway a fan of Decathlon. I'm a heavy buyer, but even more after your presentation. Thank you so much, Arno.
Thank you.
Thank you for the presentation. Applause for Arno, please. Yeah, from Decathlon to Renault, Melanie, stage is yours. Let us see what you have brought us.
Hello. So, Mélanie Chevet, I work as additive manufacturing project manager at Renault Engineering Process in a techno center in Guyancourt. And I will present to you briefly our additive manufacturing journey with the first video. That is a hint to start the video. Thank you. So we have been using additive manufacturing from prototyping to tooling and now in our vehicle serial parts. First, about prototyping, it's a skill and know-how we have been developing for more than 20 years. So we have prototype centers that work with many different technologies to accelerate the validation and development phases of our vehicles. In all of our plants and manufacturing sites, we have also developed additive manufacturing printers and skills to be able to produce locally, reducing storage and cost of spare parts and tooling as a great factor for enhancement of the performance. And today, we also print parts in our vehicles. Here you have an example for our professional driver in Limo Mobilize. And if you buy your Alpine A110R or A110 Eternity, it will integrate printed parts in Flins refactory and assembled in our Dieppe factory. If you also use ZT car sharing, you will find different printed components, such as the key. So the message is that we are developing the technology internally with partners for needs and external needs also.
Thank you so much.
I will also present in a second video one of the tools that has allowed us to integrate the parts in our vehicle. It's our Flins refactory. It's a global project in our historical plant of Flins to transform our industry focused on circular economy. For the circular economy of electric battery and vehicle, and it integrates an additive manufacturing center equipped with different technologies for our internal needs of prototype, toolings, and vehicle parts, and also for external needs who wants to benefit from our skill and industrial know-how. This, for us, is a key transformation for the French territory, for our historic plant, to focus on high-value parts, for high-value projects with key skills to develop in France for Industry 4.0, with skills such as modeling, new processes, validation for industry of automotive and other French industries. If you want any further information about the refactory or how we use 3D printing at Renault, don't hesitate to contact me.
Thank you, Melanie. Great, awesome. I unfortunately can't afford an Alpine, I guess, but it's great to see that it's already in a car, even in a serious situation.
Yes.
But how many of these Alpines are produced already?
Today, it's 1,000 vehicles equipped with those printed parts. And main reasons to choose additive manufacturing for this vehicle is the time to market. Compared to injection molding, we saved approximately 8 weeks in our planning, and we were able to solve very fast problems and integrate it in our limited series.
Again, great to see that you are really pushing forward the AM industry with real-life products and not only prototypes. Thank you so much for being our guest. So finally, Florent, it's your part, and I'm really excited to see what he brought us. Thank you.
Thank you. Good afternoon, everybody. The presentation, perhaps, it's coming soon, perhaps.
It's a hope.
Okay, thanks to offer us the opportunity to share with you what we do with additive manufacturing on Thales Alenia Space. I will speak only about telecommunication satellite application. My name is Florent Lebrun. I'm based in Toulouse, in France, and I'm in the antenna department of Thales Alenia Space. I will speak only about selective laser melting technical solution we use today for many flight applications. We have started using this technology in 2015. We produce about 500 parts each year for flight application with several partners, and we now have in orbit more than 1,800 parts. We produce all our parts with different partners, so we have our own production capacity based in Morocco with several metallic printers to produce titanium and aluminum parts. And we also work with external partners, French partners like Lizzie, Adobe 3D System also in Belgium, and 3D Metal Print for prototyping activities. All these partners offer complementary production capacity and technology. Just let me provide you, share with you different applications we have on our satellite. So on our telecommunication satellite, we use this technology to produce many inserts, titanium inserts for composite applications, many brackets, titanium brackets. Titanium is really very helpful for stability, thermoelastic stability. We produce big parts also with Lizzie, for example, on their X-line in aluminum for inertia wheel frame, for instance. Also some antenna supports, and we also produce with other partners some waveguides application for RF application. We can also mention titanium brackets for propulsion subsystem named ETHM. We also in Thales have a new platform currently in development to offer more mission flexibility to our customer. And on these platforms, it's interesting to note that we have increased the number of 3D printed parts. We can focus on RF application. On this platform, we will print more than 150 3D printed feeds, which is really good for us. A really step in terms of serial productions. We'll produce also many brackets for reflectors and some RF application in terms of waveguides also, which the design is driven by our colleague from Thales Avionics. And we also have printed, yes, a big horn with the big printer of 3D systems, the Factory 500, a very promising application for us. In terms of R&D activities, just a macroscopic vision of what we do today. So we focus on RF applications. We also have many applications in terms of thermal applications. We try to introduce heat pipes, thermal loops, also oscillating heat pipes. And in terms of mechanical application, we also try to improve the performance of our fittings, considering hollow design on organic shape, and introduce also functional lattice. What we can say also is that we try to take more benefit from additive manufacturing, consider more multifunction parts. It's very important, especially because SLM remains a costly technology. In our business, we also have many unit production parts, and so it's also important for us to improve our capacity to obtain parts right for the first time, and so in this way use distortion prediction software and warping compensation software. So Okay, it's time. Last word would be that this technology really makes the jump for our business. There is many new interesting technology on this Formnext, 3D printing of PCB, 3D printing of ceramics, and so for us, future in this way is very promising and for sure very exciting.
Great, thank you so much. Thank you so much. Big applause. Finally, as a summary, I can say it was very good to have you here because we discussed yesterday that especially for startups, for technology producer, it's very important to see the applications from the industry because that is what they got to have heading for. So thank you so much. Having you here was great. Good luck with the fair so far and keep on going. Okay, thank you so much. See you soon. Yeah, ladies and gentlemen, yeah, big applause for the audience. Thank you. So we just have seen some industry cases, and of course we need to see what kind of materials you need to use to create these industry cases. But before we step into that topic, you will get a 4-minute highlight break, and I'm happy to see you after that 4 minutes again here on stage. Enjoy the break.
Top quality in metal printing. This is what Renishaw shows here at Formnext 2022. Let's ask how they achieve this.
Well, metrology is really important for 3D printing. The unique shapes that we can now print using our additive manufacturing technologies need to make sure they're not just unique in what we can do, but also that they are precise. And our background here in metrology has been really important for us in helping us design our additive manufacturing equipment. But it's also really important in us delivering end-to-end solutions to the customer. Most parts have finished machining, so actually the metrology, traditional metrology equipment, making sure that link between additive manufacturing and subtractive manufacturing is absolutely key.
The RenAM 500Q is a really highly productive system. It has 4 500-watt lasers that cover the entire bed of the machine, which is the only 250mm system to do so. Having these 4 lasers firing simultaneously means that we really minimize build times. The system also has really close alignment between the optical system and the machine bed. This, when you combine that with the intelligent gas flow, means that we can achieve greater than 99.9% density of parts. This integrated powder handling system, intelligent gas flow, high productivity, with a relatively small footprint makes the RenAM 500Q a really compact, cost-effective system. So Renishaw works really closely with partners and customers. This ranges across a wide range of different applications, so from aerospace, medical, dental, oil and gas, and consumer electronics. We have a global applications and a service network, so we're always ready to help our customers.
In our AM solution centers, we have a wide range of experts. And also in the facility, you find the technology around additive manufacturing, all the post-process, part inspection, and also analytical possibilities. So therefore, we work with our customers on feasibility studies, how attractive additive manufacturing is for their factory. And so with this consultancy, we can choose the best solution for our customers for their needs.
Ladies and gentlemen, we are back with another exciting round of presentations from our partner country, France. And we are tackling now a topic that is super important in additive manufacturing because we need materials with which we can print our products. And I'm happy to announce the topic of the next session that is called, let me check, because it has a fantastic title here. So the title for the next session is Filament and Powder, Field of Innovation, Sustainability and Sovereignty. And I'm happy to welcome our speakers here. We have Guillaume and Van from Nanoe. Then we have Adeline Riot, Global Sales Manager, Metal Powders from Aubert Duval. And then last but not least, I hope I put the name correctly because it's a fantastic name. We have Dr. Bechir Chehab. Is that correct? Bechir? I tried, at least. Thank you. Good to have you. Technical project leader at Costanulum. Guillaume, Van, would you like to start? Your 4 minutes. Thank you.
Yeah, thank you very much. So I'm Guillaume de Canin from Nanoe, and I'm talking with Van, who's actually working at Thales, but that's fine. So I'm going to talk today about a new product we're launching, which is called ZMX Epsilon, which was co-developed by Nanoe and Thales. Very quickly about the company, Nanoe, we're a material supplier. We provide industrial materials for additive manufacturing, but also for traditional processes, mainly ceramic materials. And in the field of additive manufacturing, we provide ceramic and metal filaments and processes to print ceramic and metal by FDM. So that's it for the presentation. A few years ago, we were contacted by Van's team at Thales to develop a new material specifically for the electric application, and I'll leave her to talk a bit about this.
All right. Yeah, so I think that you have seen the previous presentation about radio frequency application, and now we want to make it more evidence by explaining why 3D printing can be used also for RF application. So you can see here an amazing example of an RF component. So on the left, you have a lens which is really bulky and quite heavy. And on the right, you have really the same component with the same performance, but by using artificial materials, we can make it really compact. But the problem is that by using this, we have a really complex geometry. You can see here, we have thousands of pillars from hundreds micrometers up to several millimeters, as it's really challenging in order to fabricate it with the traditional fabrication like machining or milling. So the arrival of 3D printing made it possible, as you can see here. So we can fabricate it by 3D printing, the FDM technique. And so with a really innovative design and also 3D printing manufacturing, we can have functional RF part with better performance, thinner, lighter, and more efficient. The problem is that commercial 3D filaments have been developed for low-cost prototyping only. So we cannot find the dielectric properties required for functional and efficient RF components. So we need to develop and master the materials for our application. So what are the properties that we need for the new materials? So at first, it must be printable because we want to use 3D printing. And after that, we need the high permittivity in order to have really the high performance of the RF components. And we want to reduce also the thickness of the components. So in the picture, you can see an example. If we want to have a thickness smaller than 1 centimeter, so we need a permittivity greater than 7.5 for operating in 30 gigahertz. And we also need the low loss in order to have a high efficiencies and also avoid the heating inside the dielectric components. And for industrial application, the materials must be also robust in high temperatures. So by working with Nanoe, we have developed the ZMX Epsilon, which is the new materials which answer all the requirements.
So this is the new line of filament we are disclosing on the show. You can come to our booth to see more. A line with 3 different filaments which are the fruit of this collaboration with Thales, with different permittivity levels, ranging from 2, which is relatively low, to 7.5, which is quite high. And this will really unlock new design applications. I hope we have a bit of time to show a few examples of design. The first one is from Thales, so I'll leave Van to talk about it.
Yeah, so you can see here a steerable antenna. So yeah, you can see that with the two rotating meta surface, we can change the direction of the antenna in order to establish a transmission link with a moving platform or a satellite. And you can have also the second example is a really big one with 46 centimeter meta surface. And all of this we can use for point-to-point communication or satellite communication in the moving platforms.
So we're running out of time. I'm just going to mention that these parts and other examples of parts that I'm just sliding through are visible on our booth, which is upstairs. So you have deflectors, antennas, resonators, and so on. And all of these can be shown on our booth, which is all 11.1. We'll be talking more about this with Thales this afternoon, so you're more than welcome to come and visit us.
That's a great invitation. Thank you so much, Guillaume. Thank you so much, Van, for the presentation. I know 4 minutes are always hard to keep. I know how difficult it is. But Adeline will try. Adeline, stage is yours.
Thank you. So first, there is a video. I don't know. Sorry, yes. I'm glad to have a word about our metal powder portfolio, innovative powders, in particular that we have, and we have announced yesterday at Formnext the new brand of our powder range for additive manufacturing, in particular for space. I don't know if the video will start by itself. There is a video, sorry, short one. So the brand is Stellar. So the naming all our innovative superalloys, in particular, or specialty steels for additive manufacturing to 3D print your future. The range of material we produce are targeted in particular at the turbine industry for space, aircraft, and land turbines. And the new alloys we propose to the market are helpful to develop new systems, in particular, that will be more efficient regarding thermal and propulsive efficiency, with a lighter weight and possibly to using new energies. And we strongly believe that to be lighter and hotter, the best solution is to combine the design freedom offered by additive manufacturing to design lightweight components and the high temperature superalloys we propose. For the design, here are some examples of materials, of parts that are used in space on the right, turbine or aero engines. With conventional material, and what's new is that more and more people are targeting cast alloys like that you see on the right side, with high aluminum or titanium content, and above all high temperature resistance. And for the new generation of turbines, you need more and more temperature capability. But cast alloy are usually not processed well in additive manufacturing. So we have worked since a few years with partners in the development of alloys designed for additive manufacturing process to avoid the issues you have with conventional materials. Here is the list of alloys we have been working with and developing for the additive market. So with different temperature capability. I will not have time to detail each of them, but some have been developed in partnership, as you can see, with Mitsubishi Power in Japan, with Safran, and with Alloyd in UK, who has designed a very innovative and interesting material for temperatures up to 900 and soon 1,000 degrees. These powders are produced using the VIM gas atomization process in our factory in Spain. Sorry. I will go fast, showing just some example of parts made with ABD 900, the best alloy regarding temperature capability, which I believe is the best on the market today. And focusing in particular on this combustion chamber for a liquid-fueled rocket engine designed by Airborne, and which was successfully tested in a combustion chamber in a rocket engine, as you can see in this last page of my presentation in March 2021. And we believe that by the combination of the design possibilities, which are impressive regarding, in particular, cooling channels, regarding thin walls, that you can have with additive process, in particular selective laser melting, with high strength material, being able to withstand very high temperature, corrosive environment, hot gases, and so on. You can really reach a new era in systems that will help to being able to work towards the decarbonation thanks to the innovation offered by these technologies.
Thank you so much. Great, thank you so much, Aline. Pleasure, applause please for Aline.
Come and visit us on our booth.
Yeah, it would be great to see you there.
In the hall above.
Thank you so much. So I would hand over to Bashir. I try my very best. Enjoy your presentation.
So good afternoon, everybody. So I will give you today a short talk about Constellium Ahead CP1, which is an aluminum alloy powder specifically designed for LPBF process. So first of all, why new aluminum alloys for LPBF process? In fact, conventional aluminum alloys do not perform well for this technology. If we look to aluminum silicon alloys, these alloys print well. However, they suffer from moderate strength, limited ductility, distortion during quenching if used, and also moderate performance in chemical and electrochemical polishing. If now we look to high performance 7000 or 6000 and 2000 alloys, these alloys are very difficult to print. In fact, they are suffering from hot cracking during printing. Also, they are suffering from distortion during quenching, and they suffer from evaporation of elements like magnesium or zinc. The evaporation of this element will generate a lot of smoke and will impact the final composition after printing. So to solve all these issues, at Constellium we have designed specifically our solution called Ahead CP1, which is an aluminum zirconium iron alloy. So this alloy is, in terms of properties, is bringing high strength than existing aluminum silicon alloy, higher ductility, including in cryogenic condition, low anisotropy of mechanical properties, high thermal and electrical conductivity, which is really suitable for heat exchanger, for example, very high thermal stability, and finally, excellent corrosion resistance performance. Now, in terms of processing, Ahead CP1 is offering very high additive manufacturing productivity. Also, it offers very low residual stresses during printing, which is suitable to print complex shape with big geometry. Also, this solution does not need any solutionizing and quenching treatment like conventional alloys. And finally, CP1 offers really excellent surface finishing performance. In this slide, I'm sharing with you some CP1 demonstrators targeting different kind of application. Like, for example, lightweight mechanical components or in-demand spare part, semiconductor fabrication equipment, heat exchangers, RF components for satellite application. So, in summary, head CP1 can replace aluminum silicon 10 or aluminum silicon 7 mg and 6061 for different kind of application with better geometry, better surface quality, better mechanical performance, and better corrosion resistance. So solution made out CP1 are cost competitive through faster printing and simplified post-processing process. So if you want to see all these demonstrators and to know more about our solutions, please come and visit us in booth in Hall 12B22. Thank you for your attention.
Thank you so much. Thank you to the four of you. We just have seen again how important materials are. Excellent insights, and please visit them at their booth. Thank you so much for having you. Good luck with this Formnext. So, ladies and gentlemen, we had research, we had industry, we had now materials. Of course, there are a few more topics to tackle, and the next one would be software. But before we do that, let's have another look into our highlights. See you in a minute. Wenn ihr das mit den Präsen
Hi
hinbekommt.
guys, this is Marion from Formnext TV. We are here at the booth of Nexa3D. They say they make polymer 3D printing ultra fast. So let's check it out.
Nexa3D is all about ultra-fast, high-throughput 3D printing for prototype and production applications. So the Zip, because it has those industrial capabilities, is actually a very versatile printer. It's a great entry point into 3D printing in terms of a desktop 3D printer for prototyping and design, but also you can build a zip farm, and that's actually what we're displaying today, where you have several zips, and you can use that for high-mix, low-volume manufacturing applications as well. The NXE400 Pro is our industrial or commercial grade 3D printer. Both it and the Zip are powered by LSPC technology. That stands for lubricant sublayer photo curing technology. This technology uses a UV LED light source that then goes to an imaging mask. We use an LCD screen. It's monochromatic and it's 4K resolution. Think of it, everywhere where it's black is going to block the UV light, everywhere it's white is going to let that light shine through to evenly and uniformly cure the entire layer at a time down to the pixel level. So that's going to mean high quality, high detail, and excellent resolution down to the pixel level for each print. What really sets this technology apart, though, the unsung hero, is our membrane, the Everlast 2 membrane. That membrane is self-lubricating, and that's a key component of our technology. And that allows you to overcome some of the typical physics associated with the 3D printing process, reducing and eliminating peel forces so that you can leverage the full speed of the technology. We're able to print up to 6 times faster than most of our competitors. This printer is all about high throughput, so it's really geared towards high volume prototyping, maybe for like a service bureau or contract manufacturing environment, or typically production applications. So all of our 3D printing technologies, from the desktop Zip all the way up to the NXE and QLS for industrial applications, are all about ultra-fast, high-throughput 3D printing. That's important because that's going to allow you, whether you're doing high-volume prototyping or even moving into production, achieve a low total cost of ownership and a lower cost per part, which enables you to move into production applications that you may not have been able to do otherwise. The second is large build volumes, so you can fit more parts or larger parts than a lot of other technologies, particularly for the resin-based printers. And lastly is going to be materials. So we have over 30 validated materials, and then it's also open source systems. So this enables you to use your own materials as well. This, along with the high throughput, mean that this is an investment that you can make, and it's going to continue to pay dividends for years to come.
Hello and welcome back again, ladies and gentlemen, to the very interesting next session here of our partner country, France, on the AM4U stage. And we are tackling now a topic that is really important because the companies that are presenting now are the drivers for everything that is running around AM, because we're talking about the topic of software, a key component to serve the promise of mass personalization, distributed manufacturing, and IP protection. And I'm super happy to welcome three speakers here on the stage. I start with Philippe Laslerie, business development from VSS Orca. I hope you know how difficult it is. It's good to have you here. Then I have Christian Daquet, VP Sales, Spare Part 3D. And last but not least, Clément Glacé, Life Science Solution Consultant at Dassault System. Philippe, you're going to start. Your 4 minutes. Please enjoy.
Thank you. Hello, everyone. I'm delighted to be there, and I will talk on behalf of VSS Orca, of course, Orange Group company, and 3 other partners that I will mention in the presentation. So we are 4 French small companies, VSS Orca, Marclix, who is also MES provider, as well as Service Bureau, Epsilon, and Cosmix, which is printer vendor. And we have decided to gather our strength to provide with a unique value proposition, because we believe that technology is great, but at the end, what we wanted is to deliver a solution to a need. And what is the need that we wanted to tackle? In fact, the need is to, let's say, as an OEM, I have a catalog of parts, spare parts or whatever, and I want to be sure that this can be easily manufactured all over the world on a network of manufacturing facilities in a secure way, so that I can license my IP. So this has to be an end-to-end use case, of course, with the specific use case of distributed manufacturing, which we believe is really growing and will become very strong in the near future. So if we look at the different steps, the first step is, of course, to publish a part and receive very quickly a quotation. So then we use the automatic quotation tool provided by Marclix, our partner. And then the Service Bureau will make the quotation. Once the purchasing flows are accepted, then the transaction is agreed using e-commerce capabilities. And then the idea is later on to provide with the good scheduling to optimize the manufacturing capabilities of the Service Bureau. In this case, we have our partner Epsilon. Of course, as an OEM, I want to make sure that my most valuable asset, my IP, is well protected, and I can have the revenue I'm expecting to have. We can make a parallel with what has been done in the field of entertainment, music, VOD, where, of course, without this security all over the digital journey, there is no business. Who would invest in all this if there is no revenue behind this? And that, of course, we also need to have reliable, cost-effective, online printers, such as Cosmix, our partner. And at last, of course, we need to rely on a network of partners in terms of production. So Epsilon has great experience and can bring you all over from design, advice on design, up to the guarantee the quality of production. So to present it in a different way, this is the workflow coming from the CAD, where we will encrypt the content and using all these different functionalities I have talked about, quotation, planning, up to the production. And of course, we did the print integration of all this, and we believe that this print integration, this use case, this customer-centric use case makes the value of this solution. Thank you very much for your attention.
What a timing, Philippe. Awesome. Thank you very much. Excellent presentation. Yeah, then we could hand over. Christian, it's a pleasure to hear your presentation.
Thank you. Hello, I'm Christian from SparePart3D. We developed a software called DigiPart, which helps companies accelerate and industrialize parts identification and inventory creation. And I'm going to illustrate this with a use case that we just finished with the national oil company of Oman. Yeah, thank you. The problem statement of Oman was they had a catalog of 150,000 spare parts that they wanted to move to 3D printing. They have a very aggressive roadmap for the country. And they lacked the knowledge, the know-how, and the information completeness on each of the spare parts to actually do the analysis. So we came in and we helped them do this and actually accelerate the different analytical steps. How did we do that? By using DigiPart, which is a software that operates in different steps. One of them is a semantic recognition algorithm that allows to recognize parts, group them, cluster them, look at what are the functional specification, the different environment in which they operate, from which we can derive functional specification. For the parts that cannot be recognized, we cluster them, we create new part categories, talk with the engineers on workshops to define the types of environment that those parts operate into, and then we cascade automatically all the functional specs to those parts so that we can therefore later on derive the right material and processes from an AM standpoint that makes sense to print those parts. This basic operational of our software allows to quickly treat the 150,000 spare parts that we sifted through, derive the 62,000 spare parts that were really important to focus on, that had a technical solution, and then apply a business case formula that were relevant to the client to define the one that were most pertinent. So we went from 150,000 spare parts originally to 62,000 that were technically printable, and then we focused on the one that had the most business potential, that varied between 3.5 and 11% depending on the use cases and business case that we were looking at. Cherry on the cake, we also produced a report for the country that looked at the main technologies from an AM standpoint that made sense for them to invest into, what we call the in-country report. Those countries are very keen on developing their local capabilities, so we were able to give them the directions in terms of technology that made sense. Basically, those are some of the obviously very nice comments from PDO, but in a nutshell, we made them gain 2 years in their roadmap to accelerate and implement additive manufacturing to spare parts. We are at booth 127 in Hall 12. Gladly answer all the questions that you might have. Thank you very much.
So I hope it's running, Clément. Thank you very much, Christian. Pleasure to hear your presentation. And let's see, once it's started, you can start, Clément. Stage is yours.
Okay, thank you. So quick introduction. So just waiting PowerPoint to load. But do you know, for example, just giving you a number.
Takes a while.
Again. Yes. So what are these numbers? What do you think? Like 5, 25%, 15%? What are these numbers? So basically today there are 5 software changes in a basic additive manufacturing process from design to execution of the process. And 25% of the additive manufacturing process is spent in testing and validating the parts you are producing. And did you know that 15% of medical devices are 3D printed today? It's a big number. So the question is, as you know that today we are going more and more to personalized medicine, personalized implants, how do you reduce this time to market to go to mass production through for example, one unified environment for additive manufacturing. So today with Dassault System, we support most of the processes that you see on the screen. So from powder bed to binder jetting, going to material extrusion and even photopolymerizations. And we support most of the industries that you can meet in our today's world. The story I will tell you about today is about life science, so medical implants, and so made by powder bed application. So basically, this is the full story we are telling to our customers today about additive manufacturing. So what do we support? So basically, I could tell you all, but you won't believe me, so I will just show you. It's from collaboration with the basic of the 3D experience platform. We allow a smooth path from generative design to part preparations, going to even post-processing and negative compensation, because you all know that an additive manufacturing part isn't really, so you have tolerances to respect, and if you don't play on the software, on the design of your part will completely be distorted. So we have all of these solutions, and even going to the execution part with planning and scheduling softwares and execution systems. So the story you will see now is about what you see at the screen, so from generative design, even going to the marketplace, so no more teasing. This is just a video. So our journey starts so in a clinic where you are gathering all the medical data from your patient. You are making CT scans and reconstruction of the CT scans. And based on this, with the 3D experience platform, we are able to make the generative design of the part, optimize its topology, considering different scenarios, different use cases, and in a virtual twin of a manufacturing plant, we are able to, in its environment, so create and the different strategies, so support strategy, laser strategies, and even so create like different strategy for support for different parts, which makes the job of additive manufacturing engineer really easier because there is no one strategy, you all know about it. So. And then you can do all your building plate. You can optimize your nesting parts directly on your building plate, and based on this, you can then generate outputs. So outputs for planning and scheduling, outputs as well for manufacturing execution systems, and then let's go to produce. So basically, what we say with the platform, so you have one environment for all, from generative design to execution of your productions, and you can gain a lot of time to market. So yeah, if you are interested, I'm really happy to answer your questions as well on other topics which are not covered in this video. Thank you.
Awesome. Thank you so much, Clément. Yeah, thank you so much to you speakers. Great topics in the field of software. And what does software need? Of course, software needs data. And this is a topic we want to tackle in our next session. And we're going to do this in just 3 minutes after another highlight block. See you there.
practices, and we have something quite suspenseful over there covered in this black veil. Peter, tell us about Stratasys vision. What hides under that veil?
Well, as you know, Stratasys stands for innovation at the end of the day, and innovation also means we are supporting any new technology, especially when it comes to faster go-to-market, faster innovation amongst all the different technologies that we are offering. And therefore we are happy to join forces with Frontier as our development partner, and we are going to unveil a new, let's say, brand new system, which could be explained by Stefan much better than by me.
Stefan, let's pan to you. You're from Frontier, which is I think the heads behind the innovation. Tell us about the technology. This is the future of e-mobility, you teased it. Tell us more.
All right, so what we're seeing here is EULA, and EULA is the answer to a new green and urban mobility, because what we need to do is we need to get rid of the cars in the cities, but how we're going to do this, we need to make a new offering to car drivers, commuters, also in tourist areas. So this is why we came up with EULA. It is a four-wheel bike. It's an e-bike, so you can ride it on a bike lane. It has a hot motor, two hot motors in it. We have a partner for this, so it's very comfortable. It's also a digital device, so it'll have functions like follow me, like going to have a head-up display. You're going to bring your own device features in there. Wow. So I think that is creating a great deal of comfort and a digital experience for the consumers. I think that's what needed going forward to create sustainable mobility.
Lots of new technologies that hide behind this particular thing, and I hear urbanization is the key word. And since we're here at Formnext and additive manufacturing is the key word here, tell us about the parts that have been manufactured with the help of 3D printing.
What we did, it's an aluminum frame that we welded inside, which you can't see because we cladded a lot of polymer parts on top of it, and all of them were done on Stratasys machines, so we were very grateful for this collaboration. So let me do a sneak preview just for you, because we're going to have the big unveiling.
Let's get that, yeah, before the big unveiling.
What you see here is just the front part. The rest we're going to see later.
So basically this is the Batmobile, but sustainable. And from the looks of it, it's going to be a huge unveiling. And I wish you all the best for this technology, and I hope as soon as it hits the road, we are all going to get a good taste of what the future of e-mobility looks like. Thank you both, Stefan, Peter, for talking to us. Have a great time in Formnext, and I'm sure we'll be here for the unveiling. Can't wait.
Thank you so much.
Thank you very much.
Thank you.
Welcome back here on stage, and we are now tackling the really exciting topic of data and how AI serves AM. And with me on stage, two fantastic speakers. To my left, I hope I put it right, Rushik Matroya, CEO of Cognitive Design Systems, and to the right, Pierre Marigo, co-founder and CTO of Andel. Awesome, thank you so much. Stage is yours.
Hello, everybody. There you go. Today I'm going to present to you cognitive design systems and what do we do as AI and how do we help AM for that purpose. The vision of the company is very simple. We want to bring the concept into reality. But in order to do that, we need to assess not only the manufacturability of the part, but also the cost and the structural integrity of the part. And for that purpose, we have created three different solutions: cognitive additive, cognitive molding, and cognitive machining, and that allows us to do what we need to do. Our technologies are based on 3D model analytics, implicit modeling, and 3D machine learning. 3D model analytics, it's for voxel-based technology, and we do cost analysis, manufacturability analysis on that. We also use implicit modeling because it's a math-based 3D modeling process, and it helps us, these two technologies, to develop our third technology, which is the 3D machine learning, where we modify the geometry for optimization, for the manufacturability, for the cost. It allows us to do accelerated 3D model analytics, but it also automates the whole morphing. When I say morphing, is we do the localized shape modification in order to achieve what to make the part most viable. Why do we use machine learning? It's simple. We use machine learning for very obvious purpose is the speed. We want to have a solution which is fast enough so that each iteration in a CAD system, a user or a designer should be able to do exactly assess the cost and feasibility while designing. And for that purpose, we have our first solution, Cognitive Additive, which is also available on GrabCAD Print and Cinera. So you would be able to work without any kind of disturbance in your digital continuity. AM Study, so the first solution, it provides you with lots of insights on how to produce your parts, what are the risks related with it, and give you a very good assessment of the cost and how the cost will evolve in the future. We can also do the same kind of screening on a large data set of large assemblies. For example, here we did 61,000 calculations in under 7 hours without any cloud connectivity. So thank you very much for listening to me. If you have any questions, please visit my booth. It's 12.0 E52. Thank you.
Crazy timing. This was like artificial that you have met the timing also. Thank you so much. Yeah, stage is yours. Go ahead.
Thanks. Hi, everyone. Good. Actually, we just got a perfect example of what we can do with AI to design a part. But once we design it, we need to produce it. So let's move into the shop floor, into the physical world, and let's think about how can we bring these AI tools into the physical world. I'm pretty sure you already heard about many applications based on AI technologies, based on machines data, but there is a field, there is a kind of data which is really unexplored today. I mean, video streams. In the video stream, we have many information, and using computer vision algorithms, or generally speaking, deep learning algorithms, we can record the entire manufacturing flows and all the operations that are made on a part during its production. So it's quite interesting to understand what happened in the factory. Yeah, I think it's definitely a key to understand what's in your factory and how to produce high-quality parts at scale with additive manufacturing. This kind of tools is great, and it gives us how to say a strong, deep knowledge of the rule process and a way to analyze the flow inside the factory. And using these results, we can make a copy, a digital twin of your factory, and then use it, analyze it in order to predict what will occur in the factory, what will be, for example, the capability of the factory in the future. Just to be sure that everyone understands what I'm talking about when I'm saying digital twin, I'm going to take this well-known example, which is the autonomous vehicle. If you think about the roads, you will see cars, you will see pedestrians, you will see bicycles, I don't know, animals, whatever you want. And if you think about the shop floor, it's quite the same, in fact. But instead of having cars, you will have machines, you will have robots, you will have anything you want, sorry. And we can bring the same technologies that the ones that are used in the autonomous vehicle and put them into the shop floor. Actually, I worked for several years in the autonomous vehicle, so these kinds of algorithms are well known at Handle. And OK, to go back on Handle, I'm happy to present you today our new tool, which is called Handle Line. Handle Line is an industrial IoT device which is able to collect data autonomously in order to analyze, to optimize and to predict what happened in your factory. I think it's really important to know what happened in your factory. And one point which is really important to note is that everything is computed inside the device, so nothing is hosted to the cloud. So we really are making AI inside the factory, at the heart of the factory. So it's a way to empower the shop floor using AI tools, and let's say to take a step towards the shop floor revolution, which is definitely led by data-driven technologies. Well, it was quite good to speak today. I'm Pierre, co-founder of Handle and CTO right now. We are a young startup based in France, in the south of France. We started 2 years ago with 3 co-founders. Today we are a team of 10 people. We work with several markets such as defense, aerospace, medical. Anyway, so we are at hall 12, C39, so feel free to visit us if you're interested by the product or by the team, and hope to see you there. Thank you.
Big applause. I mean, as you both were perfect timekeepers, allow me to ask 1 or 2 questions, if you don't mind. Hushik, first question would go to you. I'll probably come over them where I have you on the camera here. I mean, I know a lot of software companies that are digging now into AI and machine learning, etc. The main problem that I experienced with them was the lack of data they're getting. What is your experience on that topic when you work together with companies?
Of course, the data is very important, and the quality of data is the key to have a good AI. And for that, we need to. It's a lot of work, and kind of like even to make a thing automated, you need a lot of manual sorting and selecting of the right data. Of course, we are essentially off-cloud solution for a very simple reason is that all our customers in Japan, in France, in USA are in defense market, and they don't allow to go any data up on cloud. So we have gathered more than 22 million data points, which was created. There was a part of it which was artificially created by morphing different models to create a good algorithm, have a good balance in the whole data, and we can cover the whole spectrum of different data sets. But yeah, I believe that the quality of data is the key, and finding the right data from the customer is the key without having to upload it on cloud. For us, that was one of the key.
Yeah, that will lead to another question as well for you. Same topic here. If it comes to security, data protection, especially I can tell you from Germany because I'm doing shop floor management for several companies, and I know that they're really keen on not letting data out, especially if it comes to video and you're using video. What about legal restrictions in using video because you are filming the operators as well? How's that solved?
To be honest, it's a huge problem for us. Yeah. Well, actually, we have a command base which works on pretty any machine we want. And then once we installed our product on site, we need to train our model to fine-tune our model for the machine we are studying. So generally speaking, it's quite difficult to get videos in this kind of situation. But as I said before, all the video stream stay inside the box. So we can find arrangement in order to optimize our models and to find solutions. Yeah.
But I tell you, in Germany it will be quite difficult due to the regulation here. Ushik, I mean, you mentioned it's about quality data, it's about the amount of data, especially if it comes to learning out of the data, you need a certain amount of data. Now, you were mentioning focusing on defense, they want to keep their data inside their location. So again, don't get me wrong, it's hard to understand or hard to believe that you gather enough data because the best data you could have is from different locations, from different clients, gathered all together, and getting your algorithm performing every time better, isn't it?
Yeah. Yeah, of course. That's a question of improving the AI model or the machine learning model that you already have established. So what approach we have is that we have a certain ML model which is already in the software, and then we fine-tune it with the customer data as it uploads each time. So we are kind of creating another layer on top of the existing model to make it more suitable two for each specific customer.
Very nice. Thank you so much. I love the topic, to be honest. It was a pleasure to have you here. Good luck here on the fair. And thank you for being our guest. Thank you so much.
Thank you very much.
Yeah, ladies and gentlemen, AI and data, very interesting topic. And the final session we're getting to is about another very interesting topic, at least for me, and one of my favorites, because we're talking about startups in France. But before we do so, we would never let you miss one of our highlights. So here are 3 minutes highlights of Formnext 2022. See you then.
Step into the light, I'm alive, I can see your love shining. You put it on the inside, so no matter where the darkness, you been shining like lightning. I surrender, you fight my fight. Darkness ain't ever gonna take my life. I'm so give you my praise, that's right. I'm so give you my praise, that's right. I'm so give you my praise, that's right.
We're here at 3Dstep at Formnext. Welcome, Pekka. Tell us about the services that you're providing and the product that we see in front of us.
All right, we are 3Dstep, a metal and plastic 3D service provider from Finland. And what we do is contract manufacturing, serial manufacturing for industries.
And what is it that we see in front of us? Tell us about the products that we see in front of us here.
This is an example of serial production. This our customer is Mirka in Finland, and this is a component for robotic grinder. This has 120 components that are printed in one go, and here's the one specific component that this has. And this is an example of what we do as a daily business.
Hello, ladies and gentlemen. Welcome back to the last session of our partner country, France, here on the AM4U stage. And I loved the order of the sessions because we are getting back from research over companies that are using additive manufacturing and are now at the early start point, because we want to have a look on interesting startups from France, and I'm happy to have these speakers here on board. Our first speaker that we're going to see is Pierre-Jacques Lyon. We know already your company from the Pitch Next event. Good to have you here again. So from Marklix, then we have Louis instead of Claude from 3D Minerals. Thank you. Good to have you. Then we have Clément. Yeah. I can't pronounce your last name.
No problem.
You will introduce your last name as well. Thank you so much. You are CEO, co-founder of Nama. And then we have Ingrid. That's a familiar name, Ingrid. It's a pleasure to have you here. Ingrid Florentin, president of 4D Pioneers. Great to have you here. Pierre, you want to start?
Let's go.
Thank you.
So, hi everyone. So my name is Pierre-Jacques, and I'm the co-founder and CEO of Marklix. With Marklix, we are the first MES, French MES, and we are building a costing and planning software. So we help our customers to deploy a wide-branded solution on their website to take orders, 3D printing orders. So that are some example of customers we have. So the customers can upload 3D file, like say Kendo and on Sculpteo or 3D Hub or other platforms, but directly to the service bureaus they're used to work with. And they can configure the part. They get access to some tests, and they can directly pay for their order. After that, we are also building, for the end of this year, a complete production planning module that will be integrated with this cutting tool. So, thank you. It was a short presentation. I think we had like 3 minutes each. Thank you.
Go on with Luis.
Yes.
Takes a while. Takes a while.
Okay.
Will come, hopefully.
So, hello, my name is Lois. I work for 3D Mini Worlds, a company which is located in Limoges, in the center in France.
I take care, Luis. Ah, there it is.
Oh.
Is that the correct one, I hope? Yeah?
Yes.
Perfect.
So, 3D printing makes it possible to imagine and create new parts with complex, original, and unique forms. So, we manufacture ceramic 3D printers. We have a patented technology, which is called SDM. So, it's a slurry deposition modeling. It's a unique ceramic technology. The advantage of this technology are numerous. So we have a no printing limit size, control of the firmness of the paste. We can use traditional and technical ceramics. We have no air bubble during printings. We have a quick and easy preparation of the paste directly in the extruder. And we can use a specific or commercial slurry. So the technology is simple. We have 2 tanks, one for the slurry, another for an adjuvant. And these 2 tanks, which are alimented with 2 pumps, and this pump send the slurry and the adjuvant in the printing head. And inside this printing head, we have some elements which mix and push the extrudable paste. So we have 3 printers, a robotic ceramic 3D printers, a rotary printers, and Cartesian printers. With the Cartesian printers, it's a modular machine. We can use our technology or another technology with a cartridge. It's perfect for printing technical ceramics, thanks to its precision and accuracy. It's modular printers according the motion to the customer needs. This is a rotary printers. It's perfect for making revolution parts, and it's a modular dimension. We can print, for example, a jar for vinification or other round parts, like you can see on the video. And we have the robotic ceramic 3D printers. It's a robotic arm which is equipped with our printing head. And it's a good printer to printing complex parts or a small series of parts, like for example on this video, without human intervention. And for any question, you are welcome on our booth, all 12, C39, and later we hope to see you in your Pion plant in France. Thank you very much.
Before you hand over, because we have some time, you have been a perfect timekeeper as well. Let me ask some questions. Luis, probably 1 or 2 questions, if you allow.
For sure.
So first of all, I've seen the size, because one of you was standing next to the product. It's quite big, isn't it?
Yes, we can print big parts. It's our main advantage. We can print small parts, but our main advantage is to print big parts. Like, for example, jar. We can use technical ceramics, traditional ceramics, like alumina, stoneware, and some more.
I mean, we have seen some products, but what are the main product segments you're going for right now?
Right now, I think it's the Cartesian 3D printers, because it's a perfect printer to print traditional ceramics and technical ceramics.
So how big is the market? Don't get me wrong. I mean, ceramics, I have no clue, to be honest. It's not my branch, I would say. So what would you consider the market size, or how much are you tackling? Well, how big is the interest?
It's a big market. Actually, it's in a maturity phase, and we can touch area like aerospace, aeronautics, like jar for vinification, artistic design, architecture. We have many area of activities.
And right now you're mainly focused on the French market, or is it already super international?
No, more international.
Yeah, okay.
Yes.
Okay, good to know. Thank you so much.
Thank you very much.
Let's come over to Clément from NAMA. I'm really excited to see what behind this name is. Okay, go ahead, please.
Hi, everyone. I'm Clément Cazotte. I'm the CEO of NAMA, a French manufacturer of hybrid 3D printer, like EVA. Okay, let's imagine I work in the industry and I want to manufacture a part. There is a wide range of manufacturing processes at my disposal, but today I want to talk about two processes in particular. The first one is CNC machining. That's the advantage to make a precise part, but it generates a lot of waste during the manufacturing. And the second one is the FDM or FFF 3D printing, when you can make easily complex parts and quickly, but there was no rolled surfaces on this part. But what if we combine them on the same part? Indeed, at NAMA we are convinced that they are both manufacturing processes are different but complementary. We can talk about hybrid manufacturing because we combine these processes on the same part. At NAMA we propose EVA. EVA is an hybrid machine that combines three processes: FDM 3D printing, CNC machining, and engraving laser for the industry. With this machine, you can make prototype, tooling, and final parts for different sectors like aeronautic, automobile, and many others. With this machine, you can changing tool head depending on your demand and on the material like you manufacture, like metal, like polymer, and composite, and many others. And this year at Formnext, we are coming up with something new, AIM, for automatic hybrid manufacturing. The principle is two independent tool heads which works in the same time in the same part, to have a beautiful part with beautiful surfaces rapidly and easily. And we can put on these two different tool heads. For example, on the right, you can have a 3D printing head, and to the left, to the head to the left, we can put a CNC machining to, for example, to create mold for industry. You can put also two 3D printed tool head on the two independent tool head for make parts in the same time. So with this new system, you have a lot of gains, and you can make a part faster and more cheaper. You can have a part in 3D printing, a 3D printed part with a good quality for the surfaces and good accuracies. And you have a cost reduction on your part because you have no human intervention on the fabrication of this part. Thank you for listening to me. If you have any question, come visit us on the C39 hall 12.0. Thank you.
So before I move to the other hall, I ask my question here. Is that okay?
Okay.
Is it theoretically feasible to have two components or two materials in this machine?
Yeah, we have on the different tool head, you can have filaments, and for the next year, you can have pellets also.
Okay. And is the machine already in place, or are you selling it already? Or?
Yeah, the machine is on the French market from this year.
Yeah.
And for the next year, we are looking for a reseller for European country. So next, yeah.
And as a startup, what is your size, or in what phase of your startup you are right now?
Sorry?
What state is your startup right now when you have started?
The machine is on the market, and we want to make this new system for the next year. Yeah.
So is there any funding needed, or?
No, I don't think so. No.
Oh, so self-financed. I like that very much. So thank you very much for your presentation. A big applause. Thank you.
Thank you.
Ingrid, I need to ask the question up front. Is it a German base or is it French?
No, I'm French with Swedish origins.
Oh, very nice, very nice. So, presentation, stage is yours.
Okay, so good afternoon, everyone. My name is Ingrid Florentin. I'm chairman and co-founder of 4D Pioneers. We are extremely excited today to introduce for the first time our 4-shift machine, which is an hybrid and multifunctional machine. And thanks, Clément, for introducing hybrid, so I don't need to, to talk about hybrid technology more, but I'm going to show you how we are developing hybrid. The first thing I have to say is that we develop our machine with industrial customers in mind. So our goal was really to develop a machine to print ready-to-use functional parts with unrivaled performance in a highly productive manner, because that's really what industrials want. So what is the 4-shift? The 4-shift is an hybrid and ultra-functional printer that allows to manufacture complex, precise, functional, and scalable parts in nearly any industrial-grade materials for perfect fit rendering, and that's really what industrials need. As well, what we did is really to develop it to save time and to optimize resources of industrials for more value. So let's have a look at the printer. I have got a small movie highlighting the printer.
Feels nice, doesn't it? The cheer of things clicking, matching, suiting, balancing, enduring, getting it right. All it takes is the perfect support, the perfect techniques, the perfect tools, the perfect materials, into the perfect machine to create the perfect fit. There, feels nice. 4D Pioneers, the perfect fit. Oh, just one more thing.
So let's go into detail about the functionalities of the 4-shift. The first thing is that it's a full hybrid additive and subtractive machine, meaning that the operation of addition of the material and subtraction are done layer by layer in a simultaneous way. To allow that, we have got a patent on an automated tool change, which allows to change the different heads in 2 seconds. So it's very rapid, and it allows industrial to work in a very efficient way. As well, this machine is a 5-axis robotics, meaning that you have seen it at the end of the movie, meaning that the head have got 2 additional axes in order to reach the parts that traditional, I would say, machines can't reach, and as well to remove all the supports. We have got in our machine 4 positions, and we have got filaments and as well pellets. The big benefit is 2 things. First of all, it allows, in fact, to reach any industrial grade, but as well, we can do multi-materials printing. The third one is about the materials. We are able, in fact, to print more than 60 materials on this machine. So imagine someone who is working on the maintenance. You need to print one day metals, the next day polymers, composite, ceramics, whatever you want. So that's really a big benefit. And you know, of course, we are going up to high performance materials, and we are developing some materials by ourselves. We have got a cohesive bed sheet, which allows, in fact, to get a perfect fit between the material and the sheet, so that when you print the first layer, you have got a perfect cohesion. And as well, we are printing in high temperatures. The machine can go up to 500 degrees. And we have got a heated environmental printing, meaning that the environment of the machine is 150 degrees. And that's a big performance because, of course, when you go so high, the technology needs to follow. The big benefit of this heated environmental printing is the fact that you have no delamination, and as well you avoid the phenomenon of warping. So the machine has been developed, and we are going to ship it to Maintenance Technical Center in Saintes with SNCF. So we participated to a very big project called Additive for Rail, and this project is about printing 3D pieces in routine in a maintenance center to repair trains. So we are part of this project. We are the polymer lead on the project, and we are going to print many materials for many pieces. We are actually working on digital designs for 350 pieces. And if you look at the market, you were asking questions about how big is the market, to give you an idea. So at SNCF, they get 150,000 references. They can be printed in 10 to 1,000 pieces per year. And they do estimate that 10% of those pieces will be printed in 3D in the future. So we are located on booth Hall 12, E88. Of course, come and see us. We will be extremely happy to tell you more about our system, about our capabilities, and about our materials. So thank you very much.
Thank you so much, Ingrid. Allow me one question or one remark. We had this fantastic panel discussion yesterday with Stefanie Brickwede from Deutsche Bahn.
Yes.
And I know whether you know her or not. And she was talking about the approach of the Deutsche Bahn is that in the future, if they hire suppliers, they must guarantee that they will deliver the spare parts lifetime. This will be hopefully the breakthrough for additive manufacturing. So it's not really a question, it's rather a recommendation. So you should connect, because I think this would be an interesting customer or at least cooperation partner for you.
Yes, thank you very much. So indeed, I would say we have got 2 collaborative projects with Fevele, which is one of the worldwide most important spare parts supplier for the railway, and SNCF. And SNCF is part of a European group, so they plan to connect ourselves with Trenitalia, the Dutch Bahn, of course.
Very good.
And we are looking for that. On your point regarding certification, that's one of the pain points, because obviously all the pieces will need to be certified. And that's why we immediately started collaboration with those two big actors of the railway, because we need to learn, I would say, about certification, how they do it, and we needed to be connected to experts in order to do that. But I hope with the Dutchman very soon as well. Thank
Awesome.
you.
Thank you so much for the
Thank you so
presentation.
much.
Exciting product. Thank you so much. Yeah, ladies and gentlemen, we have one more startup to come. Very spontaneously. Please give a big hand for François, because he is presenting as CEO the company Discover3D. Is that correct? Yeah, go ahead.
Thanks for the introduction. Sorry for being late, so I will do without presentation. That is not a problem. We are a developer of pellet system, pellet extruder system, and we are able to print today more than 1 million material different, including rubbers, real rubbers like EPDM, NBR, FKM, FFKM. We print silicones too. We print thermoplastics, beginning with the TPE, really soft material, and we go through all the range of material with commodity thermoplastics, with technical thermoplastics, to go to ultra polymers like PEE, like Ultem, like PIC, PEKK, and so on. And we print metal from MEM System 2 and ceramics. Soonly, we began to print food with candy, sugar, chocolate, and with a certain level of success, and we try to stabilize it. And our main, I would say, our main innovation on this topic is the non-planar printing, because we lead the mechanical properties by the calculation, and the calculation drive to the trajectory of the printing of a printer. Like this, we are able to multiply by 10 to 20 the mechanical performance of a 3D printed part, whatever you need to make with it. We just change the way of printing without changing the parts, without changing the material, without changing the printer. We only drive by the tool path. That's it.
Thank you so much. Awesome.
And thanks a lot again. And sorry for the delay.
No problem at all. Wait. One question must be allowed.
Okay.
I mean, like all of you, the thing that was still in my mind was the word candy. So
yes.
You're printing candy, because
Yes.
I was, a few years ago, was introducing a very exciting startup there, printing meat.
Yeah.
That was, or printing vegetables, or making candy out of vegetables with a 3D printer. So there are so many exciting things. What kind of candy is that, and where do we get it?
We start with gummy bears from the market.
Okay.
And we have specific customer requirements, so we try to print it. We did not succeed yet, but we have some really nice parts, and can be shown here, but we have nice parts and tasty parts, I would say, because you can change the taste during the printing.
I think this is worth an invitation, right? I mean, at their booth, you're all surely looking forward. Thank you so much. The Startups of France was impressive, really, I can tell. I see a lot of startups. It was fantastic to see your products. Good luck for the fair. Even more luck for your projects and your company. Thank you so much for being our guest.
Thanks a lot.
So, ladies and gentlemen, what exciting session this afternoon with our partner country, France. So many interesting insights, interesting presentation, very inspiring. We will, of course, go on here with the program. The next thing you will see is our news, followed by our highlights. And then I will be guest in our afterwork session together with my colleague Frank. And we will have several more guests that are super interesting. So stay tuned and get back in roughly 10 minutes. And then we will see you here at the afterwork session on our AM4U stage. It was a pleasure having you. See you in a few minutes.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. Formnext spearheads into day 2, and here is a small recap and outlook. Yesterday at the AM4U stage, the top female leaders of 3D printing came together in an interactive panel and discussed intensively about industry applications. Several ladies from the community offered their insights on career opportunities for women in additive manufacturing. Another highlight was an exciting unveiling ceremony. Uila's world premiere attracted a huge crowd of spectators from all over the fair premises. Uila is a prototype combining an e-bike and electric vehicle, featuring a chainless electrical drivetrain designed by Berlin-based innovation studio and Frontier. Presented in cooperation with 3D printing partner Stratasys. Bottles of sparkling wine popped at the Permundus Challenge 10-year Jubilee celebration, where winners from the past decade reconvened to celebrate the uphill evolution of additive manufacturing. Thomas Luc, Head of Innovation and Sales at Curb, explains the thought behind it.
The Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Oh, definitely.
Yeah.
Definitely they have. And that's what this retrospective view of the different winners of the last 10 years really show, that there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well at the applications as how to combine material and process, as how to make a really good design, and because at the end it's a design contest.
At after-work talks presented by Frank Jablonski, Petra Harburger, president of Messago, emphasized upon the importance of spreading the network of additive manufacturing. The talk round discussed the development of the AM market internationally, in particularly about the United States. Doug Woods, president of Association for Manufacturing Technology, said,
"We have a really big market already, so it's easier for many of our new companies to get started and have sufficient market just in the United States. But the reason they come to things like Formnext, it's in as much they want to be able to prove that they can sell their products in Germany and Europe, because that's pretty difficult sometimes for smaller, medium-sized American companies. It's as much this event. This event is the premier event. If you want to show off that you're great in anything from materials all the way through to service bureaus and everything in the middle for additive manufacturing technology, you want to show it off here."
How was the mood at the fairground? Spread across 4 halls, exhibitors from all over the globe have set up colorful stalls displaying the creme de la creme of 3D printing technology, which drew in thousands of 3D printing enthusiasts. Our camera team picked out some trends and product reviews for you. Munich-based Fraunhofer Institute for Technological Trend Analysis have put up their powder nozzle tech up for display. Engineer Moritz Greifsue lists out the nozzle's top features.
So that is a nozzle for additive manufacturing. The special thing actually is this little box here, which is screening the powder cone. So it's characterizing the quality of the nozzle. So we could detect, for example, if there's any abrasion or something like that, we would have to change the nozzle, because its lifetime is over, or there was some clogging or whatever.
Next, we have the Heron, an industrial robot AM cell produced by Caracol. For its production processes, the Italian 3D printer manufacturer uses extrusion 3D printing technology, designed with an approach based on applications in mind. The technology already combines over 29,000 hours of printing and has found intensive application in industries such as aerospace, automotive, energy, marine, and more. It can process a wide range of polymers and composite materials in pellet form.
The aerospace industry, we are working today mostly with molds, trimming molds, lamination molds for composites, for example, but we are also looking at functional application in the future. So we are engineering new materials to move from tooling to functional parts. That's the big bet of our company.
RevoPoint Pop 3D scanner is designed with binocular structured light and uses reverse engineering. The scanner ensures that the 3D point cloud data is on point. The highest single frame accuracy can reach up to 0.3 millimeters. This device supports both high precision and texture scanning modes, used to generate vivid 3D models for color 3D printing. The Evotech stand houses a ginormous drone, built keeping lightweight technology in focus. Lucas Meinhardt shares with us its central hallmarks.
Yeah, we got here a very interesting drone because most of the parts are 3D printed and are designed just for the 3D printing process. So you can see here, we got here a very lightweight design and it's printed with carbon fiber filament. So it's very strong and yeah, it weighs about nothing, so it can carry a huge load.
Now, on to some pointers for tomorrow's upcoming events. Make sure you do not miss these. Keep your eyes peeled for exciting presentations by partner country France in the afternoon at the AM4U stage in hall number 11. Here also, visitors can attend the Discover3D Printing Seminar, sharing knowledge about basic technology aspects of additive manufacturing. Last but not least, we have the BEAM Symposium at 10:30 a.m. at the Portal House at the Frankfurt Fair Room, Frequency 2. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Germany Trade and Invest is the economic development agency of the Federal Republic of Germany, and from the investor consulting department we support international companies setting up in Germany. We provide market information about the key industries in Germany and advice on tax and legal issues. We also have a team specialized in financing and government incentive programs for businesses, and we also analyze different locations in Germany to find the best place for the investor. And of course, all our services are free of charge. Germany is the biggest manufacturing country in the European Union and offers lots of opportunities for 3D printing companies. With its famous research institutes and universities that conduct research in 3D printing, it offers optimal conditions for startups that are developing new additive manufacturing technologies. So no wonder that already 1/4 of all additive manufacturing companies are located in Germany. We are a government company and all our services are free of charge and all inquiries from the investors are treated confidentially. If you plan to expand your business in Germany, please contact Germany Trade and Invest and also check out our webpage for more information.
Riding a motorbike you restored yourself is a unique and defining experience. Every single part of the system is important, no matter how small it is. I support the AM community with this same passion by finding and creating the best materials for functioning production concepts.
This beautiful dress in front of us. Tell us about it, the technology behind it.
All right, so what we have here is taking the polyjet technology of material jetting and applying it specifically on the fabric, directly on the textile itself. And by this, basically allowing the designer to go wide with his dreams, with his designs, doing basically give whatever they want.
How would you say does it fare in terms of sustainability? Are 3D printed clothes better for slow fashion?
Yeah, so 3D printing combined with fashion, I think, in my mind, is the next step in terms of sustainability and in terms of environmental friendliness, because this way minimize the production, everything can be localized, so no need, to start shipping things all over the world. So yeah, I think that's the next step in sustainability in fashion.
Welcome to our Formnext Afterwork Talks. Wow, we had a very impressive second day of Formnext here in Frankfurt, and we had a very impressive show here from our partner country, France, this year. And this afternoon was full packed with information, with presentation, with lectures here. And wow, now we are going to have some short wrap up here with my guests, and I'm very happy to have you guys here on stage at an evening as an after work talk. And who is here with me? Rainer Gebhardt, he's consultant, working group additive manufacturing of VDMA. And his working group is actually covering the whole AM process chain with more than 200 companies. I think that's the number.
Thank you, Frank, yes.
Christoph Eschenbrenner, he works at Dassault Systems in charge of global accounts and clusters. But here on Formnext, the most people know him, I think, as president of France Additif, a non-profit organization federating up to 180, it's right, 180 French AM actors. Maybe the one or the others coming additive there, because you are very good promoting here your France community. Perfect. And Vincenzo Belletti. Vincenzo is Director of EU Public Affairs of Ceshimo. Ceshimo is a lot of people well known as a manufacturing community in Europe. And, but you do not only cover machine tool industries, but all the manufacturing technologies as well.
Correct.
And Sven Krause, my co-host here, and he was the one who managed all the French presentations this afternoon. Sven, no, exhausting, was it?
Not exhausting at all. First of all, thank you for Christoph for organizing and enabling this session. To be honest, as a moderator, probably from the outside it seems like a lot of content, but as long as the content is interesting, and I must admit that I liked every single session of it. I mean, I'm a favorite of the startups, I must admit, but I liked it very much. Very interesting innovations, very inspiring community. Thank you so much. Was a pleasure.
Christoph, I saw that you were attending here, you were visiting as a spectator. What is your conclusion? What was your highlight, maybe?
Clearly, it's a huge event. I think everyone is very happy to be there. You are on 4 different floors. It's just amazing to see such a success. I think today was a crazy day with many visitors. And the French community was really happy to be part and to be invited this year as a French country invited in 2022. So thanks a lot for this great event. Very happy.
And from the topics that you saw here on stage, were there some topics that impressed you
the
most?
reason why we are here, so thanks to VDMA and to Ceshimo to be there, is that we want to talk about national plan for additive manufacturing.
Oh, we come to that later, but I think that was not a presentation today. I just want your personal impression. Maybe you saw one device you want to take home, or maybe you saw a new machine you never knew about before, something like that. Or were you busy with different topics? Then I won't bother you anymore.
No, you are right. Personally, I'm refurbishing a house in the south of France. And I'm looking for some specific parts that we call mouche à rabier. That's a part where you can let the flow get in the house. And I found a company here who was able to do that. printing Moucharabieh parts and to put on the building, and you can have fresh air inside.
And it's a French company? Or?
Yeah, exactly. It's a French company.
Yeah. What else?
But I did not know that before coming to Formnext.
Yeah, what else? In Europe, various national plans for additive manufacturing are ongoing currently. You said that before. And that you mentioned it when we were talking prior to this meeting here, and that is on top of European program activities. Would you please give us some insight what's going on here? Because we have a very international perspective here, not only the French perspective, but the German and the European perspective. And I want to dive a bit deeper into the international perspective later. But let's begin with this program. What is it? And tell our audience, please, what is going on here.
So I will start effectively on what we do in France and what we try to extend at European level. The idea is all of the actors, they are collectively acting to make the business growth, to extend applications. We are working with media, with exhibition company, with research centers to say how can we enhance, how we can deliver more value. And most of us, to develop this kind of activity, we need the support of public actors. So we go to local actors, to region, we go to state level, and we try to get money to raise funds to execute this different initiative. What we have done in France is that we have not only moved together at additive manufacturing level, but we have also moved with robotics, for example. You have seen a lot of robots here in this event. And we try to get in touch with the government to say, let's go and let's define a roadmap for the future. And let's try to contractualize together what we can do for the future of our country, to create jobs, to deliver sustainable solutions for Earth, and also to execute some very important R&D program to satisfy the key industry that we have, like it might be aerospace or fashion or nuclear or new system of energy. And the idea, behind that is to say we can do something at the French level, but clearly we have to face various competitors, and we think that the different actors who are close to us, they are more friends than competitors, because there is some other major markets, like the one in the US or like the one in China. And approximately in March this year, there was Joe Biden who has launched a plan called Forward AM. It's a huge national plan at the United States level, so with much more usage, much more money, much more actors, and a different method also. And the idea is to have an open discussion together with my friend from Sesimo and friends from VDMA to say, but you are a lot of skills around Europe activities based on what you do every day for Sesimo, and yourself, you have done already in the past some activities around the national plan for additive manufacturing in Germany.
Okay, Christoph.
And it's to draw that for the future together.
To drive that forward.
And next year we'll be on stage at Formnext to say we have done it.
Yeah. Okay. we are going step by step. First, I want to understand when you're talking about such a program. Let's begin with the program in France.
Yeah.
What is the content of that program? So, do you give money to universities? Is that the program, or are you, is it a kind of substantial growth for small companies, or what are the topics?
What we have defined is 7 different actions.
Okay.
We have 3 actions that are targeting demand, 3 actions are targeting offer, and 1 action is based on skills. So the 3 first action is to say how can we detect more usages. So we do various initiatives on the field to say maybe we have to make this bottle.
That would be like marketing. Marketing, like showing applications, show the users what they can do.
Needs, identifying needs. You have a problem, maybe we have a solution. We don't know yet, but maybe we have one. So it's just to open new ideas, new territories. The second action is to say if you detect something that may make sense with additive manufacturing, there will be probably some efforts. So you need to purchase a machine, or you need to go to a research center to do a specific process, or you need to have a specific material. So how do we get some resources to enhance this effort and to fund it. And the third one is to say we need to work closely with industrials, and we need research and technical center to be able to deliver these promises on the field. So this is a free action targeting demand. Targeting the offer, we have defined that the actors on the French market are too small, and they are not enough on the export market. So how can we help these actors, you have seen some of them today, to accelerate, so to go out of France and to develop and grow. Second action, you want to ask?
Yeah, no, it's okay. Tell us the second action.
So second action on the offer is to say we need to have workshop. So this is the actors who are making parts for others. And this workshop has to be at the same level as the others. So how these companies can have various sites, how can they cover different processes, how can have the right skills to address the market. And the third action targeting the demand, the offer, sorry, is to get an industrial, a large group, who will say, I make the choice of additive manufacturing, but also the choice of a French customer. So it's really a challenge. You know that here in Germany, you had BMW who did something excellent. Maybe you will talk about it here with different actors to show what you can do at industrial level with additive manufacturing. So we asked to the actors who are in France, let's do it together and let's show what might be the future. And the last element, that is number 7 in terms of action, is how do we work with the universities, all the engineering schools, etc., to get the right skill at the right level and to get maybe 5,000 people trained on a very short time of period. General managers, salespeople, research people, sales guys, etc. All the different actors that we need to support the course. So we have presented that to the government, and they have said, okay, let's go, let's move forward together. We will help you depending on these different targets that we have, and we will raise funds for that publicly, but let's do things progressively together. That's
okay, that sounds like an awful, an awesome program. Is there something similar in Germany, Rainer?
Sure, I think the points you mentioned, Christoph, the targets are very similar. We have our group of these about 200 companies you mentioned, really representing the whole process chain, because this is a very important point to be successful with the technology, bring together all involved parties and to show what is necessary to realize a good AM product. And okay, within the VDMA, the Mechanical Engineering Federation, we have also the possibility to be directly in touch with different branches, industries, and their needs. So nobody wants to use AM because AM is so beautiful, but for the industrial use, and this is our aim, we started 10 years before. Industrialization of additive manufacturing means really to use it where it is sensible, helpful, to have the best solution for your challenge, the industrial challenge. Yeah. And for this we have similar points to look at. But you asked for national initiatives. I think one point is we started just last year with this education point, because the signal was from the industry, different companies, very interesting, but who knows how to use AM? Who knows the details about the understanding the mindset and also to find out, is it freedom of design, or is it perhaps to use it in a special business case, flexibility, print on demand or print on site, all these different aspects, and you need these experts who understand what's behind, because sometimes it's good really to copy, many cases not to copy a conventional part, and so on. So education is really something we need, and what we see is there are many offers, but who really uses it? That's the point,
You recently contributed a strategy position paper to strengthen the German market, is that right?
Yeah.
Got that? And And what were the key insights here? How to strengthen the German market? We have, and remember, we have a guy from the European, with a European perspective. But that's the first step. We are talking about the French market, we're talking about the German market, and then we are looking at the European market, and then we will be bigger until we are with Elon Musk on Mars, okay? But first, or second, what's with the German market? How to strengthen the German market? What are the findings of your strategy paper?
Yeah, okay. One point is really that we are in Germany with our federation, but to be honest, we are open for the European companies. So we are not in this way only focused on German markets. This point with the education, it is important to have an overview.
Sorry when I interrupt you. That was one finding of your strategy paper, the education.
Education, really. And digitalization is surely also something. Is it really a national initiative? No, it's you do it together in the whole market, everybody who is involved. And what we learned is there are so many players in the European market, and you need the cooperation of these players to be successful with this. And then this growing market, to enter in the different markets, in the different industries, is another point. If Frank, you are invited to come up to the first floor here. We invited our companies, and I think this is also something very important.
I would send my camera team.
Please do it.
I'm busy here, but I can send a camera team to you.
To show what is realized up to now with additive manufacturing in industrial use, not only also to show what is done in research, but really parts which are produced for industrial daily use and for doing business.
Yeah. You mentioned one very important aspect. Don't forget about it. Ask me later in some minutes. The growth, how to accelerate the growth. We come back to that later. But I want to get in our talk the European perspective. Now we have here two very nice guys sitting, and they obviously are working together here. We have one of these guys as partner country here. But from the European perspective, when you're looking at politics, it always sounds like, hey, when Germany and France are going together, then everything will be fine in Europe. Is it the same here?
Well, I would say that most of the topics that they mentioned are also the ones that we are covering at the European level. Education, definitely, we are part of a European project that is actually looking at the skills gap within the AM sector. But I think I would say that the action that we are carrying on since now several years, it's the one of information, because there are a lot of misconceptions about additive manufacturing, especially when it comes to policymakers. We have every year, I think, a meeting with the different policymakers asking us all sorts of different questions regarding additive manufacturing. What if I buy a 3D printer and I want to 3D print a car? I just go buy a scanner and then a 3D printer, and then I will be able to do it.
Nice
and
approach.
Then, yes, exactly. So nice business model as well.
I like it.
But and we are there exactly to connect them with the fact, with the reality, with the concrete example from national associations, but also directly from companies, and showing them that what's the reality, where is this technology today, and where can it go, actually. I think that's our let's say core business. It has been our core business so far, because let's say there have been many topics that have taken up the attention too fast from the policymakers' point of view, and they have overlooked maybe the benefits and all the beautiful application that we can see, for instance, today.
But that's our job, Sven. Huh?
Yeah,
honestly,
doing
information.
My experience, I mean, I'm accompanying the sector quite a while, and what I see when I talk to people outside our industry, that, as you said, there's a total misunderstanding most of the time. And my question would be to you, I mean, I know you mentioned there are programs in place, but nobody knows about them. Is it a marketing topic? Because the thing is, especially if it comes to education and future employees in our industry, you have a competition, right? I mean, we have a lack of skilled people. We have so many industries that are searching for them. What should attract them in additive manufacturing? That's the first question, probably for you. Is that included in your programs to attract them? First point. And second, adding the factor that you just mentioned, if they don't even understand correctly the industry, what can we do then? Or is the main topic marketing then? Is that?
Well, so in terms of attracting, let's say, new workforce in the sector, I think with this project we have seen that certain areas, let's say, have been more successful than others. So we have recently launched a course for AM metal coordinator. We had many let's say, participants, while others were less successful. So therefore, probably it depends very much on what aspects of the sector we are dealing with.
I asked the question here on the stage, I don't know, yesterday or this morning. Do you bring the machine vendors from your classical subtractive business, which are producing hybrid machines? Do you bring them as Sesimo here to an exhibition like Formnext?
Well, no.
But wouldn't be that one action to get a bit more a step ahead?
Let's say we try absolutely to make the connection between the two words.
So you have the EMO in Hanover and the EMO in Milano, and maybe it would be good to make a hall. Just I'm right now selling some. I want to have some salary here, but you can bring all this machinery industry to the AM community in combining them. I think it's a lot of getting people in connection.
So the idea when we created the AM group within Sesimo was exactly this. So to make our machine tool manufacturers and the AM manufacturers finding their points of let's say the common points, the common grounds where to cooperate, but also how to complement each other's work. Within EMO, we do have exhibitions dedicated to 3D printing, additive manufacturing, many companies are participating. Next year in Hanover, we will have one hall dedicated only to additive manufacturing. So definitely, it's something that we are working on. Today, no. Today here in Formnext, we are not present with the booth. Most probably, that will happen.
Okay, we write down next year.
Next year, yeah. But it is definitely something that we are looking. We are trying to inform our national associations as well. We worked actually together on a report sponsored by the European Commission on the use of 3D printing for machine tools. And so we looked into this report and how this technology could be used by machine tool manufacturers.
Okay, now we talked about a bit the chances we might have in cooperation and some methods how to solve the problem. And China, as a word, was here in our round already. I want to focus a little bit on that topic. Where are the obstacles that might come? Is there a competition internationally? We had American guys here. They were saying with a smiling face, "Oh, you European are a bit behind with digitalization and try and error methods." We already discussed it. I had your colleague, Mr. Hering, today this morning here, and he said we want to do it in our German and engineering way we used to, and it's a better way. So there is a kind of competition between US and German or European way in doing it. But what's with the Chinese market and with the Chinese, push coming out of this strong development over there?
Yeah,
Christoph.
Yeah, I think for China it's different. I think, but at least for the United States, the key factor is that's their president who is speaking. I think that's what is missing at European level. Is there at the top level, It's Joe Biden. He said, let's go to additive manufacturing because we want to localize activity and to be more dependent of China. So he cleared on something. He said to everyone, if you have a major actors, you need to place order locally. Your research center, you need to work with SMBs and with solution company to have some solution. And everyone has to commit. And I will give money if yourself you commit, and if the major actor who will place order commit also. So I think this commitment, we don't have it at European level today. So there is programs in Germany, there is one in France, there is different actors. We talk when we are with Sesimo or what the European Commission is doing. But at the top level, there's no global message. And I think really that's the challenge for us, is to say, and that's the right place to talk together, because we are all together at Formnext, to say, let's do it differently. Let's think about what is working well in the US, and let's try to duplicate. And that's why I said it's a good target for the next 6 months or 9 months, and to get someone from maybe the president of European level coming to Formnext to say, we launch a European plan for national additive manufacturing to localize our activities, to deliver new solutions, and to execute a program.
So we have to
that's
invite
clearly
Mrs.
the idea to talk
We have to
together.
invite Mrs. von der Leyen to come here.
Clearly.
Okay. Yeah, we'll do so.
That's the challenge.
This is really a proposal that I highly
clearly, I open the
appreciate.
discussion
And
on
I tell
this.
you what, I mean, when I think how I entered this industry, I was shown a model of the Kölner Dom from my brother-in-law, who was working at AOS at that time, and it was the size of the thumb, and it has all stairs, everything included in this size. So once I've seen that, I was addicted right away. And I think if you want to have European politicians, especially in the European Commission, to force it and to stand behind it, I think they need to get familiar with that. I remember Angela Merkel once visited several additive manufacturing exhibitions and got close to it, and she is an engineer, so she was addicted right away. So I think we need to bring that together. So bring them over to Formnext, best place to be, and show them application. I think application is the key to get infected.
Okay, I totally agree. But I wanted to switch to another aspect of the internationalization, because US is kind of a competitor. You mentioned Biden is announcing some sort of
acceleration
American
first
program, but they are partners as well.
Yeah,
and
for sure.
it's the same in China. How to find the middle way? I think I find it very, very difficult to find the middle way between China or the big markets, let's say. There are different others in the world as well, Japan and others. So not only always to mention China and US, but they are the most biggest one. Rainer, how to find the middle way in cooperation and going in frontation?
I think to have a competitive situation is always good. It's a healthy situation because you have to push your business, you have to push your technology, you have to be in front of the others. So this is a good situation. The point is, if there are, and this is, you mentioned our strategy paper, to have fairly competition, and that's what we would like to have. Surely, not something which is supported in a country a very strong way, and you
how to get that.
So it's really to have a view on the situation, what means the business between the countries, and to have no regulation which stops our business and pushes the Chinese, the Asian
but
business.
We have the associations here, Sesimo, VDMA, and France Additive. You are a very loud voice. You can say, okay, we need that more.
Yeah, but the point is perhaps one example I think we didn't mention up to now, this work at standardization.
Okay.
Which is an international platform, surely, and especially the Asian, the Chinese companies are very active, also the US, and our impression is in Europe, it's not always in a similar way. Yeah?
Very interesting
we
point.
have
Standardization. It's a sharp
push
sword,
it more.
isn't it? It can be a sharp sword. Standardization.
Yeah.
What is your about the idea? Do we need more cooperation in standardization?
Yeah, I think so. Effective standardization is one point. Working on certification also. So it's another way to address this topic is to say, do we have the right skills? Do we train the people on the right things? Do we change mindset? And do we have people with the right skills certified? So we know when they make something for medical implant, that they can implant it effectively. They do it for a rocket, they do it for a nuclear plant, but they have the right certification. So you know, these aspects are key to accelerate. And on your question, I think effectively Europe, China and the United States, they are partners. Myself, I work for Dassault Systèmes. We sell solutions worldwide. So it's not a matter to have this different competition, but it's just to say additive manufacturing is a way to build the future. It's a way to localize activity, to reduce the impact of economy on the planet. So clearly, we have to develop it. It would be a shame if we make additive manufacturing part in China to put that on a cargo or in a plane to use it in Europe. It's a nonsense. So that's why we have to move. If we do not move, what will happen? We will make parts in China or in the US, and we put that in a plane to consume in Europe. So let's move together and build the future, and we will work with them also. It's not a problem. Yeah. But at least we will be at the same level.
But as Frank mentioned, a question to you on a European level, yeah, is it sometimes frustrating seeing how fast US and China could go as they, in my impression, somehow can set a new standardization right away and go ahead, especially medical? How long does it take for a startup to raise an idea here in Europe due to regulation in the States, and China, it's right there. So how does that feel, and what do you do about it?
We have we have this frustration, absolutely. The solution is actually we have to develop something that is in between, as we were saying, the approach in the US and in China, because for sure their approach wouldn't work in our market. For standardization, for us, for instance, would be to one suggestion that at least we have made to the Commission, it would be to start helping smaller companies to attend these meetings, even funding some of the flights, even their attendance to this kind of standardization discussion. When it comes to speed, unfortunately, we have this type of methodology, I would say, that is not gonna change. What we can change is the approach in which we bring AM to the let's say to the market, and that, for instance, can be done with an AM initiative. The real issue in general that we have had in Europe, that we have moved always too late. We have discussed it before also with Rainer. We are getting there 10 years, 20 years later. Now we are doing the solar panel initiative in Europe. When we are definitely not market leader, we should have done it 10 years ago. We are doing the battery initiative when we have implemented the strategy for electric mobility that is in full speed like now. And most probably with this kind of pace, we will develop an AM strategy in 30 years when we are importing parts from China, as you were saying. So we, as association, we need to flag this, and we will continue to flag this, maybe even as you did, to develop steps on or exactly what they need to do, because otherwise this won't come from the other side. So for sure.
My impression is that Christoph brought to us a good concept, and it sounded like a comprehensive concept, and that could be the way to take parts to Germany, to take parts to cover it as a whole in Europe, and maybe we have Mrs. von der Leyen next year here on stage, who can announce that we are going fast forward in that. I'm looking at our time scale. We have a bit time left, but not much. So I just want a quick answer from you four guys here. looking at the third show day tomorrow. But I want to have a personal view, not your view as a professionals, just your personal view. What will you do tomorrow morning as first? What is your first, step into the exhibition? What will you look at through your personal eyes?
As an exhibitor, I have to start at our booth, and my first view is, so many nice and beautiful examples for successful additive manufacturing. We have to push it and to show it to the industry. That's really amazing for me as a mechanical engineer, and I like it very much.
Christoph, what would be your first impression here? You mentioned already for your house in South France.
So I will visit another startup for the French actors that is called Lattice Medical. They won the prize from Formnext, and they are implementing artificial breast made by additive manufacturing. So I will go and congratulate them because they get a prize, and it's a very good example of what we can do, how we can change life with additive manufacturing.
Vincenzo, what will be your first step?
Yep. Besides the meeting that I have scheduled, I want to look for a pair of 3D printed glasses because that's my next purchase for sure.
So maybe you have a look at the Ukraine donation action. There are some of these 3D printed eyeglasses, sunglasses, and maybe you can donate there and win one of these glasses. Sven?
Excellent.
I don't have to ask you, or do you want to have an answer for me?
Tomorrow with Marcus together tomorrow, so I'm looking forward to the stage because we have a wonderful program again, super interesting. And I hope I find some time to walk a little bit about the fair because so many friends I haven't seen.
Exactly.
And so many amazing things I just saw by walking by, so I think it won't be boring, that's for sure.
True.
That sounds really good. So thank you very much, you four guys here with me on stage, for your insights, for the discussion, for the good ideas you brought to us. And thank you very much, dear audience out there and dear audience here at the booth. We see you tomorrow in the morning. We are starting on time at 9 o'clock for the third day of Formnext 2022 here in Frankfurt. And my last word is, stay tuned.
Thank you.
Joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.